Hey, hey, hey. Welcome everybody to our .NET Day Online 2023. This is the 5th year already. I just talked with Martin in the backstage room. Unbelievable. Time passes.
Martin, yeah, so it's kind of an anniversary. Yeah, welcome from my side as well. If you're in the chat, I'm actually really curious to hear who is here for the 5th time as well, who has been joining all of our events. If you have been here or if you haven't been here, we try to do something different every year. So I think in the first year, we started streaming just one day. Then we switched to 2 days because there were so many good sessions. This year, we decided to actually do 1 day, but make the day a little bit longer. So apologies to anyone in a time zone that is not super friendly in overlap with where we are streaming from. It's going to be a long day, but it's going to be a fantastic day as well. Not sure, Matthias, if you want to go over the agenda a little bit.
Oh yeah, and I just wanted to say it's so hard picking sessions for this every year. Yeah, but yeah, let's roll it with our agenda for this year. So this is our wonderful website. So Martin, you gonna start with the first one?
Yeah, I'll start with the first one. So our first speaker is going to be James, who will be recreating Wolfenstein 3D in F#. I don't think this is something that a lot of people will be doing, but it sounds like something super interesting to look at and to see how it's been done and how all of that works, how raycasters work, how rasterization works, and things like that. So I'm actually, if you would ask me what session are you looking forward to, the first session is definitely one that I want to see.
This is definitely a good introduction for our streaming on Twitch also. Second talk we're gonna have Laila talking about how to effectively spy on your system. I didn't know she was an agent. So this will have great bits about telemetry, and yeah, very looking forward to this talk as well. Just like the next one, but that's yours to take again.
Yeah, next one is kind of related, where the spying is going to be automated with some Roslyn source generators, which should be cool. I think I've been looking at OpenTelemetry myself, and it's always a little bit of a hassle to add to all of your projects. So I think if you can automate that with source generators, is definitely something that's going to be interesting. So actually also looking forward to that one. I'm actually looking forward to all of the talks.
Just like the next one, and I'm not surprised, I have to say. Giorgi is talking about beyond relational with entity frameworks. So he has a couple of other projects, or at least one, which is really popular in the working with entity framework. And yeah, let's see what this is going to show us.
Yeah, next one is understanding microservices, which is definitely something that a lot of people will be interested in. Myself as well. I always think of microservices as being monolithic, but just distributed on different machines. So looking forward to what Layla has to say about that. Yeah, and the next talk as well, super excited about that one because, yeah, Matthias, you want to go for that one?
We had Mike before already on together with, I forgot the name just in this moment, but we had him before, and he's one of the leading people in the Avalonia UI project. Meanwhile, they have great support for Rider. He's going to talk about it, cross-platform development. So yeah, this is the person you want to hear talking about Avalonia, I'm sure.
Yeah, next talk is going to be mind-blowing, I think. So Andrii is going to join us and talk about how he implemented part of the debugger, or I think the entire debugger for .NET WebAssembly apps in Rider. So lots of internals about the IDE. Again, I don't think this is something that anyone will be doing at home or in the evening or something like that. But definitely looking forward to that as well, because WebAssembly is something different from the traditional runtime. And I can imagine there's a lot of hidden difficulties there.
The next one, Ian Griffiths. Oh man, I probably said that name wrong, but he's going to talk about high-performance JSON serialization with code generation on C#11 and .NET 7. So I assume, I have no idea what this talk is going to be about, but I assume this is just, you know, to show a rapidly improved way compared to the traditional way of handling JSON, like probably Newtonsoft JSON, I believe. Yeah, I have no idea what's in the works, even more so a reason to actually watch this talk.
Good reason to stick around, indeed. Yeah, next talk as well. We traditionally have a couple of performance talks at .NET Day Online as well. So Matthew is going to talk about the fastest .NET dictionary, but written in F#. I hope, and maybe, yeah, I guess he's going to show some C# there as well, and lots of benchmarks and profiling and everything there as well.
We have two F# talks. Two F# talks. That's nice. And the last one, closing with Daniel talking about xUnit expanded beta testing with xUnit. Now, I'm a long user of xUnit, so I'm very curious if I will learn something new. I'm sure I will. You know, it has been ages since I learned about the basics and all, and yeah, definitely also stick around for that one. Okay, what's next on our list here? I removed my screen. You removed my screen.
Yeah, I removed your screen. Yeah, I just want to mention that during this day, we will also do a raffle. So we haven't traditionally been doing that in previous years. Now, in between sessions, at some random point in time, we will actually ask a question, and then the first person to respond in the chat will be able to win a license to some of our products here at JetBrains. So yeah, definitely stick around in between the sessions as well, where you can see something or win something that might be very useful to you, or you can give away to friends if you already have a license.
And I definitely hope everyone has a good ping for that. Yeah, this will be, you have to be fast. You have to be fast in this one. And stick around also, yeah.
Yeah.
Okay. Yeah, otherwise, chat, if you have questions, any questions, post them wherever you're watching from, Twitch or YouTube. We will either try to answer just by us in the chat, depending on the question, or maybe even ask the presenter live afterwards. Yeah.
Yeah, and then just before we bring in James, who is, I think, eager to start his talk as well, I just want to mention that all of the talks are recorded. So if you have to drop out for a bit or go for lunch or whatever, the stream is going to be there. You can always rewatch at the URL that you're currently at. After the event, we're also going to cut all of the videos into separate ones and publish them on YouTube. So if you want to subscribe to our channel, definitely do so, because all of the talks will be published there separately as well. And with that, James, I hope you're ready. I see
welcome, James.
Kind of a thumbs up. Yeah, let's welcome James. Hello, James. Good morning.
Hi, guys. Thanks for having me here.
F# for the win. I knew it.
That. Yeah, it comes out on special occasions.
Do you also have a suit with branded in F#?
I don't know if a T-shirt does say "Go Functional" or "Go Home." Yeah,
I'm
I was going to say it's probably one of those Superman T-shirts with the Superman logo replaced by an F#.
F#. Yeah,
those are so cool as well. Yeah.
Cool. All right. Without further ado, James, because we already are running a little bit over time, we'll give you the stage, and I'm really looking forward to seeing Wolfenstein in action there. So let's add your screen and let's remove ourselves. And yeah, good luck.
So great. Thanks, guys. As in the intro, I'm here to talk about recreating Wolfenstein in F# and .NET. It's about me, I guess. You know, I've been working in tech for a long time. I work at a company called Black Dot Solutions at the moment as the CTO. We do OSINT investigation software. Yeah, you can find me there. The code's all on GitHub, so keep note of that link. I'm currently working on a whole bunch of kind of game and crazy related stuff just for fun. You can find some of that on my GitHub, some in other places. But I don't want to dwell on that because we've got a lot to get through. 45 minutes, it's not long to talk about the range of topics I'm going to cover, and we might not get to the end of the session, so I've kind of structured this in order of what I perceive as interestingness, so I can kind of, you know, keep my eye on the time and present the interesting bits. The source code can be found at the link you can see on the screen. I wrote it, I think, 1.5 years ago, and revisited it when I started talking about it this year. It's reasonably legible, considering I didn't know what I was doing. I set off. That's quite surprising. So you can kind of pick your way through it, particularly if you've heard this talk, I hope, which will give some of the concepts behind it. And if you're more on the C# side, there's a Blazor and C# version of a renderer also in my GitHub. I didn't quite get around to implementing the AI, but it does render. And it's, again, I think it's probably a little better written than the F# one, because I knew what Wolfenstein was doing at that point. So Wolfenstein 3D, why recreate it? It was a really formative moment for me when Wolfenstein came out, and I think it was in '92. And I literally remember running around the house. I lived with my parents. I was probably in about 16, I guess, and I was running around the house, extremely excited, and screaming, "This changes everything!" Because I'd never played anything so colourful and fluid that was in 3D. And at that point, I'd already written lots of code. I was, typical sort of 8-bit bedroom code in the UK, cranking out 6502 assembler and all this kind of stuff. So I had to go writing array caster. I was like, I wonder if I could figure out how this worked. I could kind of see how it worked. So I wrote one in C on a probably a 80386, and I guess in Turbo C, which I was using at the time. But it was interminably slow. Like, it ran at no frames per second. And there was weird gaps in the textures, and there was a fisheye effect, which I now understand what was going on, but at the time I had no idea. It was interesting, and I was sort of, amazed at what the id software guys had accomplished. And in 2022, I guess that's last year, I kind of woke up one day. I thought, I have to try this again, and I really don't know why, but it was like I'd got this. I got it between, I really got this idea. I have to do this. I have to get this, understand this, and I started building it out again. So quick demo. I have to do a little bit of screen hopping in this, so hopefully I've got things set up okay so we can see it. This is it running in a browser. So I've done a browser version and a desktop version, and we'll talk a bit about that. And you can see that if you remember Wolfenstein, you probably can't hear the audio, but there's audio in here. The sort of the German guys running around, and if you played Wolfenstein back in the day, this will be extremely familiar too. So it's the gameplay is mostly there. It was great fun, and I had a whale of a time writing it. So I'm just going to refresh that to set it back to the start, so we don't get the sounds while I'm trying to talk about it. So that's it running in the browser. If we get time, we'll pop it up on the desktop later, but it looks exactly the same. So before we get into sort of how it works, there's some kind of important principles behind Wolfenstein 3D, which I knew going in, but they're really easy to forget because it's quite convincingly 3D when you're playing it. I know by modern standards, it's not this amazing graphical wonderland in a modern game, but it's still it looks and feels 3D to you as a player. It's really a 2D game. There's nothing three-dimensional about it. You can't go. There's no tunnels underneath things. It's strictly on a 2D grid. And in fact, the id Software guys, as I understand it, used their 2D level editor from things like Commander Keen and their previous games, if you remember that sort of time period, to do the level design for Wolfenstein 3D, which was a tile map editor. So it's strictly 2D, and everything is on a grid, including the way the enemies move, which I didn't quite realize when I started, which was quite made for an interesting moment or two. And if you want to look at the source is online, and it's pretty readable. It's pretty. I started life as a C developer in my professional life, and it's pretty readable as a C code base. It's got some cunning tricks in it in places, which can make those bits a little bit obscure, but it's pretty readable. So there's some sort of important principles. This is just a view of the grid. So this is the first level of Wolfenstein in a sort of level editor. When I was developing this, I used Maphead 42, which runs in DOSBox on my Mac. It's an old, goodness knows when it was written, but it lets you inspect the levels, edit the levels if you want to edit the levels. I was really just inspecting the levels. But you can see it's strictly grid-based, and if you see my cursor on the screen, the cyan G, that's a guard, and there's plants, and the player is there, or there rather. I forget which one there. That's the player. It's strictly grid based. The whole game works like that. And that's what allows it to work so quickly, as we'll see as we get into it, and how it works so well on low spec kit. By modern standards, it was quite high spec at the time. I didn't plan it as such. I didn't sort of, which is probably a bit silly, really. But I didn't sit there and think this is how I'm going to build this thing. But I just sort of thought, I'll get this thing going without textures. I'll get a plain view of a raycaster working without textures. I'll add some textures and see if I can figure out what went wrong last time I did it. Then I'll get the Wolfenstein graphics and maps loading, and hopefully they then just drop into my raycaster, and then I'll add the enemies and the AI and things like that. Which was fine, and that worked quite well. It was quite exploratory, but I didn't know anything about raycasters. I didn't really know how Wolfenstein worked as a game other than as a player. So a sort of exploratory approach seemed reasonably sensible to me. About halfway through, I thought, oh, it'd be fun if this runs in .NET on the desktop, as well as in the browser. So in the browser, it's using Fable, which is an F# to JavaScript transpiler. So in the browser, it's running using Fable to create JavaScript from the F#, and it's rendering to the canvas. In the .NET desktop version, it's running in .NET. I think it's .NET 6, it might be 7, perhaps. It doesn't really matter. It's a fairly recent .NET, cross-platform .NET, and it uses Silk as an interface to the graphics hardware, and we'll come to that a little bit later, hopefully. I don't think I referenced any source code until I got to the AI, but I was definitely looking at other raycasters. So there's a few JavaScript ones out there. There's I don't think I came across a .NET one, but I could be wrong. But there's a whole bunch of people writing simple raycasters that you can go and have a look at, and that helped me figure out some of the concepts behind how they worked. So raycasting, I've used that word a lot. So what is it? Essentially, if you think about the view of Wolfenstein we're looking at, we've got a rectangle on the screen. And for every column of our viewport, we're going to draw a line from the player, from us, to that viewport, and see if we intersect anything. So we'll cast a ray. And for example, if our screen size is 320 by 256, and people who are my age or older will remember why I'm using that resolution. But if our viewport is 320 by 256, actually, is it 256? It doesn't matter. I'll have 320 rays to cast across, one for each column of our display. So we cast those rays across, and we're looking for collisions with a wall. And we'll forget about enemies for a minute and just think about wall collisions to get the wall collisions working. So how do we cast the ray? How do we actually shoot a ray across our viewport? Like, the obvious way to do it, the sort of naive way to do it, is to break the line down into lots of small sections and walk along it, and testing at each point if we've hit one of our walls being these squares, these cubes, because it's on a grid. And they're not lines, they're actual cubes. The problem with this approach, though, is that you can miss a wall, you could step over a wall. And one fix to that would be to make increasingly tiny steps. And you could probably make them so small that if you ever missed a wall, it wouldn't really matter. It'd be right on, be right on an edge case. You'd probably get a bit of flickering, but the cost would be really high. You're going to have to start making lots and lots of these tiny steps each time for each line across your screen, each column across your screen. So that's not a good way to go. So what you can do instead is think of your map like another sort of 2D canvas, and draw a line across it using a line drawing algorithm. And this will really start to make ray tracing make sense to me. Until I got this in my head, that I was drawing a line, thinking of a map as a set of pixels almost. I find it quite difficult to get this in my head. But once I realized I was drawing a line, it started to make sense to me. And if you draw a line onto a 2D, if you've ever done any kind of primitive graphics work and you're drawing a line, you've got your array, your pixels, which you think of this as a set of pixels. You start here, and if you're drawing a line in this angle, you don't draw this smooth line. You're drawing this pixelated step-based line. And that's, if we draw arrays like that, we can't miss anything. Eventually, we will hit we'll hit a grid element with something in it, and we can decide what to do. Once we've hit the grid element, we can backtrack from the element we've hit and figure out where we hit it. And that makes this, many times cheaper than the series of steps to do, and it's also accurate, which is quite important unless you want a crazy display. You could use, in theory, I guess, any line drawing algorithm for this, of which there are many. And if you do sort of a Google for line drawing algorithms, you'll find many, and there's many interesting ones. Some deal with aliasing, some don't. It's one of those rabbit holes you can go down. It turns out the line drawing algorithm I was familiar with before I came into this was Bresnum, which I'd used previously. But when I looked at the raycasters, that are out there and the sort of literature on them, most people were using something called digital differential analysis, or DDA, which sounds horrifically complicated, but isn't that complicated, again, once you get your head around it. But in any case, it was this kind of low resolution line analogy that made sense of it for me. I was like, oh, I get this now. Okay, I see how this works. I suspect when I did this back in '92, I probably did a series of little steps. That would have been pre-internet and pre-being able to kind of research this stuff easily. Obviously, this is quite easy to do these days. Actually, I find DDA easy to explore from pseudocode, but essentially what you do is let's just look at the pseudocode. I find it much simpler to explain through pseudocode. You figure out your initial distance to the next X point and your initial distance to the next Y point from where you are now. And then you start tracking the total distance that you've traveled X and Y. And essentially what you do is you walk along one axis until you've traveled further than you have in the other axis. And then you swap it around and start walking in the other axis. And each time you swap it round, you've moved along an entire element in the grid on that axis. And you can see that in the pseudocode here, I hope. There's our sort of initial distance to the X and Y. Actually, if I just go back a slide, this diagram would be helpful. The initial distance to here. We load that up there into a total distance. And then we do this. Let's move to the next X. Let's move to the delta distance X is the distance to the next X point, to the next X point. And at some point, we'll have traveled further in the X distance than we have in the Y distance, and we flip it around. And then that will start stepping up. So you'll go step, step, step across, step, step, step up, step, step, step across. In general, you're going step, step across, step up. Depends on the steepness of the line. And that's essentially how you cast the line, cast a ray. And you just keep doing that until you hit a wall. Once we've hit a wall, we need to figure out how high the wall is to display. So you think about the sort of Wolfenstein view, we need the sense of perspective. Further away things are, the smaller they are. So we need to calculate that height. This is the thing that tripped me up the first time I did this back in '92. I was measuring this distance here to the wall, which is kind of intuitive. Here's the player, here's the distance to the wall. We use that to calculate the height. But that results, as you move out, that results in a strange fisheye effect. So what you actually do is calculate the perpendicular distance from the camera plane to that point. So the right angled distance from the camera plane to that point, and that gives you the flat, gives it nice and flat for you. Which was quite interesting to me. I'd figured out why I got this wrong in '92, at least. I don't have the code anymore. It was on a floppy somewhere, but why I thought I got this wrong in 1992. So with all that out of the way, we can look at some code, and hopefully I've got this racked up good to go in Rider, which I'm on a Mac, so I've been using Rider for some time. The bulk of it is in this render scene method, and you can see here a sort of F# implementation of that pseudocode. So I talked about walking across across our viewport. So we're using a HTML canvas. It's got, it's as wide as it is as I've defined it in HTML. So we walk across that canvas from column 0 to column 1. And for each, let's get to the bit that I want to talk about. For each, we basically have variables, so there's a delta distance X, the thing I was talking about earlier. We set up our step X and step Y. You need to track, I'll come back to that later, but you need to track which direction you're moving in, basically, so you can add the if you're going to the left, you want to add -1 on. If you're going to the right, add 1 on X, for example, and top and bottom is the same with Y. So we just need a sense of that to move the map on the right direction. And finally, we get to our DDA algorithm. So this is the thing where we basically just go on forever until we hit a condition. So we use a scan. There's a lot of scanning and folding in this to kind of take those loops and put them into a functional fashion. I did try to keep this in a somewhat functional style. I think there's a couple of bits that aren't quite so functional, but most of it came across quite nicely as a functional style, but it did require a little bit of sort of mind bending in places, because most of it, if you see pseudocode written down or you think about it, it tends to be in a more sort of procedural kind of way. But I tried to do this as an F# project, as a functional project. So, but this is the implementation of a pseudocode. We're basically just feeding into the scan our initial distances, and then we start walking through, flipping around as we go, X and Y, until we hit. And when we hit something, we then, and the hit is here, if we hit something, the cell's not empty on the map, we exit the loop. We've had a collision. In this sort of setup I have here, you can never not get a collision. So there's no sort of sense of, have I escaped the map? You can't escape the map. It's always, you always have a collision. It doesn't deal with unbounded maps. Once we've got that, we need to calculate the perpendicular wall distance, and then we draw a line. So what does this look like? I just need to go into my browser. Just give me 1 second, make sure I have the right thing running. Should be on. So if you've not used Fable before, this is the sort of, that's the transpilation step, and it'll watch the code, and like most of these things, like if you're using TypeScript, for example, it'll track your changes and recompile the code as you go. But here's our simple raycaster, and you can see I can walk around it. It's quite smooth, but it's it's pretty uncolored. It's pretty basic, really, but it's a functional raycaster. So that's that up and running, which is great as far as it goes. I just want to add one other thing as well. You can see, let me just find the right line here. At this point, I'm just using, I'm just drawing vertical lines with a given color based on the map cell. Pardon me. And I'm also tracking what side of the cube I'm on, and if I'm on the far side, I color it one lighter. There's a light and dark going on. But the thing I just want to note is that at this point, I'm not actually, I'm not actually using like a byte array or anything. I'm using the canvas functions to write out the to draw the lines. And that's not what I wanted to do ultimately. Ultimately, I wanted to do basically use a byte array, do it as it would have been done back in '92, which is write the bytes that represent the screen out directly. So when I came to add textures, which is the next step, I made a change to make it not use things like draw line in HTML canvas, but instead get the underlying pixel data, which is essentially a byte array that I mostly look at as a uint 32 array, RGBA, red, green, blue, alpha, and each of those is 0 to 255. Each of those color components is a byte. It can be quite convenient just to think of it as a set of bytes. From a texture point of view, we've got a texture with some color on it. We want to put the same color on the screen. We don't need to copy all 4 bytes at a time in code. We can just take the 4-byte representation and move it over. So that's the sort of move to the byte array, and we can take a quick look at that. Then the other thing we need to do to add textures is figure out where we've hit in the grid. So it doesn't really matter for the color. If we've hit a wall and the wall is of uniform color, it doesn't really matter where we hit on that wall. we're always going to draw the same color. But if you're going to draw a texture, we need to know where, what slice of the texture, and the texture being, a little graphic, a little sprite graphic, and we need to know which slice of the texture to put in that column. So there's a little bit more, maths involved to figure that out. And once we figured that out, we simply scale the source image to the right height. So, like an image resize essentially. So my next step was essentially doing these textures. The flow got a bit more complicated here. Previously, I just had a canvas and I was sort of blatting stuff to it. But now I've got various images in play, and I'm doing more complicated things with the canvas. So the flow became a bit like this. We get image data. So there's two textures, a blue wall and a grey wall, very familiar walls to Wolfenstein players. We get the image data from them and load it into a texture object. And the texture object is pretty simple. Again, it's just a byte array essentially, or uint32 array with some metadata. And every time we render, then when we begin a render, we get the image data from the canvas. So in the canvas, you can get the underlying image data out of it. And when I do this in .NET, I do exactly the same. I just create a byte array, a uint32 array, and use that as a texture. But we'll come to that later if you have time. I then essentially render these colors into that byte array. And when I've rendered filled the byte array, done every single column, I output that back to the canvas, and I set the underlying pixel data in the canvas. Hopefully that makes sense. Obviously it's using the browser and it's using F#, but I was trying to do this in a way that was similar to the kind of approach you would take back in '92. Again, the source of this you can find in GitHub. I sort of broke out. I didn't keep track of these as I went, but when I realized it was of interest to people, I kind of broke out the steps. So there is a quick example of that. Bear with me to open a different solution. Originally, I had all these open at once, and it was just too confusing. So I moved to having it in this model. It's, again, the bulk of the interesting codes in this render method. It's the bit that's been added here. The bit up to here is all the same as what we were just looking at. But then we start to figure out where... if it's a color, we just draw a line still, but that's not actually in use in this. If the map cell is a texture, if it has a texture, essentially we, again here, find where our texture position is, and that's this here, let texture X. We're going to find the texture position. We get the texture that is represented by the wall, and then we basically go and use the column in the texture to output that texture, copy the bytes across to the canvas, and you can see this no longer uses a vertical line. It's using the set pixel method, which if I go to, is setting a uint32 array, a JavaScript uint32 array, setting an entry in that array. So it's largely the same. There's some work to load the textures. You can see here. It's not that interesting, really, that code. But again, if I just go to stop this one and run this one. We can run that, and hopefully, yeah, we've got a. So it starts to look a bit more like Wolfenstein. So exactly the same principles before. The only thing we've changed is that we're now rendering these textures and finding the columns, etc. And again, the textures in Wolfenstein, the walls in Wolfenstein, if you look, they have these light and dark. It's just based on the side of the cube that you've hit. And you'll see me tracking side in that code, and that's what that's about. Which side of the cube are we on, and which are light or dark texture. I wouldn't be certain I've actually got it the same way around as Wolfenstein. I think I have, but I think I have. But it's possible I haven't. I'll skip over this. If you load up the I will skip over this. Well, it's running. This is the C# version I built in a little, again, when I knew people were interested in this and wanted to talk about it. The C# version has a little mode you can switch it into that shows the rendering process, shows it casting arrays and hitting things. So that can be quite sort of fun to explore. And this is just a YouTube video I captured from that process. It's not in the F# version, but it is in the C# version, and it's quite interesting to watch, and you can start to understand how it's actually rendering things. You can speed it up and slow it down, so you can see the detail or just let it go. So essentially, that's the raycaster that's running in Wolfenstein. So that small one is, if you were to look in the Wolfenstein code base, which we will shortly, it's basically the same raycaster. It's kind of been abstracted out a little bit. So it turns out that casting arrays is generally useful. It's used, for example, for enemy bullets, and it's used for collision detection. So it's been rendered away a little bit, abstracted away a little bit. And if you want to look at the actual raycaster, it's in that file there. But it's really the thing we were just looking at minus any rendering. So it just produces the outputs, and then you can do things with them. And again, you can find, we won't look at the raycaster again because there's other bits and pieces to look at to get kind of complete Wolfenstein, but the raycaster, the renderer for the raycaster using the abstracted ray code can be found in render.fs, which is actually where most of the rendering code is for just about everything. So at that point, I had my Wolfenstein sort of maps running, and I was feeling quite pleased by that. I felt a little bit smug. I wouldn't have felt so smug if I realized how hard the next bits were going to be. But at the time, I felt quite smug. I also at that point wasn't like loading the Wolfenstein graphics properly. I was just I just essentially captured two of them and converted them to PNGs, I think, and was kind of just doing it in a pretty primitive way. So the next thing I needed to do was get objects and enemies appearing. So not necessarily even animating them, but just having those things appear on the screen would make the worlds a lot more interesting. Wolfenstein, again, it's a 2D game, so all the objects that you see in Wolfenstein are 2D sprites, and you can see it if you move around things. They don't, some things don't rotate at all; they just kind of stay facing you all the time, and other things rotate in steps. They don't rotate smoothly like you would see in a modern 3D game where everything is actually in 3D. So simple 2D sprites. To draw them kind of in the right order so that they kind of they block each other out. If there's an enemy guard in front of a health pack, we draw them in the right or in depth sorted order. So we maintain them in a depth sorted order relative to the player. We want the things further behind to be behind things that are nearer to the player. So we maintain the sprites in a depth sorted order. And then again, this was a little bit complicated for me to get my head around at the time. But the other thing we also do, we don't want, sorry, I'm mumbling a little bit. We don't want enemies to show through walls. We want to clip them, and we need to clip them really cleanly so that if you have a wall, you're on a corner, you can perhaps only see part of the enemy. So we need to clip them. And the way we do that is we essentially extend the raycaster a little bit to capture the depth from the player on each column on the screen. So we make as we draw our screen, we essentially draw all the walls first. And as we draw the walls, we say this wall is 200 units from the player. This one is 201 units from the player, 202 units from the player, and we use that depth then to clip the enemy. Which we'll see in a moment. Before we look at that, I mentioned some sprites moved in steps. Sorry, some sprites kind of animate in steps rather than just facing you. I call them orientable sprites. It might be something I picked up from somebody else talking about Wolfenstein, but I've called them orientable sprites. And each of a sort of orientable sprites, which is basically the enemies, have this kind of format you can see on the screen here, where each part of their animation is done in a different direction, 8 directions, so they can face in one of 8 directions, and there's 5 animation frames or whatever it is for each direction they can face. So then you need to think about which direction these sprites are facing relative to the player. And this is where my head started to explode. This is where my smugness evaporated because this really hurt my brain. I kind of was struggling to visualize it. But fortunately, we can talk about this a little bit more in a second. Yeah, you need, if you're facing a player and the player's facing you, that's easy. But if they're facing west and you're facing northeast, which of these sprites do you select? And you need to select one. So I'll talk about that briefly now. It was quite complicated to figure out, but I think I ended up doing it. I've not looked in the code, but I think I did it in the same way id Software did it, just because it magically worked with the sprites in the same order that they'd stored them. So I was like, I probably landed on something very similar to how they did it. But the way this gets figured out is you establish kind of 8 cones, 8 triangles around the enemy, and you basically all have a unit of 1 length. So these triangles just literally go around the enemy. Each of those triangles represents one of the orientations in our kind of set of orientable sprites. We then look and say, well, what's the direction of the player from the enemy? And then we shorten that direction vector so that they fit inside the triangles. If the triangles have unit 1 length, we just need to take the same direction from player to enemy and shorten it so it will fit inside those triangles, but in the same direction. And we then say, that vector is a point. We use the XY as a point, and we can use that to figure out which triangle we've landed in. And if you do that, and you sequence the triangles as I happen to sequence them, you end up landing in the 0 to 7 array that id Software defined. The way they ordered their sprites, you land just right, which was kind of handy. It's quite complicated. Yeah, I find it difficult to figure out as well, as I think you can tell. Yeah, the one final thing to talk about before we look at some code around all this is as we draw the objects, as we're rendering them, we keep track of any objects that intersect the middle of the screen, and we use that when the player fires. We use that to figure out which enemy they've hit, rather than cast array again. We already have figured out what, if anything, is in the middle of the screen. So we also track that, and then we can see this in code. So if I just open up the Wolfenstein solution, make sure I open the right one. They're the same. New window. This window. Get the renderer up. Make sure I'm looking at the renderer. 1 second. I think I'm looking at the renderer anyway. Yeah. Okay. And we just need to find the right method. Right, we're looking at walls. So if you want to see the walls section at the top of this renderer is for the original raycaster, the thing that draws the walls. And then we have this object section. And in here, there's some complexity around, again, around states of enemies. Enemies can have various states, which I'll talk about in a second. And we can also, yeah, is alive is slightly different, I found. So we have to pick out, if they're an orientable sprite, we need to pick the orientable sprite index. If they're not orientable, it's just a sprite. There's nothing complicated to figure out. So the thing I was talking about in terms of picking an orientable sprite, the sort of interesting code in here, is this bit here, where I break the space around that player into 8 triangles. We figure out the vectors for those triangles, which is what this is doing here. Again, it's reasonably functional. We then this is me figuring out the test point for the player as I described. So what's the relative position of the player? And finally, we kind of iterate through those quadrants looking for a point that is in the triangle, which is this isPoint triangle method, which is quite interesting in itself. I think I've gone to the wrong place, unfortunately. That was a bit silly. Go back. Just try and find the right bit of code. Sorry. Yes, I was in the right place. Sorry, it just wasn't quite what I expected it. There's again, this is a wonderful thing about I find about doing this kind of project as opposed to sort of your sort of your typical web app, is you come across fascinating things that you wouldn't normally come across otherwise. And I may say this wrong because I'm not a mathematician, but there is a system of coordinates called barycentric coordinates, which you can use to describe triangles and decide if a point is inside a triangle with relative ease. And that's what this code is doing here. There's a great Wikipedia article on it, and there's a really handy Stack Overflow article on it, which describes it quite clearly. So yeah, I find that interesting because it's the sort of thing you wouldn't come across writing a line of business application, but you come across lots of that kind of stuff doing this kind of thing, which is really, really fun. I find, at least. Weapons in the status bar, they're pretty simple. They're just 2D renders. And again, the code for that can find in render.fs, but it's just 2D renders. But there's no sort of fonts as we would think of fonts today. It's not like a TTF font or an open font or something. They're 2D sprites again. So there's nothing, to draw the numbers, the score. You just pick the right sprites for the number and draw them. There's I'll skip through the scene because it's not that interesting, but all that stuff is coordinated through what I call the scene. You often come across that term in games, and it just brings together all those things, sets up the sort of graphics context, calls the various renderers in sequence, and is just a sequence of renderers. And then when we've done all that, we pop all that on the canvas through drawing those points back over. Enemy AI. I'm going to move quite quick because we're nearly done, but I think we've got through most of it. Enemy AI, it's this is where I had to start looking at the code, the id software code. It wasn't obvious to me what enemies were doing, what their states were. There's a classic book, and it's called I-386. It's a black book. It's about Wolfenstein and how it works, and there's some good info on there on how the enemies behave. But the enemies are essentially controlled by turning points. So on the map, you can have, I think it says P in that editor. And when an enemy walks into them, they turn direction into whatever direction the map's pointing. I mentioned things being grid-based and enemies tripping me up. I hadn't quite realized that when I got started, but it makes sense in retrospect. One of the things enemies can do is react to you. So they see you and they start coming towards you. And in my first iteration of this, they would literally see me and then immediately start coming towards me. But that could take them off grid and start missing turning points, essentially. So, and missing other important things. Wolfenstein relies on them always being aligned to those, being able to land on the center of those grid points. And if they don't do that, you get very strange behaviors happening. They'll start to slowly wander off paths and things. So again, it's about an example of how strictly grid-based it is really quite interesting. Most enemies will hear sounds and come running towards you, but there's the occasional enemy that doesn't hear sounds. Interesting, Wolfenstein had quite a complicated, for the time, sound model. It would track open doors, had sound zones, and that's one of the things that makes the game quite interesting, I think, is that it allows for surprise. It makes things a little bit more unpredictable. Things hear you, and some things never hear you, so you can get caught off guard, which is it's just quite interesting. That can all be found at AI.fs. I use the original source as a heavy reference to this because I want it to be reflective of of the original game, and it was difficult to do through observation alone. So I dove into the source. So talk about this because I think this is really interesting. You know, at the time, the game had to be downloaded over really small bandwidths. I think I had a 14.4 baud modem at the time, which is, you know, puny. Even my rural broadband has more. Or it was distributed on a floppy, so you had to squeeze things down. And I know it's still the case now. You know, obviously we've got graphics cards which support texture decompression and things. It's still a problem today, because things are much bigger. The asset files are double compressed. There's a typical sort of run length encoding system that is used. But then there's also a sort of a secondary compression, which is called Carmack compression, after John Carmack. It's his compression algorithm, and it allows for similar blocks of bytes to be replaced with pointers. I've never done LZW compression, but I think that's similar to LZW compression. It's its own format for doing it. So things are double compressed. And again, we just load up those raw bytes, and then we start decompressing those bytes using those two algorithms. And if you want to look at that code, it can be found in compression.fs. It's very simple, but it's a good example of the sort of code that you get into with this kind of stuff. Let's try and find the thing. If I can't find it, we'll move on. Assets. We'll just move on. I can't. Oh, there it is. Having a senior moment. Yeah, so there's a run length. Again, it's quite functional, and it uses an unfold. Again, I try to keep this very functional, this code, which was quite interesting to twist these things into that shape. I didn't use original source code to figure this out, but I did find somebody who'd done this in JavaScript, I think. So I kind of looked at his JavaScript and based it off that and made a few tweaks. But they're the two compression algorithms, which are, you know, quite interesting to look at. Yeah, so that's pretty cool. Maps we talked about, just a reminder. I won't talk about them much now because we're running out of time. Graphics are in weird formats, and originally I was sort of decompressing some and others. I had issues decoding some of them, and so in the end, this was supposed to be a fun project. I didn't really feel like beating my head against a wall with weird formats forever. So I used a few tools to extract from them the audio, which are listed at the bottom. They're open source tools, mostly on GitHub. Yeah, the text is stored in a way that was to facilitate quick rendering to the VGA mode that was used at the time, but it feels a bit strange to somebody like 2023. And finally, the thing I wanted to get to before I finished was targeting the desktop. If I'd have set off with kind of targeting the desktop as a goal right at the start, I would have probably built some you know, some abstractions for that purpose, but I didn't do that. I just set off with JavaScript. So the abstractions that I used to make this cross-compile with a desktop are not particularly purposeful. We were basically, instead what I did was I looked at the JavaScript that was the code that was specific to the JavaScript runtime, so data view, uint32 array, and I basically wrote .NET versions of those back to us onto .NET structures. So that I could use the same code. I used image sharp to represent the textures and let me see and get the pixels. And again, you know, I use the same approach. I render the output to a texture, and I use OpenGL to put that onto the display. So I do use OpenGL, but it's literally because I just needed some way of getting a graphic onto the screen performantly, to transfer it over performantly. That's mostly it. It's a bit of a hack because I didn't go about it in a purposeful way, but it does work. And in fact, if I desktop Wolfenstein run it, we should see there's Wolfenstein, the same code running in .NET. I don't know if you hear the sound, but it's just gone badly wrong. That's not. I've never had that happen before. Demo curse. Oh no. It crashed. I've never actually had that happen before. How embarrassing. Yeah, but it's the same code running in .NET. So I've lost a position in here as well now through that, getting me a bit confused. That's a whirlwind tour of it. If anybody's interested in it, I'm always happy to talk about it at more length and go through the code with people. You know, you have to cover those concepts to even look at the code, really, have it make any kind of sense. So it's a bit of a whirlwind tour. They are some things I found useful on the screen here. Obviously, I've talked about many of them. And I guess that's it for me. I think I've hopefully ended on time. And I guess if there's any questions or comments, happy to answer them or try to answer them.
Great session, James. Absolutely great session. And great job also on the project. Now, one of the natural questions that you expect in this for some kind of this talk is how long did it take you? So I see in the GitHub repository 35 commits, 20,000 lines of code, something like that.
How long did it take me? I think it took. It was very part-time because my dog, who amazingly hasn't put in an appearance on this show because she normally does at the worst points, was a puppy. So I was doing it when she was asleep. I think it probably took me about 4 to 6 months, something like that. It wasn't a crazy long project. It was a while, but it wasn't like insane. It was doable, and I just broke it down into small chunks. And the bits I talked about here is literally how I chunked it down. So I could spend a weekend on it, around the dog being awake or asleep, and crack on with it. So it didn't take too long. The public commit originally it wasn't a public repo, and there was another repo I was working on in private, and it had some assets in it that were not from the shareware version. So I had to I just had to clean the repo down and republish it when I put it open source.
I was confused for a moment because otherwise it would have been in 14 days, something like that. So that's why we had to ask. Yeah.
No, it probably took me 14 days to work out those orientable sprites because that was a real head melter. Yeah.
Martin, next question. I think we have a couple.
I'm doing this thing again where I'm on mute.
Yeah.
I think a related question there would be: would you do this thing again? Like if you could get a different title from the era where Wolfenstein 3D was released, would you do it again?
Definitely. So funnily enough, I've got a few things on the go. I'm doing an old BBC golf game called Hold Out, which is I'm doing in TypeScript and WebGL, which is kind of fun. And I'm writing. This got me kind of inspired to start writing about game engine development for fun. So not writing Godot or Unity, hiss, boo, flavor of the month for the last week or two, but not writing like a commercial game engine, but the concepts behind game engines are really fascinating. We're getting into all sorts of interesting space. So I've got a C# based game engine, a 2D game engine, which I've been writing, and I've been writing a book about how it works at the same time. And I started to sporadically publish some of that. The book's actually quite well written, and I've been kind of publishing bits of it, but I've not really got into a rhythm in terms of outputting it. So I'll definitely do it again, and I am doing it again. And there's a whole bunch of games I'd like to visit of different styles. I've got a real hankering to do Elite. If you remember Elite from the I've got a real hankering to do a .NET version of Elite. And
there was just a question about what's the next remake.
Yeah, I think it'll probably be Elite. Yeah.
Right now, the poll that we have going in the chat is it's going between Lemmings and Dune 2, it seems.
Oh, they're both really interesting. Yeah. Dune 2 was another formative game that had me running around my house in excitement. And Lemmings was just everywhere, and I played it on so many machines. Writing an RTS is really interesting to me. It just interests me. I've done quite a lot with pathfinding and things, so some stuff I know. But yeah, I love that era of gaming, and it's really interesting to port them across to modern languages because they take you in some fascinating directions in terms of things you learn and have to think about, which you just wouldn't encounter in, a sort of in your day job unless you're working in, I guess, the games industry, which is not something I particularly plan on doing.
Will there also be multiplayer capability at some point? I mean, it's running in browser already.
Yeah. So I was talking to a colleague I used to, an ex-colleague, someone I used to work with about the game engine, and he was like, "Are you going to do a multiplayer? Are you going to do netcode?" I was like, "Oh my goodness, that's probably a book in and of itself, like multiplayer netcode." So maybe, but I'd like to finish the 2D game engine.
It sounds good. Sounds good.
Yeah, there's lots of things you could do. It's just interesting. It's whatever. I think it's wherever curiosity takes me, I guess.
Did you have any experience prior to that, like from studies or anything, or was it really, like you said, the fascination and then getting right into it?
It's just a fascination and getting into it, really. I sort of did maths to A level in the UK. I was always, you know, I'm okay at maths. I can generally figure stuff out. I'm better at maths than I'm at visualizations, which is why the orientable sprites eluded me for a while. The maths behind it was simple, but the visualizing it was difficult. I just it just interested me, and you know, I just kind of learned what I needed. I guess I've probably got just enough mathematical grounding that I can. Things like this are okay. You know, but I'm not a mathematician for sure. But yeah, I just kind of got into it. I guess I wrote one of my first jobs was writing some graphics engine for trading systems. But it's a long time ago. 96.
Well, I would like to have one other question answered if possible. So Simeon, I hope the name is correct, asked for elements such as raycasters. Are there NuGet packages for that? Do you know anything?
Not what I came across. I must say I wasn't looking for one. There could be one. It would be pretty easy to take either the F# raycaster or the C# raycaster that I built and package them into NuGet, because the core of it is pretty abstract. They just need a set of textures and a map. You know, you could easily repackage them into some kind of library. Maybe that'd be an interesting thing to do, because I don't think it'd be too difficult to sort of abstract into the NuGet raycaster. Yeah, that might be fun.
I guess it's also hard to kind of standardize that for anyone to use it in various scenarios. And plus,
where's the fun? Yeah. I think the raycaster itself would be okay, but you couldn't standardize the game. You know, you could say here's some game objects and bits and pieces, but yeah, it'd be interesting to see how much further you could go. But of course, Wolfenstein, the Wolfenstein engine was reused many times back in the early 90s by, you know, other games. So it's, you know, it's possible. Yeah, interesting.
It feels like I was at that very moment when a new engine was born. That's the vibe that I'm getting here.
Yeah, it was awesome. It was mind blowing.
Also, I'm very glad also to have seen Silk.net on your slides. We had a webinar with them some time ago. Awesome project as well. Also, I like
it's fantastic. Guys there. It's amazing. Yeah, it's amazing. Yeah. Big shout out to that. It's amazing. I've used it a few times. It's amazing. Yeah.
Cool. All right, James. Thank you for your talk. This was great. I think to open the conference with. There's going to be more talks as well. If you want to stick around, we have a quick raffle going with a question from your talk. So if the audience wants to win a .ultimate license, which is essentially all of the .NET tools from JetBrains, I have one question, and the first person to answer it will get the license. How do you avoid the fisheye effect when raycasting? Is that using the Euclidean distance or the perpendicular distance from the camera plane? And I promise not all questions are going to be so complex, but this one was fun.
Man, we need 10 minutes to actually write that answer.
Euclidean. I explained it right now.
All right, we have many answers. UVCW, we will be in touch. I see you in the chat. You're the first person. I will be in touch and arrange the license for you. With that, James, again, thank you for your talk.
James, I have one more. I have one more question. I see there have been a couple of answers, maybe unanswered. Maybe if you got the time, check the YouTube chat once more, and because I think people would be curious to know. Some questions have been left unanswered.
I'll take a quick look in YouTube.
All right,
I'll take a look in YouTube.
Then thanks.
Great. Thank you, guys.
Right. Thank you very much. And then I think we can bring in our next speaker, right? Let's bring in Layla. Good morning. Welcome.
Hello. Good morning.
Good morning.
So I heard you're an agent, a spy agent.
Yeah, or at least trying to be a good one.
Looking really much forward to your session and seeing where the agent traits come up. So yeah, we'll talk after your session and just give you the stage so you can jump in immediately.
Okay. Cool.
Good luck.
Thank you.
Best of
Thank
luck.
you. Well, first, I'm going to start by apologizing for my voice because I was in London last week and I brought back a bug. So hopefully, at least it's not transmittable this way, but you might sort of hear some signs from it. Anyway, so my name is Laila. You know where to find me. So I'm just going to quickly skip this part and start talking about, why we're sort of all here. And for my session, that context is observability. Now, I'm guessing that most of you sort of have the context of what that is, or otherwise you wouldn't be in the session, but I still want to take some time to align on what exactly that is. Now, you can sort of think of observability as the ability to understand what's happening in your system. And that refers both to the expected and also the unexpected state that you may arrive to. So not only thinking of what could possibly go wrong, and all of those scenarios, but even the ones that you haven't dared to dream about that would possibly occur in your applications, you should be able to get insight into those as well. Now, that should be based on data that's stored outside of your application. So, not by querying whatever data store you have or things like that, but literally we're going to use specialized tools to analyze and query information that is stored outside of the system to get more insight into what is happening. And basically the idea is that we can that way get actionable insights. That's the whole goal of observability. It's just not spying for the sake of spying. It's spying with a goal, right? There's no spy that spies with the sake of spying. There's always like an agenda. There's always like something that they want to take out of it. And that's the same for us. We want to get actionable insights on how to, understand our application or our wider system, if you will. Now, there are multiple reasons why we'd want to do that. I think the main reason that got me so interested and so excited about observability was root cause analysis, because I work for a company called Particular Software where we built in Service Bus, which is a messaging middleware framework. And I've been using that for years before I joined the company. So I was building message-based systems. And one of the things that I struggled with a lot for years was that it becomes a lot harder to troubleshoot these kind of systems, because when we observe a specific failure, the odds that the root cause of the failure that we're seeing, that we're perceiving, is happening further upstream. Could be 2 or 3 services upstream, and we're just seeing the sort of result of that in a specific service. Another one could be, monitoring the health and state of our system, which is extremely challenging in, what we see more microservices architectures or, distributed balls of muds or whatever you're building. But we may want to have we may have some insight into a single thing, but we need to be able to understand, how is my whole system doing, and are the crucial components up and healthy and things like that. We also might want to get insight into performance of the system. Now, I'm not talking about a single component, right? I'm especially if we build those distributed systems that have disconnected services that are interacting together, and if we look and connect that back to a sort of larger business process or business transaction, then that usually crosses multiple services. And if you talk to a business expert, they're going to be interested in asking how performant the whole flow is, not an individual service. So that's also a possible reason. We also want to be able to catch any side effects. And remember that not all side effects surface as failures, right? It could be that there's issues that are lingering in the system for quite a while, and they're growing like the virus. I feel them in my body right now. But it's basically like I don't know, things like where you find yourself in a situation of like, hey, this data looks wrong. Oh, this data has been wrong for 2 years, and more of that type of data has been growing, right? Those are the types of side effects that I'm talking about in this sort of case. It could also be to sort of get an understanding of user segment behavior, right? Do your users behave differently across regions, across other types of segments, and get some insight into that. But also, for example, feature flags. Again, the context of this session is these larger distributed systems. And when we're building that kind of system, and we have millions of users, then when we build a feature, we're usually not just going to sort of, okay, here's a new feature, go ahead, entire customer base. No, we'll usually, make that available to either people who opt in or maybe like a specific percentage of our user base, and we want to be able to understand how is that feature behaving, are there any issues with that, is there any increased latency and things like that before we roll it out to the entire sort of user base. But that requires some insight into what's happening in the system. And then finally, chaos engineering, which is an amazingly powerful technique in which we can sort of unleash chaos on a system and try to push it to its limits to see where it breaks. But then we also have to bring back structure to the chaos to be able to understand what is failing, what is struggling, why is this happening, again, leading to that increased need of observability. So I thought I'd drop like multiple points of angles for you to sort of understand why is observability really important. And I think we find ourselves in a sort of exciting transition period in the industry when it comes to observability, because over the last few years, the industry has been both implementing and adopting the OpenTelemetry project. Now, OpenTelemetry is an open source observability framework. It's led by the Cloud Native Computing Foundation. Actually, their second highest velocity project behind Kubernetes. So it's actually pretty crazy. It's gotten a lot of adoption, a lot of weight behind it, and it's really cool to sort of see that happen. It basically provides a collection of tools, APIs, SDKs, with the goal of enabling teams to standardize how we instrument generate and collect telemetry. You can almost sort of think of it of like a protocol, right? So that whatever backend observability platform you're using, whatever language you're using, that telemetry is going to be instrumented, generated, and collected in the same manner. So I already sort of alluded to that, but it's also interoperable. It's available on multiple languages and platforms: .NET, Java, Rust, Python, Ruby. There's 11. So, I mean, they're available on the website. So there's quite a few. It's has a very wide adoption. Now, the idea is basically, to allow us to track system behavior across multiple languages and platforms. Because again, if we have a super large system, right, and that is based on multiple stacks, which tends to happen, not necessarily because we always choose it that way, but because we're presented with those situations, could be due to mergers or what have you, then we need to be able to understand how our entire system is behaving independent of, which language, which platform, which framework, and so forth. And there are three so-called OpenTelemetry signals that you can sort of use to increase the observability of your system: traces, logs, and metrics. Now, I'm going to assume for the context of the session that you sort of know what those are. And what I'm going to try to do is give you some insight into what the goals of the OpenTelemetry project are in terms of those existing signals and how they want to improve those and strengthen those. So we can start with logs, which is basically the oldest type of observability or telemetry that we know. I'm really going to assume that everyone listening has worked in a system application where logs have been available and collected, right? And we've gone through a whole transition of using dedicated libraries and then the logging abstraction from Microsoft with iLogger, and from having it in the event log or on file, and then sort of going to, okay, now let's centralize this. But even so, with all of those sort of improvements that we've made along the way, there are still quite a few problems. One of the biggest one is that there's very weak integration with other observability signals. So if you're using metrics and you're using logs and traces and whatever it was, then connecting that all together doesn't really work so seamlessly, right? That could be due to the use of different collection agents, right? We're using completely different tools. It could also be that there's a mismatch in labeling between logs and also other signals, making it harder to sort of connect that information back together and correlate that back together so that we can understand that these things are connected. But one of the other reasons is that there's no standardized way to include the origin information, the sort of source information. Like we look at a log statement, it's like, where did this come from? Especially if it's like centralized somewhere, then it becomes, that part of the story becomes hard. Before we centralized, it was trying to figure out, to which machine do I go to find the right logs? And now that we've centralized things, where did this come from? So it's like we're interchanging problems. And that's one of the reasons, is that there's no standardized way to handle that concern. And we also lack a sort of standardized propagation mechanism. There's no way to record or propagate anything that is related to the sort of request execution context, right? And that leads to sort of disjoint sets of logs that are collected from different components, and we're still kind of flying blind. And these problems are specifically painful in those larger distributed systems that we're trying to address here. So what OpenTelemetry does to sort of address these problems is introduce a unified log data model. And the whole idea is that we can have a shared understanding and a shared agreement of what a log record is and what information should be recorded in there. And then, any existing log formats that are available can then be mapped to this OpenTelemetry model, if you will. And another one is that we'll create, or that they will create support for distributed context propagation. So that will also allow us to have the data flow cross-service and then be able to further enrich subsequent log records by accessing information that was captured when previous log statements connected to that entire flow were being recorded or emitted, if you will. So we get basically standardized log correlation. And this is going to be based on 3 different sort of pillars, if you will. It's going to be based on the time of execution on the one hand, but also the execution context. And finally, where did this come from? The telemetry origin. This is all going to be included in that log data model. And that's going to significantly improve, our ability to correlate between logs, sort of different log statements across different services, but also between logs and different signals. So up until now, that was a sort of horrible manual mapping experience. I'm sure all of you can sort of think back to a time where you lost an incredible amount of hours trying to find, the right log file or looking at the right log statements, only to come to the conclusion of, okay, what's being logged here is not actually helpful. But we'll be talking a lot more about that throughout the session. And then next we have metrics. Again, we've been using metrics for years. I'm going to assume you all sort of have an idea of what that is, and focus on what OpenTelemetry sort of brings to the game, if you will. Now the thing is that OpenTelemetry was based on as a sort of accumulation of the Open Census project and the Open Tracing project. Where Open Tracing was focused on distributed tracing, but Open Census was focused on both distributed tracing and metrics. So one of the goals of the OpenTelemetry project for metrics is to work well with those existing metric protocols and standards, because they were already being used and applied, and including Prometheus, StatsD, and to also provide a migration path for Open Census users. And then again, one of the more, in my opinion, important sort of goals is the ability to correlate the metrics to other signals that we're collecting, so that we get that sort of full view of what's happening. And then finally, we have traces. Now, this is the sort of, newest signal, if you will, in the industry. You can think of it as a sort of relational graph that visualizes an entire business transaction, if you will. It might be part of a business flow, it might be the entire business flow, depending on how that's implemented. But the idea is that it goes across multiple services, subsystems, network, security boundaries, different types of things that take part in that. Could be reading something from the database, sending a message to a queue, doing whatever, heavy calculation you have in there. So you basically get a chain of spans, which include their own individual attributes and events on the span level. And we're going to connect those together. And that connection sort of happens through a correlation ID, which is our trace ID, and that then is propagated through a standardized protocol. Most popular one, W3C trace context for HTTP headers. I hate it every time I have to say that. It's just so long, I struggle with it. Anyway, so the thing is, we have multiple signals, right? Multiple signals that can give us more insight into our system, make us better spies at understanding what's going on inside the system, which immediately raises the question of, well, which one do I then use when, right? And as always, with everything in this industry, the answer is, I wish I was in a live sort of setting where I could hear everyone scream, it depends. Anyway, it depends, right? So what we're rather going to do is sort of look at, the strengths and the weaknesses of each, so that we can sort of engage in, a trade-off exercise and decide for ourselves what is best. So for metrics, it's really good to do health monitoring to, get a sense of what's going on in the system. It also gives us very good insights into how performant something is, or like, are there, certain things that are happening? Is there something that looks off? And those things are, easily sort of visualized on a dashboard, which then also makes it easy to sort of add alerts so that we can get pings of, hey, this looks off, because nobody's looking at a dashboard the whole day, right? It might be useful that from an alert, you'll go look at the dashboard and see what is off. Now, the important part about metrics is that they're aggregated values, right? They're not independent things. They're sort of put a lot of information together to give you an overall idea of the trend of how something is behaving. But that also means that they carry less context. It's harder to understand, okay, this metric is off, but why is it off? And then for logs, they're, amazing in the sense that anyone can read them. They provide a high amount of detail, but they're really hard to sort of, connect across services. And they also cover a very small scope. I find them especially useful to sort of capture information on sort of startup, shutdown type of scenarios and things like that, especially now that we have so many different observability signals available to choose from. And then finally, we have traces, which is arguably the sort of most powerful observability signal. It provides the deepest insights. It can give you information on performance, how long something is taking, about the flow of events, how things are interacting, in what order things are happening, which can be really crucial in these sort of distributed systems. We'll also get an idea of how is the data progressing, how's that data sort of being modified across services. If this came into this one, and then it went through service B and C and D, and now the value is that, why is that so? And that gives you that type of insight. And you get a lot of information. You can capture a lot of the internal state. So you really get like very, very, very deep insights into what's going on. So again, it's really the sort of richest data model that is available. Now, each signal provides value on its own and answers different types of questions. So in short, metrics will give you insight that something is up in a sort of proactive manner. Hey, go look at this, where the logs and traces can provide insight into the why, how, and where. Now, these are only the technical sort of concerns, and we'll get to other concerns that you have to think of as well throughout the rest of the session. Now, one of the things that I get asked regularly is that, I have a big distributed system. It's quite complex. We haven't really invested in observability at this point, or we've done it really poorly. It's hard to sort of understand, like, where do I begin, right? And basically the answer, or my answer to that question, is start at the edges of the system, right? Because in today's distributed system landscape, where multiple services or even microservices are communicating with each other, I find that those are the sort of main blind spots, is how they communicate, how they interact. So I find that a very good place to start. So wherever inter-service communication occur, think of REST APIs, gRPC calls, messages into a broker, etc. And it's also easiest to start there. Why? Because you don't need like a full understanding of how that service works. You don't need to understand all the technicalities and all the business aspects to be able to add instrumentation on the sort of edges of the system. And then based on that, you can see, okay, how much insight does that give me? And then work your way inwards step by step. And the good news is that to instrument at the edges of the system, there's no need for you to make any code changes. Well, hardly any code changes, because the community really has us covered there with instrumentation libraries. Now, there's a bunch of names of frameworks that are appearing on your screen, and I'm guessing that you can recognize at least a few of those to be part of your application. And if you sort of map that to where inter-service communication occurs, then you already see it, right? HTTP, gRPC, ASP.NET, Redis, Azure, AWS SDK. That's how we sort of hand off data from the one service to another. So if we enable these, we already gain a tremendous insight into that inter-service communication, even across infrastructure and everything. And we can really go a long way in understanding what the service behavior is internally. And this is where I really recommend to start, and then adding custom instrumentation from there. So, okay, we might see this and get like super excited and say, okay, then let's collect all of the thing. Let's turn on every instrumentation library on the planet. Well, at least hopefully, those that are connected to the frameworks that you're actually using, at least that. And we're just going to collect all of the traces, all of the logs, and all of the metrics that they emit. And it's going to be great. We're going to have full insight, and we'll be good to go. But then before we know it, we'll be confronted with the downsides of doing that, because we're going to be so overwhelmed with all of that data that it's like really drinking from a fire hose. Just trying to shift through all of that information to get to what's helpful is going to be like its own finding a needle in a haystack. Because what is relevant to a specific scenario, what is not? Does the instrumentation library offer enough insight, or does it, sort of not give me sufficient application-specific insight for me to make that actionable? And then how do I make that actionable? So turning everything on is a good first step to get a sense of what telemetry is there. But just doing that and saying, oh, I have an observable system, well, you're not going to be effective at spying on your system, if you will. Instead, we need to sort of come up with a plan to collect high quality and most importantly, actionable instrumentation that is going to help us move forward. And to do that, I want to take a few steps back, because we're engineers. I'm an engineer for many, many years, and we come at things from the technical angle. But I think to make us really successful, we need to take a few step backs and think in terms of alignment within our team and even within the wider organization. Now, again, observability. We've been talking about this for a few years. You read a lot about it. You see these topics pop up at conferences, but in real life projects, it's still sometimes a rather new topic, right? And that's why we need to make sure that we create alignment. So it's important to understand who is going to benefit from this telemetry data. I remember a project where we were working on, and we had this requirement to build this incredibly sophisticated dashboard of insights and metrics, and we spent weeks on that. Like, seriously, it took us weeks to tweak it and get it right. And guess who looked at it? Nobody ever. Like, nobody ever. It was just a wasted effort. And for me, that just is proof that we haven't sufficiently aligned to what was really needed, who was going to use it, in what way was that going to be used. Right? So for me, this is a really important part of the story. We want to be able to understand which signals are going to be used. How are they going to be used? Is there even room to introduce new signals? Because many organizations know logs, they may know metrics, but then distributed tracing, it's like, whoa, hold your horses, Laila. That's a whole new thing. And is that going to require me to learn a new tool? And how do I interpret that information? And so ask yourself, who will be looking at that telemetry information? And how do we make sure that it becomes valuable at an organization scale, not an individual service, right? And that's why I think it's really important to sort of invest in what I just sort of came up with as a term, but an observability strategy. So what do I really mean by that? Again, it's about having a clear and shared understanding of what purpose is this telemetry going to serve? Why are you doing this? And it can't be like, oh, I watched this cool session by Laila at JetBrains NET Days, and it was so cool that, no, not the right reason. It has to come from an actual need in your system, in the system that you're building. It could be, because you want to get better at failure investigation, because you want better performance insights. Or maybe you came into a project with a massive system and nobody, took the time over the years to document how the system works, and you just want to have some insight into system behavior. All valid reasons, but make sure that your reason is valid. And it's also important to have a really clear understanding of the questions that your telemetry should be able to answer at the end of the day. So one of the things that I like to do is to sort of advise to document a set of questions that whatever telemetry you're using, independent of any service you're writing it in, should be able to answer. And these are just a few examples that I'm going to give you, but my point is come up with your own, right? So one of them is how easily can you connect a specific user action to your telemetry, right? If you have a support case and you need that ability to be able to sort of link that back to a specific, to specific insights from in your observability backend, then that's going to affect the type of telemetry that you're going to collect and even the amount. Another question to ask yourself is what type of behavior do you want to be able to group on? What is going to be interesting for you to look at in the context of the application or the system that you're building, or subsystem most of the times, right? Can you easily identify where the most load is? Again, this is not specifically going to be on an individual service level, but it might be across multiple services. Maybe are you able to debug, something that happens in a production environment based on the telemetry information alone? Maybe this is not a relevant question for you. Again, these are examples. Can you easily find suspicious events throughout the system? Maybe you don't have a full-blown fraud policy built into your application, but you still want to have insight into, I don't know, certain things that might need to give some insight in that regards as well. So we have to sort of think, how is this telemetry going to be used so that we can improve the quality of the telemetry that we add to our applications as well? Now, all of these questions sort of feed into what I call observability guidelines. And I think it's useful to have this documented, available to the entire team or even across multiple teams, so that that same quality and that same sort of streamlined behavior can be visible from the entire application, independent of individual teams. So also important to understand and to document is which signals are available to us. This may be different per team, it may not be. Which scenarios best fit each individual signal? We might say, oh, for these types of scenarios, we just want to do traces, and for these types of scenarios, we want to do logs. And we also may want to have insight into what types of cases require multiple signals, and why is that so? And also having an understanding of where's enough. Remember the early testing days when we finally starting to test our applications, and we were like, we need 100% coverage. Do you really? Does that mean that your application is now bug-free? I think we've learned over the years that that is not the right translation, right? So again, it's about finding that right balance to put yourself into the seat of the people that are going to be looking at that information that is emitted, and try to make decisions based on that, and make sure that you're giving them the right information for them to achieve, their goal, their job, even if that is yourself. I'm talking about a third person, that could be yourself, but you're going to be in a completely different context when you're developing a piece of code than when you are looking at your observability backend, trying to understand why something is off. And then finally, there are multiple best practices that should be considered. Again, these should be available to the team, especially because we're still getting better and better at this over time. So we need to ensure that we have that information available and that we have an understanding of what do we find important within the context of our system, within the context of our team. Now, when it comes to best practices, there are whole books that are written on the subject. So also be on the lookout for extra resources at the end, because I listed the ones that I read and I found useful. But for this session, I sort of made my own selection of best practices that I really wanted to share. So just to underline that this is not a comprehensive list, but it'll give you an idea. Sorry about that. Like I said, I'm still struggling with a cough. So the first one is failure scenarios. Now, I feel that, I don't know, as I gain more experience or I've worked in more complex scenarios, like building an individual feature is pretty easy, if you will. It's a lot of the sort of effort and complexity goes in trying to understand what could go wrong. How do we handle those scenarios? Do we handle them at all? Do we just let them occur? And getting insight into that. Now, from the observability perspective, you really want to capture any possible failure scenario that might occur in an application. Again, because you cannot foresee everything that might possibly go wrong. You can't. So having that captured will at least give you insight into, okay, this happened. Now let me try to understand why. Those failures then need to be signaled to the observability backend so that we can easily find them there. So we want to include error information, error message, stack trace, inner exceptions, whatever it is, that gives us more insight. We could even consider adding, additional information when a failure occurs. So especially in the distributed tracing context, you already have that chain, and there's already context being captured at each individual step that is part of the sort of transaction, if you will, business transaction that we are looking at. But still, sometimes you may want to capture some additional information that may otherwise be invisible so that you get more insights into what's going on when you're looking at such a failure. Now, another important part is that our instrumentation should never cause business failure. So we have to be really careful with the instrumentation code that we end up adding. Make sure that keep the complexity low and make sure it's straightforward. Because remember that as valuable as instrumentation is, at the end of the day, it's not a mission critical component. Right? If we spend a few weeks, increasing the observability in our system and we release it, and then the whole thing comes down, then it's an absolute failure from the business perspective. So again, this is something that we need to be mindful of. Be careful with that code, because instrumentation code or not, at the end of the day, it's production code, and it should also be tested like any other production code. Now, to make that telemetry insightful, again, events are happening across independent services. We want that information to be connected. And this is not a new concept, right? It's at the basis of how distributed tracing works. It basically works based on that correlation ID that links all of those different spans together and says, this is a child of that, and that led to that, and that led to that, and so forth. And then we get that sort of tree graph of what is going on. But that same idea of context propagation that lies at the basis of distributed tracing could help us improve any signal, not just traces. And that is really the goal of the baggage API. Now, the baggage is a standard to propagate context across services, and it's available for different signals. So that would be, provide you the ability to strengthen any signal that you may be using. Now, a word of care, or a very, very strong word of caution here, because you have to be careful with how you use the baggage API. It can be powerful. It can also be really, really, really dangerous. There's no other way to say it. First of all, you need to understand that using the baggage API is going to have an impact on your latency, because you're just adding information, right? The baggage is either you can use it as a dictionary, or at the end of the day, it's just a string. Now, be careful with what you put on there, right? You don't just add in whole collections of stuff, because that's going to have an impact on your latency, because you're adding a bunch of information. So you have to be really mindful of how that's affecting the rest of your system. Why is this so important? Because everything you add on the baggage is going to be available on every single hop after it's added, right? So it's really important that you are aware that you are creating impact across multiple services and not just your own. Now, another angle to consider is third-party integration, because you have to also become mindful of the third parties that you integrate with. If they have observable systems and they are using baggage, you might be facing a request with a baggage header with a bunch of information that is completely irrelevant to you. Now, you could also turn that around. You're also passing that through to the next party that you then integrate with as well, because that information is just being passed through. So again, this is really to be, it's available, it's powerful, but you have to be very well aware of the impact that it has when you're making use of this API as well. Now, one of the things that is a sort of possible risk when using the baggage API is that you start leaking sensitive information. So I want to talk about that as well briefly. Now, with any type of telemetry that you're using, I don't care which signal it is, it's really important to keep any type of sensitive information out. And even though many of you will be frowning and, yeah, I know, but still, like, this happens so easily. It's such a sort of innocent mistake at the moment in time that it's, I mean, how many times have you just, checked in a connection string? It happens, right? We're just people. So be aware that you can have any personally identifiable information in your telemetry, nothing that ties back to a single individual. Then you get the GDPR request to be removed, and you're like, oops. Also financial, healthcare data, that type of information, passwords, connection, infrastructure information, anything that would open up a security breach in your system. Now, how do you keep this out? Well, one sort of tool that I refer to a lot are code reviews, because I have a sort of maybe a little bit of a different understanding than many people I've talked to over the years when it comes to code reviews, but I think of it as a sandbox that I have to come back to wearing multiple hats. Because, for example, if someone or I write a feature together with a few colleagues, or someone writes a feature and asks me for a PR review, I will sort of put on my first hat and say, okay, does this feature work as intended? Does it, is it like according to the requirements and all of that? Did we forget any edge cases and things like that? And once I'm like, okay, good to go, then I don't approve the PR. Then it's like, for me, a mental model of, let me put on my testing hat. Have we sufficiently tested this? Have we covered the right scenarios? Are there any sort of side effects that we need to test for? Is there enough sort of coverage from the business perspective, not the code perspective? Those are also things that I will consider. And once I'm done, I'll have to put on my third hat and say, okay, let's look at this from the angle of observability and instrumentation. Did we create the right instrumentation? Is this going to give us sufficient insight into what's going on? Are we leaking any sensitive information? Right? So treat those PR reviews seriously. And it's not just like, oh, I scrolled through it, approve. No, that is your opportunity to talk things through and act as a sort of mechanism to ensure that, you're adding quality to an application on all of the levels. But of course, that's not the only way to keep information out. Now, you could also be saying, I'm going to use encryption, or I'm going to tokenize data, I'm going to mask specific data, or redact information from the instrumentation that I'm emitting from my application. And, you may want to do this in a more sort of centralized manner, and not every time that you log a statement or every time that you create a span, having to think about this over and over again of like, oh, I have this sort of customer object, and there may be some things there that are, not suited to be in the telemetry and having to repeat that code. So that brings me to processors. Now, the thing is that you don't want to go through that exercise every time you create a span, log something, add a tag, add baggage, whatever it is, right? So you could sort of handle these concerns in a more central manner using these processors. Kind of reminds me of the pipes and filters pattern, for those of you who know that. When data comes in, you transform it, and you pass the result to the sort of next link in the chain, like in a factory. Right? The telemetry data is going to sort of flow through that data pipeline, where each individual processor can either further enrich that information, or on the other side, further filter it or redact it, if you will. Now, you can basically define 0 or more processors that do different things, and you can also set up different types of processors per telemetry signal. Again, something to be used with care. Why? Because whatever you're doing in those processors is going to affect every individual signal element that you create. So you're creating a new span, it's going to go through the processor, right? So it's important to be aware of the performance and latency impact. That is not the right place to query something from I don't know, in REST API or a database or whatever. That has to be like, super fast. So like, you have to be aware that that's going to have a big impact if you do crazy stuff in there. Again, something you can keep an eye out during PR reviews as well. Okay, and that brings me to one of sort of my favorite best practices, and it's also the final one that I will be discussing today, and that is telemetry correlation. Now, again, there are multiple reasons to use different signals to capture insights on a single business transaction. And we've already established that each individual signal does provide a value on its own, right? But imagine that you're working on an existing project, and it includes a REST API, and there are already some, useful log statements in that code. And you've now started to invest in distributed tracing, and you've enabled the instrumentation library for HTTP clients. You're also capturing some metrics to track HTTP request results so that you can alert on sort of a spike in failed requests and things like that. Again, each of these signals, we have the metric, the log, and the traces, they're all valuable on their own. But we can really boost their value if we can connect all of those together. Because imagine that there's a spike in that failures metric, and you'd be able to figure out which API call that was, and which environment that happened. Because if we sort of can enrich that metric with some kind of correlation information, then we would be able to say, find the related traces. And then we're looking at that tracing information, and because we're still pretty new at this, we still want to be able to connect that back to our logs and then get the picture of what we had in our logs as well. Being able to connect all of that information together is going to make us more effective at understanding what is going on, and that's going to eventually reduce the mean time to resolve. This is basically a metric that is used to understand how long does it take us to resolve an individual incident, right? So it's important to connect our logs and traces through that trace ID and span ID. And alternatively, we can consider capturing the trace ID in metric exemplars. Now, I'm going to explain to you a little bit what this is, but it's really important, or the main thing that I want you to take away from this is that it's really important that we don't, by mistake, introduce what's known as cardinality explosion. So to sort of give some context on what that is, think of a metric as a value that you can sort of add labels to, if you will, to simplify it, right? That give you more insights. And let's say that you want to collect a metric that represents the failures that occur. You could add a label to that to say, okay, I want to know the status code, and I also want to know the environment on which that happened. Now, if you think about the cardinality of this metric, you basically need to look at all of the possible label values for HTTP status code, which is going to be everything under 400 and 500 and whatever, and every possible environment. And the cardinality is going to be every unique combination, every unique possible combination that is available. Now, I hope by looking at this example, you can say, okay, this is fine. But what if I add, I don't know, customer ID in a system like Amazon or something like that, for the sake of the example? That will lead to a ginormous explosion of information. There's a super high amount of data to store, and our bill is going to explode as a result of that. It's also going to become a lot harder to effectively query the information, right? So some observability backends do support high cardinality data, such as Honeycomb, but it's important to understand the sort of limitations of the observability backend that you're using and make sure that you're not doing things that it wasn't built to do. So again, it's about finding a balance. I have a few additional best practices here. This is the time for you to take a screenshot and for me to take a sip of water before we continue. Now, sort of to recap this first part, it's really important to build an observability strategy. And I know this may be like the more boring part and not the exciting code part, but it is a very important ingredient if we want to be effective at it. We have to apply best practices, document case studies and learn from them, see what we can learn from something that took us a very long time to understand. How can we improve our instrumentation, evaluate the telemetry that we collect, and then we can monitor that mean time to resolve over time. Should be going downwards, right? And then we can improve from there. So okay, at this point we could say, well, awesome, we have high quality instrumentation. It's now safe to collect all of the things, right? But then at some point there's a manager in their office and they're looking at a piece of paper like this. Because the thing is that if you're in a high throughput system, even though the telemetry that you're collecting is super useful, it might still be way too costly to collect all of it. So we need to start considering whether we really need all of the data that we're collecting. Now, this applies mostly to traces and logs because metrics are aggregated forms of data. But for this session's context, I will focus on traces for this last part. Now, if we look at all of the traces, right, that are collecting throughout a single system, we'll find that there's probably a whole lot of successful traces. Well, yeah, hopefully. You'll find that there's a small group of errors. Again, hopefully. We'll also find some that are, higher in latency for whatever reason. And we'll find some that have very specific attributes. Now, the thing that you should ask yourself is, do I need all of them to sort of meet my observability codes? Observability goals, not codes. Sorry about that. Or would it be sufficient to say, keep like a sort of, random sample of the successful ones, and then all of the, those that are high in latency and that have errors and have specific attributes that we care about? So it really comes back to understanding, what do you really need? Like, again, what are your goals? What are you trying to achieve? If you want to be able to debug any request in the system, then you need all of it. That's the answer. Then you just need all of the information. You can sample. But if you want to just debug system-wide problems, then maybe you need half. Maybe you just need half of the successful ones, for example. Maybe you just want to understand the baseline behavior of your system, or even less if you just want to understand the system architecture. So again, figure out what you really need. How is this going to be used? And then we can start to talk about, okay, so how do we sample some of that information out? There's two different strategies. There's head sampling and tail-based sampling. Now, for head sampling, the decision to basically keep that trace or not is going to happen at the beginning. So basically, the root span is going to make the decision on whether to keep that trace or not. Now, the default way that this works is a parent-based sampler with a trace ID ratio-based sampler. Lots of complicated names, but the biggest sort of important thing to remember from this is that you get unbiased sampling. It's purely randomized. Now, I do want to point out, remember that your individual spans are still created, they're not recorded. I have resources at the end that show that this is not a too big deal, but I don't know what types of applications that you're building, right? if performance is an extremely high concern, then this is something to be aware of. And next we have tail sampling, where what we're going to do is we're going to collect all of the spans that sort of pertain to a trace, collect all of that, and then defer the decision on whether we want to keep that span, that trace or not, until the end of the flow, if you will. Now, how are we going to make that decision? Well, usually it's going to be based on the overall trace duration. Is this a high latency one? Or it's going to be based on status, like did any failures occur here? Or it may be based on, specific span attribute values. Be careful with that. That's really a good way to be very biased. But yeah, it's a possibility. And remember that if you're doing tail-based sampling, it's still important to capture a segment of successful traces as well. Otherwise, you don't have a baseline. And we're playing this sort of game of trade-offs again, right? So if we look at head sampling, easy to configure, pretty easy to understand as well. Your non-sample traces, the ones that you are not keeping, they don't affect latency. You get reduced data transmission because you're only collecting and sending stuff through that you're actually going to store. The sampling decision does need to be sort of respected by all services, and this could, depending on how you've set things up and how you've configured it, this might possibly be a challenge. And the biggest sort of drawback of head sampling is that it's impossible to anticipate failures or high latency or other important attributes, which could essentially mean that you're throwing away the traces that you really care about the most. It's just a real risk. Now, with tail sampling, you don't lose those important traces, right? The ones that you care about, assuming that you have configured that correctly, which again is quite a big assumption, especially in that section of other important attributes. But you could sort of say, I can't lose important traces this way. But there's a bigger latency and performance impact because you're collecting all of that information and at the end making a decision on whether to keep it or not. If you don't throw it away, then that was sort of in vain, if you will. Another tricky part is that it's not easy to understand when a trace is finished. Like, when is something done? And what if something is failing, halfway through the trace and that's causing delays? Like, at which point do you decide whether a trace is done? You're probably going to have to use some time-based cutoff to mark the trace as completed so that you can make your sampling decision, or you could be at risk of waiting forever, right? Now, this is an arbitrary number, so that's possibly going to lead to some gaps in some traces at some point. It's a risk. You still are running into potentially unpredictable costs because you may be saying, I'm only capturing the failed ones. And then there's an Azure outage for 2 hours. And that happens through Black Friday and you have an e-commerce system. Right? That's going to lead to a bunch of failures happening, still creating that spike in your telemetry that you're collecting. Something to be aware of. Also, there's going to be additional pressure on the service that's making the sampling decision, right? Because that's have to gather all of that information and decide, do I keep it or not? And it's tricky to get right because you have so much flexibility. So by definition, it's going to also be tricky to get the balance right. It's definitely something that you have to sort of iterate through a few times before you get that right. Now, in .NET, you can easily set up OpenTelemetry and immediately send all telemetry to an exporter. And this is super useful when you are starting out because you can just turn everything on and send it to the observability backend and start to look at what's there. But it also has a bunch of challenges because there's going to be an increased load on the individual service that is doing that export. It's also exposing that service to any communication issues with the backend, right? And that could then cause business failures. Important to be aware of that. And there's also no central configuration point. If you have multiple services doing this and you want to change something about that, you're going to have to redeploy all of them. And also no central data management pipeline. Now, to visualize how this would look like, we basically have individual services collecting instrumentation immediately, sending that to the observability backend. But there's an alternative, and that's the OpenTelemetry collector. Now, the goal of the OpenTelemetry collector is basically to be a sort of mediation layer between your application and your observability backend. It's vendor agnostic, not tied to any individual implementation, and it allows you to receive, process, and export telemetry information. That means you can centralize configuration and management. That means that you can offload all of those risks of handling failures and error scenarios and batching up information to the collector and not doing that in your individual service. And it also allows you to scale per signal. Now, there are multiple deployment options available for the collector. The first one is the sort of sidecar agent option, if you will. In this sort of model, what you're going to do is deploy the OpenTelemetry collector as a sidecar to the instrumented service. And that offloads the responsibilities of collecting and processing and exporting all of that information to the sidecar away from your service, right? The sidecar can then handle any batching and retries and encryption, compression, whatever concerns that you have, independent of the actual service, but it's at the same time still running on the same node as your service, which means that there's no added latency between the service and the collector itself. It's also going to handle any communication issues with the backend. It could also hold on to some data while the backend becomes available again and so forth, right? So clearly it does also complicate your infrastructure more, but it could be a very good solution to offload individual services. Now, this could look something like this, a sort of more visual representation. So you still have your service sales, but now in the same node, you have that agent that takes care of everything regarding instrumentation. And then that is going to communicate with the observability backend. There's another option to sort of host the OpenTelemetry collector, and that's the gateway cluster option. In this sort of setup, we're going to set it up as a standalone service, right? And what is going to happen is that all of those services are going to connect with that sort of centralized OpenTelemetry collector. Makes it easier. It's easier to scale with a load balancer. And this is really required if you're doing tail-based sampling scenarios, because again, you have multiple services partaking in a sort of larger business transaction. You want to sample at the end. So you're going to need this model if you're doing tail-based sampling. Every span that pertains to a trace is going to need to processed by the same instance, right? It has to be collected in one place so that we can make a decision on all of that data. Again, to translate that into a visual model, we now have a centralized OpenTelemetry collector that all of the services are connecting to, and that takes care of all of those concerns that we've already talked about. And you could even take this a step further and say, you know what, I'm going to have a sidecar for each individual services, because there are some, for example, the processors are more sort of tightly coupled to the individual service. And because I want to do some processing on that end, and I still have a centralized collector. That is something that you could do. But again, we're further complicating our infrastructure requirements here. And you could even go incredibly crazy and scale out the OpenTelemetry collector, put a load balancer in between so that you can still make sure that all spans that pertain to a single trace are handled by the same instance. So again, Laila, you're doing this again. I have so many options. Which one do I choose, right? Now, I would say this really depends on the scale of data that you expect. Now, the thing is that the odds are pretty high that you're not Google or not even, Amazon, Netflix, LinkedIn, whatever it is. So be mindful of how you define scale and don't overdo it from the beginning. Look at what data is coming in, even if that means that you lose some instrumentation for a while. Adjust for the scale, that you actually have, not for the skill that you think you will at some point have over the rainbow, right? So let's keep things simple, add complexity as you need it, keep things simple as long as you can, learn, iterate, and refine. Okay, and that brings me to the end of this session. So I think if you're serious about observability, you can't really treat it as an afterthought. So it's a matter of time before we talk about observability-driven development. I'm sure you can already Google the term as of now and find a lot of interesting resources. But I really believe it's important to build and invest in an observability strategy, figure out what do you need, why, how is this going to be used, play the game of trade-offs. What do you need? Like, what are you trying to achieve, and what do you need to achieve those specific goals? If you're still collecting too much information about after tweaking all of that, then you can play the game of looking into sampling strategies and see what's going to sort of help you take control of the amount of data that you have. There's different deployment models that are available that can align with your individual observability needs, and yeah, help you effectively spy on your systems. And if you want to learn more, that observability sort of hashtag, it has a name. I don't know what that's called, but what basically happens is that they use the word observability, take the O, take the Y, the first and the last letters, and then they count the letters in between, which are 11 characters, and that led to this sort of acronym, if you will. You could say it's OLLI, or observability. Anyway, thank you so much for listening. If you scan the QR code, that will take you to one of my repos where I have plenty of additional resources available. I also have samples available for you to run from another talk, but I'm sure the next talk is going to sort of fill that coding need you have, and I hope this can sort of act as a sort of groundwork to make you successful overall.
Great session, Laila. Great session. And it seems so relevant. We've seen, or at least 2 times, I've seen people in the chat saying, yeah, I blow up my telemetry just because I added too much cardinality and stuff like that. So yeah, also I dropped Martin some questions before, all answered, so I'm happy. We have a couple of questions, including chat. We will try to make it brief in your, so that you don't struggle too much. I think Martin is going to start, yeah?
Yeah, exactly. I just want to add that the poll we ran about what people are using most in their applications shows logs at 65%, traces and metrics at 11 to 13%, and 10% of people using nothing. So I hope they soon start learning about the systems that they are building.
Cool. Well,
on to
I
questions.
Hope it was useful then.
Yeah. On to questions. You mentioned that observability is typically used for failure investigation, performance, and system insights and things like that. Would you recommend using the same infrastructure for getting business insights, like getting a metric on the number of signups or tracing about how someone navigated to the subscription page and essentially made a purchase afterwards? Or would you look at different tools there?
Well, thanks for the tricky question, Martin. No, it's a really good question. I'm actually glad that you asked this. So we have to realize that observability is still aimed at making us successful in running these types of systems, right? Business metrics is a whole other thing. And yes, you could be able, in theory, to detect business type of metrics from your observability backends because you have so much information in there. Now, one of the things that you need to be thinking about is data retention. How long are you going to keep that data in your observability backend? You're not going to have the same needs when it comes to troubleshooting your system in terms of data retention as the needs that you're going to have around, business metrics. You're probably going to want to hold on to that a lot longer and see those trends across a lot more time. That is one of the sort of biggest ways that makes it a mismatch. So I think it could be good as a maybe starting point, but if you're really serious about business metrics, then you should be looking at different types of solutions for that. in my opinion.
That makes sense. Yep. Thank you.
Next question. Chat was also pointing out there's at least in Serialog there's something like a masking enricher as an attribute. That's going to be interesting to look at. But the question is, any tips on finding and deleting data across multiple sinks? So talking GDPR and stuff like that. Do you have anything?
Well, if we're talking about GDPR, don't let the data get into your telemetry to begin with. Like, make it so that you're never actually going to have to do that, because now you're looking at different observability backends where those concerns are handled differently, and maybe you're not even able to do that, and it's going to mean that you're going to have to throw a bunch of data that you don't actually want to throw out away with that information just to adhere to the GDPR guidelines. So I think in that example, just don't work yourself in such a situation, right? We can still connect that information and have a customer ID, and that's sufficient information for us to link it back to whatever data store that we have. And then we can handle the GDPR concerns in our business databases alone. But I may have given only half an answer now to your question, I realize.
I guess it would still be interesting. Like GDPR was also introduced at some point, you know. And what if there was a what's the word? I have no idea
legacy.
What the word is. But if there's a new law introduced, and then you would have to throw out a bunch of things, you know, something that deems any other information as. I mean, I wouldn't think that would happen, but.
Well,
it's something to be philosophical about.
No, absolutely, absolutely. And we've been bitten by this, right? Which is why we're asking these questions to begin with. Again, I would try to, the information that you expose to your observability backend, it has to be insightful, yes, but it almost never has to be able to sort of connect back to something that it may be even at some point sensitive. So still, I would try to hammer that most of it. But then as part of choosing an observability backend, I would say, you know, when you're making that selection of, I want to use, you know, App Insights or this or that, that's something that you need to investigate upfront. If I'm dealing with a situation like this, how do I deal with it? It really ties back to that observability strategy. It's a question that you should have answered upfront and not, oh, now we need to delete it. Oh God, what do I do? So I would really recommend when you choose whatever tooling that you're going to use, that is one of the questions that you should be asking your vendor. I can't answer that because it's probably going to be vendor specific, where the data ends up being, how you handle such things. Does that help, Matthias?
Probably, at least me.
Okay.
Cool. Yeah. Speaking about tooling and everything there was one additional question in the chat and a little bit of discussion about whether things worked or not. But I do think it's a great question. And it is, where do you see, or what role do you see for AI in observability systems?
Yep. Well, I think there is a role. I've actually been already seeing, I think, recently posts from Honeycomb, if I'm not mistaken, that they're also starting to fiddle or integrate with AI capabilities so that we can get richer insights, and so that we can even maybe catch things that we haven't set our system up to catch up front, like, you know, certain metrics that we haven't thought of that would be interesting to us, but that based on tracing information could be deducted. So I definitely think that having AI capabilities will also allow us to sort of collect even more information and still make us more successful at extracting those actionable insights and information, but it will take a while. This is still sort of new, so I'm just looking with you to sort of see how this is going to evolve and enrich that type of space as well.
Cool. Sounds fantastic. I think observability definitely has grown in recent years, and I guess AI and everything around that is also one of those side aspects of observability that still has a lot of room to grow.
Yeah, I agree. Yeah.
All right, great session. We have lots of praise in the chat. Chat also confirmed that answer was helpful. not just to me.
Awesome. And otherwise, you know, feel free to reach out to me over any of the channels.
Exactly.
Perfect. Thank you, Layla, again for a fantastic talk and for enlightening us about observability and everything around that. I will now remove you from the screen and bring in our next hosts. See you next time. Our next hosts, I promised that we would do raffles and everything, so I'm going to make this a raffle, right? I also promised that the raffles wouldn't always be this complex, so this raffle is going to be more of a gamble. Who from our developer advocates is going to be the next host together with Matthias? Is it going to be Rachel? Is it going to be Matt? Or is it going to be Khalid? Chat, this is your chance to win a .ultimate license.
Or Winnie the Pooh. Maybe Winnie the Pooh appears. I have no idea. I will be surprised as well.
I see Khalid. I see Denis. Yes, Extreme, you have Rachel as the next host, and that is absolutely correct. So let's first bring in Rachel, and then I will handle the ultimate license with you. And I will see all of you next time.
See you, Matthias. Or Martin.
Martin. Martin, come back, and I leave.
They're switching out you. I did not sleep last night, so I'll start with that.
Usually it's me who's not going to sleep, but this time I was like, okay, you have to be super good in such a nice form tomorrow and all. So yeah, we're gonna have the next speaker. Should we bring him up already?
Let's do it.
Right. Okay. Hi, Denis.
Hello.
Dennis.
Hey. Hi.
So this next one is Roslyn, source generators, and more observability. So this is a nice little trending theme here. And
segue to be the topic of the year.
Segue. So.
Absolutely.
Perfect. Okay.
Rachel, please remove myself from the stream because I have no ad.
Okay, and we are good to go. Hello, everyone. Let's get this talk underway. My name is Denis. I am a lead software engineer at a Swedish company called Threaten37. And I've been a software engineer for about 10 years now. And apparently, I still need to look at the prompt to remember this. So, and I'm currently occupying a role as a software architect in an enterprise automotive company where I mostly work on architecting, maintaining, and developing highly scalable and highly performant cloud-native solutions. You can find me on any of the listed social platforms where I'm mostly, I'm mostly active on GitHub. Otherwise, on other social platforms, I'm sort of a lurker. But I do blog, and I do it occasionally. So yeah, if you like, visit my Dusty blog, and let's get this underway. So today, I'll be talking about a couple of seemingly disconnected topics, namely OpenTelemetry and Roslyn. And we are going to look at a solution which is going to help us connect this topic and then maybe produce something of value going forward. So let's set the stage. Let's start with a story as old as time, or at least computers. I have yet to meet a software engineer that hasn't come across this particular problem in describing the following scenario. So let's say you start working on a large software system. You're a couple of weeks in, and you get a ticket. It's a bug, right? You open the ticket, and the first thing that pops up is a screenshot of the error. No reference exception. Anyone got this one before? Yeah. Anyway, you start exploring the ticket, and somewhere in the comments is a hidden correlation identifier. You somehow get access to the servers. You go on the server, you find the particular log file, you press the old Control-F combo, and you try to find this correlation ID, right? You find a single log entry that states object reference not set to an instance of an object. Okay, you dig a little deeper. You find out that there is a stack trace with a couple of stack frames. And in one of these frames is a line, a source code line that specifies where this exception was thrown. You open a solution, you go to that particular line, and you try to set up a scenario which will allow you to sort of repeat this exception all over again. And man, debugging can be a really tedious thing, right? So if only there was a way to streamline this boring process of going through these loops over and over again. If only our application was a bit more observable. And this is where OpenTelemetry comes in. But not particularly OpenTelemetry, but frameworks that allow you to make your applications observable, right? So in our particular case, OpenTelemetry provides a single open source standard and a set of technologies to capture and export metrics, traces, and logs, and probably also some other types of signals. In short, it makes your application observable, right? So we are now at the observability part. But what is observability then? Well, observability, also known as O11Y or OLI, by the way, this just stands for the fact that there is 11 letters between O and Y, similarly to Kubernetes, for example, K8S. And okay, this is observability. So to recap, observability is the extent to which you can understand the internal state of a system, a complex system usually, based only on the knowledge of its external outputs or signals. So we have this problem now, and we are trying to find a solution in OpenTelemetry or in any other observability framework that will allow us to solve the problem in an easier way. So let's look at particular signals here. Let's start off with logs, for example, right? These usually help in situations where you find a bug and you're trying to dig to the source of the bug and find a solution. But in our case, we only have a single log message. We have absolutely no context around it, and yeah, this single logging entry is actually what got us into this issue in the first place. So maybe let's move on. Okay, metrics. Yeah, let's not. This is a metric that is going to be very helpful to my manager for finding out exactly how many null reference exceptions I've caused. But let's just skip this one. Okay, so the only thing we have left is traces. So traces provide sort of an ordered, correlated view of what the particular operation within the system has spent its time doing and what events it produced along the way. That's a great thing to use for troubleshooting exceptions, right? Yeah. So let's use traces. Okay, so now we have a problem defined and we know the solution, or at least we want to enable telemetry within our application to use traces. So let's just switch over and start a demo. I'm going to open my Rider instance and take you to a pre-made solution. Now, you can say that this is a very simple web application with a front-end client, or you can say that this is an old legacy system that has thousands and thousands of different functionalities and it's been there for years, right? This is the problem that we are solving. So this application has a single minimal APIs API, and it has a Blazor WASM front end. And let's just quickly start this application to see how it looks like and what it does. Yeah. Okay. Let's restart this one. Yeah. So we have this simple user interface. And the only thing that we can do here is enter a GitHub username of a particular user. And what is going to happen is we are going to get some statistics back. This is the primary use case of our application. And just a note here, these statistics are a bit skewed. You're going to see the number of followers to my particular GitHub a bit different each time I actually make a request. And that has to do with the fact that I'm trying to sort of outline that there's more logic to making a request to our web API, which in turn makes a request to the GitHub API and returns a response. And also, yeah, it makes me a little bit cooler. So if we reissue the request, we can see that this is no different. Okay. Now, let's make our app produce some telemetry signals. To that end, I've actually added a OpenTelemetry collector that is running currently in my Docker environment. So we have an OTel collector, which is receiving logs from, or will receive logs, metrics, and traces from our application. And it's going to ship them to a telemetry backend. This one specifies in collecting and displaying traces. And it's going to show us the traces that our application produces, right? So now if we just refresh this one, we're going to see that, yeah, nothing so far. Okay, let's go inside our code base and make our application produce something. So we have this stub method here that we want to add some telemetry to. So let's add a couple of lines of code here. And shut this application down because we don't need it. So what we did is we added the services needed for OpenTelemetry to do its thing. We described our resource as an application that has a name that is specified, well, somewhere else in our application, and it has some version. What we did also is we added this resource to our telemetry outputs. And we also added a bunch of other instrumentation that is provided out of the box, namely ASP.NET Core instrumentation and HTTP client instrumentation. And we decided to export all of these things via the OpenTelemetry protocol to some third-party application. Now, if we start this application up again. Yeah. And we go back here. Let's refresh this. Let's start this again. We have something. And now, if we switch over to our Jaeger instance, we are going to see that there was suddenly a service added to the list of available services. And if we find for any traces that were created, we can see that there was actually an event created that houses two different sets of spans within this trace. So we see that there was a request made to our web application, and we see that there was a request made from within our application to GitHub. Okay, that works. But the thing is, our software system is quite complex. And it does many things under the hood, maybe not visible to the naked eye at first, but we see that this number is not changing. Even if I keep pressing, it should change, right? Because it's randomized. It's supposed to make me look greater every time I press the button. And there's some hidden logic within our application. And of course, our application is complex, and we need to find a way to observe this hidden logic. So what can we do here? See, now it worked. Why? No. Okay. So we do not have enough data within our application to actually figure out what was going on. We still cannot solve our problem of a no reference exception. So yeah, maybe OpenTelemetry is not the silver bullet we were expecting it to be, but can we make it work for us? So OpenTelemetry as such supports two ways of instrumenting your applications. One is the automatic instrumentation, which is something that you can add after your application was already built. And it's going to start producing telemetry based on a couple of predefined types of telemetry that these automated instrumentation tools support. For example, ASP.NET Core, HTTP client, as well as other types of infrastructural components are already included. Unfortunately, we are not going to be talking about automatic instrumentation today. This is something that is probably a whole other topic. But we have another option here. We can add manual instrumentation to our application, right? So let's see how we can actually do that. Let's jump over to our IDE, and let's browse to our main entry point to the web application. As we can see here, this web application exposes a single get method, which the handler gets proxied to this static function here. And what we want is we want to intercept what happens, add some signals to it, and then let it do its thing, right? So we have a default activity source here, the one that we actually used in bootstrapping our telemetry in the first place. And in here, we have a static property called activity source. So what we can do here is we can say, we can do a manual instrumentation by saying, hey, this activity source, which is our application, please start the activity. Now, by default, you shouldn't actually explicitly name these things, but I want to make it obvious that this is something that we instrument ourselves and it's not a part of some automated process. Also, what we can do here is we can say activity if someone is listening. This is why the question mark. If no one is listening to this activity, the activity is not going to be created. And we can say, okay, everything worked just great. Also, what we could do is we can add some events to this activity. Right? We can add some other tags to this particular activity, which is going to just add more and more context, which may be useful in the long term. Okay, so we have now manually instrumented our application. Let's see if that actually works. Starting up. Let's restart this. Do something. Let's go back to Jaeger and refresh. And we can see that there was an activity created again, but this time it contains 3 spans. One is the one from ASP.NET Core, the other one is the one from the HTTP client, and then there's one that we actually manually created, right? So now we are gathering more and more visibility within our application, and we know more of what our application does. Okay, so we got that working. And now we're just going to make a slight change to our application just to allow us to not switch between Jaeger UI and our application, and also to showcase what OpenTelemetry is also capable of. I'm going to add a component to our main page. And this component will allow us actually receive telemetry on the client instead of shipping it somewhere else. Now, if you remember, in the first step of our journey of instrumenting our application, we added this telemetry definitions and services, but we also added a processor. And this processor allows us to export telemetry not only by using some standardized means such as OLTP or the OpenTelemetry protocol, but we can say, hey, every time some activity is produced within our application, just ship it to everyone that is connected to our signal or hub, right? And then on the front end, we also added this nice piece of code that allows us to actually view what's going on. That's one really cool feature. Of course, please don't use this in production. I'm the single client to my application. It doesn't make sense to actually use a feature like this generally, but it allows us to do something really cool. Great, we got the data back, but now we also have the traces that were produced within our application on our front end, so we can see them more clearly. Okay, the issue still remains here. We have something from ASP.NET Core, we have something from HTTP client, and we only have that little thing that we needed to manually instrument for our application. So we need some other way to make our application more observable. Let's go back to our slides and think about what could be a way to do this. So we have a web API application which has a single entry point. And that single entry point is the root of all services. So it's the composition root of our application, meaning that every service or almost every service that is used over there is going to have to be registered in our service provider, right? So we have a service collection. We say register this service. And then when the service provider is built, whenever you request a service or usually an interface, a concrete implementation is provided for us. And we can take an advantage of this by using decorators. Not these decorators. I'm talking about a means that allows us to take a piece of functionality in our system, wrap it around or rather wrap some other piece of functionality around the core and add some more functionality to it. So basically, we are going to take every interface in our application, and we're going to create our own concrete class around it, a decorator, which is going to intercept every call to every method within these classes, and yeah, maybe just bootstrap some more telemetry onto it. And we could go and do that manually. That would be great. But remember, this is a big application. It probably has thousands of classes. It doesn't make sense to put all that much effort into actually doing this manually. So not worth it. What could we use next? And now for the second part of the talk, source generators. We can use source generators to actually, that will allow us to actually create these decorators for us. So let's try to do that right now. Switch over to our IDE and let's start working on a solution. So we have a project here called Telemetry Source Generator, which is a standard component that targets .NET Standard 2. It has a couple of tags, properties that define that this is something that has to do with Roslyn. So it has to do with compilation. And it also houses 3 different packages here. And these packages allow us to actually view, analyze, and maybe even manipulate our source code. So it has access to the syntax that we actually write in our applications. And it also has the semantic information around that syntax needed to make sense of what's what. Okay, let's connect this source generator to our application. We are going to go to, we built it, sorry. We're going to go to our project information, and we're going to add, oh, sorry, something came up here. We're going to go to a project file, and we're going to add a the source generator as an analyzer. Now, usually what you do is you get these analyzers as NuGet packages, so you don't actually need to have a project reference within our solution, but this helps to sort of move things along and develop things as we demo everything. So we are going to reference this project, and we're going to say that this is an analyzer. This means that the compiler will know it has something to do with compilation and may be a participant in the compilation process itself. We're also going to say that we do not wish to reference the output assembly. Why this is important? Well, it only makes sense to use this package during the actual build. This means that the artifacts we produce, well, we don't want to include it in our final product because no one actually needs it and it increases the size of our application. So we say, don't reference anything, just use it for the compilation part. Okay, the next thing we are going to do here is we're going to go to our source generator and we're going to start generating some source. And to do that, we are going to create a class that derives from or implements an incremental generator interface, which in turn exposes a single public void initialize method. And we're going to specify that this is a generator and it's generating C#. Great. Next thing we need. Well, we need a sort of a point that will allow us to generate telemetry. That is why we're going to register the output for this telemetry. Now, what is this exactly? We've seen it in the start, where we needed to specify a default activity source for our application. So in that case, we could just use that, but we don't need to explicitly provide it. So let's make the compiler work a bit harder here. And to that case, the compiler actually creates this for us. We don't need to do it. Of course, we can, and it makes sense if you want to overwrite and provide some of your defaults. Perfect. Otherwise, the Roslyn source generator can take care of the, let's say, heavy lifting. So in our generated code, there was a syntax tree created. Why I'm saying a syntax tree and not a file, because the files you actually see here usually do not exist on the disk. They are a part of the compilation. They are generated during compilation, but they are not output to any physical media, just because the compiler doesn't actually need them to be, right? We have this cool little feature in Rider that allows us to actually view the generated source. And what we created was basically exactly the same thing as we needed to do manually beforehand. Okay, so we got the prerequisites out of the way. Let's see what else do we need to create. Well, we need to go in our application and we need to decorate all of our interfaces, right? And I'm not going to go into details on each of these implementations, but let's just see for a brief second of how we can actually decorate our interfaces. So our input is the incremental generator initialization context, which gives us access to several different types of source providers. And one of these providers is a syntax provider, which allows us to traverse throughout our application and find all the syntax trees that are within our application, and then filter these based on our criteria. And what we're looking for is interfaces that are public. Of course, these could mean private or even internal interfaces. We just decided to do this only for public types. And then we need to extract some pieces of information that we find valuable in this case. We are going to combine everything up with the assembly information provider, which is just another type of provider that does not provide syntax, but it provides us with the ability to view, properties of the assembly that we're trying to generate code for. Okay, next thing we need to do is we need to register some provider for a source output. Now, this action is going to be executed later by the compiler. It may be executed several times. It may be canceled between, but in turn, what will happen eventually is we are going to produce a source. And this source is going to have some kind of a hint name, which again is not a file that is somewhere on the file system, but it's just a symbolic information that allows a bit of a clearer visibility of what was created. Right? And that's pretty much it. By the way, we are using a syntax rewriter here, or maybe even cannibalizing it. So the input is our interface, and the output is our generated decorator class. And what we get in turn is for each of the interfaces is this class, which actually implements this interface. And we also get this cool little feature that allows us to start the activity, call the base implementation without changing anything, catch any exceptions, again, throw them because we do not want to change anything, but it allows us to set the status of our activity to an error state with the exception included. And at the end, it allows us to dispose of this activity. And that's pretty much it. Okay, so now we have the telemetry part down. We have the decorators. Now we need to somehow include them within our application. Yeah, we could do that manually, but hey, we have Roslyn to play with, right? So next thing, we need a way to allow our application to sort of bootstrap itself with this. And what we can come up with is a way to intercept the logic at the very point where our application is being built. So when the service collection, the services that we registered before, are being turned into a provider, a service provider. Let's have a look at how this looks right now. If we go back to our entry point, we can see that we are specifying that our web application should add some application services. And now, complexity of this application, so some sort of a rate limiter. We're adding a couple of these stats provider, which allow us to access the GitHub API, to access some local stats, and also to access some application cache stats, for example, right? Now, what we want to do is we sort of plug in to this process of converting our applications or the services, the registered services from the registered one into the service provider. Sorry, guys, I seem to have some connection issues. Okay, I think we are good. Perfect. Sorry for that. Okay, let's quickly bootstrap this up. So what we can do is we can say a simple thing, enable auto instrumentation, let's say true. How did that happen? Let's see what happened. So as a part of our source generator capabilities, we generated this extension class that allows us to intercept our web application builder at the point that it's building the application, find all of the services or all of the decorator classes that we've actually built, and then decorate existing services, so replace them with the ones decorated. And it does then that, unfortunately, at runtime. So this is the downside. It does it at startup, but it's still a runtime thing. But if we start the application right now, and it has started, let's go over to our front end. Let's type in my name. Oh, now we get a lot more information that we can work with, right? So we're starting again. Nothing has changed from the start. We have an ASP.NET Core telemetry source that is providing us with this sort of an input into our application. We have our manually instrumented handler, and then we have a load of other handlers that we actually instrumented, sort of automatically manually instrumented ourselves. And yeah, that is far more information. Let's have a look at this in our Jaeger UI, just to see the extent of the information that we actually got here. So we have this operation that is just fully described with every call to every method that has every piece of information that you could possibly need to at least start debugging our error, right? One cool thing here is that we can also see the graph of what our application is doing, right? So we're starting the request, we're going into our handler, we are going into our GitHub stats service. We are then doing two things at once. First of all, we're validating if the request was correct. Then we are going to the cache service stats provider. Then we are going to some stale local stats provider. So we are caching things in our application and then in our file system again. Then we are going to some rate limiting stats provider. And then finally, if everything works correctly, we are going to the actual GitHub API to see the statistics. Perfect, right? So now let's start this again. It got to the GitHub API. Oh, let's start it again. No, it didn't. Now it stopped at the cached provider. So we can see that the application behaves a bit differently based on some circumstances, right? And if we press this again, ooh, okay, there was something. We didn't hit the cached stats provider because there was a miss in the cache, but we tried to get it from our GitHub API, but we rate limited it. So the application behaved differently as well. And that's it. That's the information that is needed to actually start debugging our applications. And yeah, source generators to the rescue, right? Yeah, but there are things that are missing here. So first of all, it only makes sense to decorate interfaces. It gets much harder when you start dealing with concrete services. It's very easy to intercept the creation of an application to provide these decorated implementations if you have a single source of these things. So if you have a single input, a single composition root, then you can sort of go around it, intercept the creation of our application, and then decorate it. But what if you start newing up things all over the place? Then source generators kind of break down. The issue here is that they are not allowed to manipulate the existing code base. They are an additive approach, so they can only add source code to your application. They cannot change it. And yeah, these are the downsides. So I guess this is the end, or is it? So in a couple of months, we are going to receive a new version of .NET. Yay. And with that, a new version of the compiler. And with that, a feature called the interceptors. Now, interceptors are coming up in .NET 8, and of course you can try playing with them in RC version that is go live right now. But they come with some of the disadvantages which I want to talk about before we actually go and see what this is all about. First of all, they are a preview feature. This means that while they will be added to .NET 8, they're going to be behind a feature flag, and they are subject to change or removal in some future version. So keep in mind. Also, there are limitations that apply to our source generator, our interceptors. For one, they can only intercept classic method calls. There can only be a single interceptor. And yeah, you need to allow the actual preview feature to be a part of your project. So let's just, for sake of trying, let's try to generate our telemetry using interceptors. Okay, let's go to our application, and we are going to do a couple of things here. First of all, we are going to go to our web API, and we are going to allow interceptors to actually be used in our application. And we can do this by adding interceptors preview feature. This is what allows the compiler to actually see, okay, we can use interceptors, start looking for them. Next thing we need to do, as I mentioned, we need to use .NET 8 or a variation of it. So let's go and change our .NET 7 web API. And I'm trying to find the global, here we are. And let's change it to our RC version. And of course, this is a pre-release version. So let's set this to true. And now the third thing we need to do is we need to delete a lot of the code that we do not actually need. So let's go into our source generator and let's remove all of these things. We do not need them. The only thing we need is the output for interceptors. And also what this means is that we do not actually need to instrument our application explicitly. It's going to be done for us by the compiler. So right now, if we build this project, and run it, we're going to see that we get basically the same things with a little extras. So somewhere in the application is a rate limiter that does not implement an interface. Somewhere in the application is a local stats file repository that unfortunately is newed up somewhere in the source code and not in our service provider. So now we get the exact same same activities being created, but we get a lot more information in here. And the fun thing, the good thing here is we didn't have to actually change our application code, with the exception of actually allowing interceptors to be to work, to do its thing. So before we conclude this, let's just have a look at how interceptors actually work, or what are they exactly. So in this initialized stage, we are going to register the output for interceptors. And in here, we are going to get, well, some syntax that we're interested in. And what we're interested in is syntax or method invocations. This means that we are looking for any place that invokes some piece of code, something like that, right? Then what we do is we generate static extension-like methods around it, and add an attribute to them. And let's see some examples again with the source-generated code. So we add an intercepts location attribute. We point it to a file. This is my particular file on my particular machine, or at least it looks like. This is actually the normalized file. It just points to where the file was located during the actual build time. And that's enough for the compiler to actually build the solution. Next thing, we are going to provide a line, which is the line where the invocation starts. And we're going to provide a column, which is, again, the column where in that line where the first letter of the invocation method is actually being called. Just a quick note here, this is a 1-based index. So lines don't start from 0 and columns don't start from 0, but from 1. And then what we're just doing here is we are doing exactly the same thing as we did with our decorators. And our application is now intercepting all of the internal logic. And I think to a degree, we have reached our conclusion, and we now have an observable application. And to that end, I am going to say thank you very much for listening. And please, the source code is available at my GitHub profile, and reach out on any of the social platforms if you'd like to talk. Thank you.
Someone removed me again.
That wasn't me.
Thanks, Denis. Great session. I liked it. I also pulled in one of my friends just because I know he's so curious about this whole thing with Roslyn. Before we get into questions, man, chat was out of control about the debate about light and dark theming, etc. I just have to tell you, I have 2 key lights shining in my eyes, and it looks like Denis might have the same. Yeah, our eyes are burning.
Sorry.
All right. No, all good, all good. I'm also voting for light theme usually. But yeah, we see a lot of people say dark mode. Anyway, so I will start with one of the questions, exactly from Stefan, my Roslyn source generator curious friend. How did you get into Roslyn in general and source generators in particular?
Really good question. So yeah, I actually started with exploring what Roslyn can do. In recent years, Roslyn has become sort of available to everyone, right? Everyone can be a part. Everyone can actually learn how to create components that are a part of the compilation. They can start meddling with some diagnostics being returned in the IDE. They can provide something that refactors our code on the fly. And for me, this get code was actually something that I needed at my workplace. And I've been exploring source generators for a while, and it seemed like the perfect solution to actually try them out, and it helped tremendously. So I actually started with implementing classes or interfaces, just because I didn't want to implement thousands of interfaces by my hands. Yeah.
Yeah, it's all about automation. I think also I remember the first time when I implemented a source generator, it just feels so magic at first, right? So that you kind of get into this compilation step and you can add a little. And yeah, I think Rachel has a nice follow-up question for that.
Yeah, let's see. Well, I mean, we had a few questions in between the light-dark fight. So these have changed quite a bit since they were introduced. For people getting started with source generators, what do you recommend, especially with difficulties in debugging and all of that stuff? And at this time, I'll also point out that we do have a talk from a little bit of an older .NET Days session from one of our folks, Andrii. So I'll post that here in the chat. So that's the old link. And so you can see kind of where somebody else started with it. And then Denis, you can follow up and tell us the rest of this answer to this question.
Yeah, I mean, I would say start fresh. So what's popular right now and currently the version of source generators? So there are 2, right? There are source generators and then there are incremental source generators. And they solve the same goal eventually, but incremental source generators allow you to process your code in a sort of a pipeline style. So you're not limited to a single kind of output like you were before. You can now add sort of outputs from the start of the compilation and then also observe, so to speak, your syntax. So they are heavily optimized to actually observe the syntax and only trigger when something relevant to you changes. And you can specify a link-like syntax that allows you to filter out the things that you're looking for and are interested in. And then work with that in a really nice manner. So definitely go for incremental source generators if you're up for doing this kind of things, metaprogramming. I hope that answers the question.
I think so.
I have one. We do have an issue. Your QR code doesn't seem to point to a at least not public repository. Is that possible?
Oh,
Oops.
Do you remember?
It may be. I will definitely.
I mean,
check
we
it out
can.
right
You don't
now.
have to. You don't have to do it right now necessarily. We can also put the link right after if you then.
Yeah, the QR code
take a
should
moment.
work. So perfect. I will do that right after this.
Okay. Okay.
Yeah.
Sounds good. Also, I'm very glad you talked about interceptors. If I remember correctly, it wasn't part of the abstract, at least what I found here. But that's seriously cool. I mean, people also pointed that out in the chat. I think that's true. This feature was mainly introduced from the .NET team to help in some cases of their own, works where they want to improve performance. I don't know, whatever. But it is a significant step into the direction of more AOP, let's say, in .NET.
That's what I was thinking this whole time. I'm
Definitely.
like, oh, aspects. And yeah, that really gave me those vibes. I'm glad it wasn't just me, because that was your topic in uni, right, Matthias?
How do you know that?
I think you told me that. I think we were talking about that once. So.
But you have good memory, Rachel, then. Might be that I mentioned that before, yeah. Back then, I remember it was main... So, sorry, Dennis, you go ahead.
No. It's a really interesting thing. But yeah, I mean, source generators kind of feel magic. That's for sure. You can do a lot of stuff with it, but they come with its set of limitations. And then interceptors come in, and they almost feel illegal to a point where you actually start using them and seeing the benefits that they provide. Of course, I'm guessing the APIs aren't done yet, and there are some improvements yet to be made if this is to ever go sort of out of preview into the live version. But it's a really nice feature to actually start exploring, I'd say.
We also had someone in chat saying something about anyone who's going to use interceptors will be fired immediately. Yeah, I can kind of feel that. But it's interesting, even with people initially said, yeah, this is AOP. Now, I kind of still remember that from my thesis there. AOP is mainly also about obliviousness. So the code shouldn't know about that other code is attached. And with source generators, usually you don't have that because you add attributes and all that stuff. Interceptors with this kind of point cut language are much closer already. I mean, yeah, we can probably debate about this whole thing. The main point is you can use this for actually pretty helpful stuff. I think Stefan, I'm not sure if he posted the question in chat, but he told me, at least in our DM, can you kind of estimate how much this source trainer saves you from manual work?
That's a good question. That really depends on the context of what you're trying to achieve, right? So if we just look at the things that we've been presenting right now, let's say you have an enterprise application and you have thousands of classes or thousands of interfaces that you really want to instrument with some sort of telemetry. Well, that saves you a lot of grunt work to start up, right? It doesn't make sense to actually generate source code for some particular issue that you only found in one place. But when you're trying to build something at scale, then it probably saves you a lot of time.
Yeah, most certainly. Also, you're less error prone, let's say, to forgetting, for instance, to add an attribute or stuff like that. Yeah, if your source trainers just scan for maybe even also an interface or public methods, etc. That's much less, or actually not error prone at all if you follow the convention.
you actually take the human factor out of it. So if the human makes an error during development, that of course can be mitigated. But once you have a source generator up and running, you actually know it's going to produce consistent outputs based on the same inputs, right? And also one thing to note here maybe is that there are usually quite a few issues with developing source generators. And there's one cool feature in Rider that allows you to attach to a running source generator. So you can specify sort of the startup project, and you can say start that debugging that generator, and it's going to start debugging with the context of this source generator. So that I found very useful in actually starting or debugging source generators.
I remember when they released that, I had a get hands-on session with Martin, who's very active also in all the MS Build stuff. And we also tried to figure out how can you actually debug this whole thing. Yeah, that was very interesting at the time, because like you said, how it's working right now is so easy to grasp. It's working as intended. Back in the day when they first released that was far from there. So we kind of had to intercept all calls to Roslyn and capture response files and all that stuff. Very, very messy, but it was working. It was working also.
Yeah. Maybe one note here, because we didn't actually have the time to catch up on this, but it's really easy to start writing unit tests or else source generators. And Microsoft actually supports all of the sort of the grunt work behind starting and making the context for a source generator and then generating code. And it's really easy to get the compiled syntax and all of the diagnostics that are produced basically with a single line of code. So it's a nice thing as well.
Are you also using, what was the name again, Verify to test against approved files and all that stuff?
Not in this particular case. I do use it. It's a really nice. So you're talking about snapshot testing, right?
Yeah, exactly. Exactly.
Yeah, that's a really nice test kind to have. I did not use it here, unfortunately. But yeah, definitely tried it out.
Verify tests. I will put this in the chat for everyone that's interested.
Sure.
Made by Simon Kropp. Again, you see this name quite often in the open source community. Do we have any other questions? I kind of lost track because a lot of messages have been posted here.
Somebody's asking, as per the previous talk, masking, removing sensitive information is a challenge, or did we go over this one? Did I miss that?
That was with the Serilog marker stuff. Yeah,
right.
I remember that. But yeah, could still be interesting about, could this lead to logging of sensitive data?
Right.
Also?
Yeah, and the question is if there's any out-of-the-box annotations or anything. So I think that should apply here too, right?
Yeah, that depends on what you're trying to do, right? So in a sense, you could actually capture the context of a single call and log everything, including personal information that is found within this operation. But I mean, to a degree, this is up to sort of the same way of implementing telemetry. You usually do not want to have personal information littering your traces, at least. So absolutely, this entire demo was actually more about to trace the path that the code took, rather than to the components and so on. Of course, that you could actually use tags and events and even baggage to specify these additional things. But yeah, I hope it answers the question too.
I think so, yeah. There was also a question about triggering a breakpoint within a source generator. I guess that's easy once you just have your. I mean, what you can do is actually in a unit test for a source generator, feed it the source code as a string. Good reminder also, Rider has a nice support for that, because you can annotate a string and use raw strings, for instance, and make it an injected language of C#. So then you have completion for all the keywords and stuff. But once you have that, then it's really just putting a breakpoint somewhere in the source generator and inspecting what it's doing. Yeah, so that should be easy from that moment on.
Another way you could achieve this is to manually invoke the debugger and launch it. So basically, it's an instruction that specifies debugger.launch, and then you're presented with a screen for selecting the default debugger, and you start up with the point where you said sort of debug from here.
So from that, I get you're a Windows user, right?
Yes, I am a Windows user.
I have to tell you, I'm such a fan of this debugger.launch, because it's so helpful for any kind of application. Unfortunately, only on Windows, but any kind of application that has a huge load of boot up time, or where you might have issues not knowing to which process you want to attach and stuff like that. Simply drop in the line of debugger.launch and you're there. Yeah. That feels so fantastic.
Exactly.
Yeah. And also in Rider, you can actually replace the default behavior, what you usually have. So then Rider would be automatically added. You have pretty much an unattentive way of getting added to debugging the process. A really nice feature. All right. Do we have any other questions? Did I miss anything? We have like 2 places where we collect questions.
Yeah, I think we got all the ones from YouTube. Well, I mean, there was one that just simply asked, a tiny one in the stream. It said, are there any geeks here? I'm going to say, yeah. Yeah, it's kind of what this is. So there's the ever important question.
I do have a good one. So chat, you are talking about, light theme, dark theme, etc. The more pressing question is probably, what are you going to use, tabs or spaces?
Oh, no, I knew it was coming. That word, like, where does the curly bracket go? The internal fights of the developers.
Unfortunately, I cannot create a poll for that, but I assume a lot of people will say spaces. That's my guess. But chat, please either prove me right or prove me wrong. I'm good with both.
Well, actually,
Tab
while we're
spaces
in here doing little off-the-cuff polls, who else? We know Stefan is doing this. Anyone else out there working with source generators and Roslyn in anything production? Drop it in. I want to see what you're doing.
Also, I like this response. Spabs. Yeah. On point. Spabs. But I'm surprised. A lot of people use tabs actually. Yeah. And I'm not sure if many, I mean, to me, it was not obvious for a very long time, but there was a good post on Reddit about this debate, and well, tabs help people with, let's say, limited abilities to read code, to have a better, to add personal preferences, like in text size, like how much they want that indented, etc. So yes, technically, I think tabs are the much better choice, because it's in the responsibility of the viewer of the code or of their IDE to actually show you or show it in the best way. Yeah. I also remember ReSharper has a nice feature for that, which basically normalizes all of that. So even with spaces, you can then indent, etc., or it at least has a consistent style. Because, like, who said that? What was it? Guys, yeah, with spabs. The worst thing you can see is a file with both mixed, yeah, where everything doesn't align.
a lot easier with a good IDE, though. I'll just reformat it for you, set everything the way you want it, and you're good.
Exactly. Don't worry about these things. Don't expose yourself.
Yeah, it's fun to argue.
Take the side of the IDE.
I mean, that's what the internet's for, right? It's like arguing with other programmers about things that really don't make a difference to the business value, right?
There was also a question about why I didn't.
Someone
catch
commented
that,
that the GitHub repo isn't public yet. I didn't actually manage to enter the.
Oh, and camera gone.
I'm like, is this my internet? His internet? That's not mine this time.
Yeah, I also always have to ask, like, is it are those my headphones or whatever?
Yeah.
I never know, so I always have to ask. Yeah, Rachel, then it's just the two of us.
It's just us. Oh, I didn't even carry my flask into the office today, because we were online. So,
carry to the office, like those couple
from
meters?
the kitchen, basically, from the bar area over to here, So, oh, I think Giorgi is almost ready to join us for the next talk. So, well, I think everybody enjoyed the last talk anyway. It was quite informative. A lot of good stuff in there. Last two talks.
A lot, yeah. For me personal, again, also one of my favorites so far. Just because of the Roslyn stuff. Denis, do you want to come back here? Just not then? Then I will add you again. Yeah? Okay.
Oh, here we go. Hello again.
Hey, sorry for that. We have some internet issues apparently in Ljubljana. Yeah, I think someone was asking that the GitHub repo is not public yet. I'm working on this two-factor authentication confirmation.
In situations like these, it's a pain, yeah.
Yeah.
But there was also another question. I'm not sure, I will let me put this into the right light. I also written a source generator and haven't made it incremental, just because time, yeah. Have you thought about that, or are you thinking about it?
So you're asking if I want to make the incremental, so a regular source generator and turn it into an incremental one, or maybe I didn't.
More or less, yeah. To be honest, I haven't looked at incremental source generators just yet. But I know this question could be relevant, at least it seems.
Yeah, so I mean, I'm guessing that at least the final product is going to be the same. So you're still going to have a number of source files created based on some customized rules that you set up beforehand. But at least incremental source generators allow you to sort of specify these requirements. So the syntax that you're interested in a more fluent way, I would say. So you can sort of create you can create a sort of a link expression that will allow you to observe certain types or certain syntax nodes, and then act only when these change, right? And there's a lot of caching going on behind the scenes, and a lot of processing doesn't actually need to happen because this caching can take place. So instead of, let's say, recreating hundreds of interfaces, you only need to recreate this one that has changed. And of course, this only affects the build time, right?
Yeah. I mean, incremental source generators are definitely a bit harder to write, and with the, let's say, easiness, if that's actually a word, I have no idea. That it's much better maintainable, I think, if you start with a simple one also. All right.
And also, just a quick note: my GitHub repository should be public, so I'm hoping this QR code is.
Oh yeah, it's live. I will put it in the chat so people don't have to seek back to actually find the QR code. I will put it there. Everyone, go check it out.
Awkward
And
silence.
Am I right? Maybe there's another one with the same name, but did you also have the no, you had the talk about build automation and stuff, right?
Oh yeah, that was way long ago. But it
just
was
a year,
yeah.
no?
Yeah. Oh yeah, a lifetime ago.
But you know, I want your opinions at some point, maybe sometime later. But that would be nice, because I watched it yesterday, just as preparation, you know, for who am I going to see today? Who have I the how do you say that, the opportunity to host and support? So yeah,
wow,
if you're interested,
thanks.
maybe,
Yeah,
maybe
let's
we
catch
can have
up,
a chat.
definitely. Let's catch
that would
up.
be cool.
But yeah, Nuke is great. Nuke is, it allows you to do some stuff you wouldn't normally even dream of. So.
Thank you. That was actually very interesting. Also, that you had some kind of the same experiment that I underwent. Okay, should we switch to Giorgi already, or are we gonna fill 7 minutes? I have no idea. Giorgi, are you ready? Show thumbs up, maybe.
Looks like he's ready.
Yeah. Okay, then Denis, it was really nice having you.
Nice to be here, everyone. Thank you.
Great talk.
Nice seeing you, Denis. Thank you.
Here.
I hit the remove button. Let's add Giorgi, because I'm not sure, you know, we still have like 6 minutes, and I kind of want to stretch it so we give our other speakers also enough time and stuff like that. Do we have any other good questions to ask in between? I have no idea. Where's our list here? I don't have a good one right now.
Oh, let's see. It's a stream full of tabs, spaces, dark,
I have
light.
a good one. Rachel, I have a good one,
okay.
Maybe, and that fits nicely also with the Roslyn stuff. What one feature from other languages would you bring to C#? Very good question. Whoever wrote that into our, you know,
oh, I didn't see that one.
Side notes here. That's a good one.
Yeah, this is a good. Oh, actually, this would be a good one to ask everybody as they join in. So to me, I'm kind of at the point where I'm thinking, like, let's back off on just grabbing new features from every Tom, Dick, and Harry language out there, you know, because then, well, you end up with C#.
I think the one for me that I would appreciate the most is what I've seen in Kotlin, and that is the return expression. So
actually, that's a good one.
What I do in C# quite a lot is trying to get some data, and then I'm checking for null, and then do an early return or whatever. Yeah, and I also expected discriminated unions, of course.
Yeah.
But the return expression would fit so nicely with just the throw expression, you know, throw exception expression, which you use in switch expressions. Everything is expression, meanwhile, these days. But so yeah, that would be my personal favorite.
Yeah, there's a couple of good ones where I wish that the C# team would put them in instead of some of the stuff that they've been grabbing at recently. But that would be one. Yeah, the discriminated unions, F# functional folks are good with that. So.
Are these the only ones that I see in the chat? Green threads also.
Oh, that's an interesting.
Yeah, green threads. There was a Twitter discussion recently, but I forgot to follow up on that. Discriminated unions, union types, yeah. So nothing else. If those get delivered, then everyone's happy. Kotlin's inline functions.
I don't know that you'd go as far as saying everyone's happy. There's always going to be something. So, or something that C# won't have that somebody needs. That's, you know.
Inline functions, I haven't looked at those actually. So something for me to check out afterwards.
Link
Ah,
without
Matt.
paying for the function calls. Matt, he's throwing down the gauntlet there.
I remember,
So
wasn't there
entitled.
wasn't there several attempts already to actually solve that? Like I remember probably around 4 years ago, I know there was a project being promoted for a while, which would rewrite the stuff from link chain calls and all that stuff. Yeah. What do you like in JavaScript?
Wait, some of the cool factor from the cool kids. Oh, sorry, we're .NET.
All right, cool. I think we have 2 minutes intro. Now let's bring in Giorgi.
Yeah, but also you could write JavaScript on the front end and look cool kid and still do your .NET too. So, hello, Giorgi. How are you?
Hello, I'm fine. How are you? Nice to meet you.
Hello. Yeah, it's fine. It's a nice day so far. We hope you're ready. We will just give you the stage right now, if you're up for it, and disappear and watch a great talk about Entity Framework.
Yes.
Yes, let's go.
Okay, someone needs to share the screen. I will share the screen. And let's remove Rachel and myself. Good luck.
Hello and welcome to my talk Beyond Relational with Entity Framework. In this talk, I will talk about some interesting features of Entity Framework and SQL Server databases. I will talk about how to keep non-relational data in your relational database with JSON data. I will talk how you can keep the history of your tables with temporal tables and how to work with hierarchical data with Entity Framework Core. So a little bit about me. I have 15 years experience working with C# and .NET. Currently, I'm a tech lead at Space International, and I work mainly with backend platforms. So I use Entity Framework and SQL Server in my day job. You can find some of my open source projects on my GitHub, and you can also check my websites for my occasional blog posts. So today, let's start with JSON data. So JSON, as you probably know, is an open standard for exchanging data between various systems, various platforms, or between APIs. It's human readable and lightweight and easy to parse and generate. So it has become quite popular and common nowadays. The most frequent use cases are to exchange data between different services, between different platforms and services, to transmit the data, to return the data from the service as a JSON, and to also store the unstructured data. And here is what a JSON looks like. So why store data in JSON in a relational database? Well, one, it has several benefits. If you have a relational database and most of your data is relational and you don't need a dedicated document database, you could just store data as in a non-relational way. It will allow you to denormalize your data. You can store nested structures in a single item and avoid complicated joins between tables. And you will be able to fetch all the data in a single query. And also, in some of the situations where schema flexibility is needed, for example, if you are an e-commerce shop and you have different types of products that you are selling, for example, TVs, mobile phones and so on. All these products have different attributes from each other. Some of the attributes are applicable only to phones, some of them only to TVs and so on. So if you need to design a database schema for these products, you would either need to create different tables for different types of products, or have one big table with many columns. But the best approach would be to just store the attributes as a JSON in the database. So you avoid all the disadvantages of the previous approaches. Another common use case is to store the real-time analytics, for example, or data from IoT sensors or some other real-time data. And finally, you can also, if you need, for example, for auditing purposes, you can store API call request and response, or just store the JSON data that was passed to your service from another service as a part of the webhook. So if your data is mostly structured, but you have some small amount of non-relational data, you can just store it in your relational database as well. So let's see in SQL Server how it works. In SQL Server, there is no dedicated JSON type. You store it in ordinary varchar or nvarchar columns like any other text. But SQL Server gives you some JSON functions that we can use to query and modify the JSON data, or extract the individual attributes from the JSON columns. And also SQL Server allows us to create JSON indexes so that our queries on JSON columns are fast and we get improved performance. So here is what a JSON query looks like in SQL Server. If we have the employees table with a billing address column that contains JSON data, we can use the JSON value function to extract the city from the billing address column, and we can also use the JSON value in the where clause to filter the rows. So with this where statement, SQL Server will only return those rows that have states equal to New York. So there is no additional. So all the filtering is done by the entity framework, by the SQL Server in the database. So starting from Entity Framework Core 7, Entity Framework supports working with JSON columns. We can filter by the properties of the JSON objects that we have. We can also make updates, like you update any other data with Entity Framework and expect the change tracker to save the changes. It works the same way for the JSON columns. If you modify a property of the JSON column, the modified property is sent to the database. In version 7, Entity Framework supports only SQL Server, and there is a separate implementation for Postgres. But starting from Entity Framework Core version 8, which will be released in November, there is also support for JSON in SQLite. And there are also some improvements for mapping the JSON. One of the improvements is that if you have a collection of primitive types, like for example, you have a list of strings or list of ints or list of datetimes and so on, Entity Framework will automatically store this column as a JSON in the database. And if you have a JSON property in your entity model, which is a collection, you can now drill into this collection and filter based on some condition for specific item. So let's see live demos now for JSON. I have prepared some data. So here we have the employees table, and as you can see, the contacts column is a JSON array. It can contain one or more contacts. We also have a billing address column, which is a JSON object, as well as primary contact. It is also a JSON object. And finally, we have the links column, which is a JSON array of strings. So no nested object here, just an array of strings. So in the code, I also have the same entity for this table. I have the employee class, which has a list of contacts and a billing address, the primary contact, and a list of strings, which corresponds to the columns that I have in the database. So the contact, you can see it has a nested navigation property, which has some other properties on its own. So first, let's see how the entity is configured in the data context as a to store these properties as JSON. So we can see here that the billing address and the primary contact and the contacts properties, these properties are configured as JSON with this toJSON method call. This tells Entity Framework to that these properties should be stored as JSON. And so if you are starting from the classes and generating your database from your classes, and the migration will take it into consideration and not generate a separate table for these columns as well. You will also notice that there is no configuration for the links property that I have here. This is because Entity Framework is smart enough to figure out that this collection should be stored as JSON, so there is no extra configuration needed for this property. So now let's see how we can work with this data from Entity Framework. I have the context created here for, and here is a query, which is pulling all the employees that have the billing address states equal to Georgia. So as the state is inside the inside this address details class, let's see what happens when we run this query. So here is the generated query printed on the console window, and you can see that the generated query is doing filtering based on the billing address column, and it's extracting the state from the billing address, and it's doing the filtering so that the state is equal to the value that we passed. So even though there is no explicit state column in our model, and we are filtering on the nested property of this JSON object, Entity framework is able to generate the corresponding SQL query, so the filtering happens on the database, and we won't be pulling any records from the database that don't match our condition. So now let's just pull one record from the database and modify the state state of the records and see what save changes is doing. So because so the state was already equal to this value, so it's did not send anything to the database. But if we set we do it again and set the state to a new value and save the changes to the database. Here is the generated update statement, and we can see that entity framework is using the JSON modify call, the JSON modify function call, and it will set the billing address to the current billing address, but it will modify the state property of billing address to the value of the parameter that is passed to this statement. So because we are modifying only the state property and nothing else in the billing address, and the update statement that is generated by entity framework will only send the value of the state that we wanted to set, and will modify only the state portion of the existing JSON in this column for this record. So let's see now what happens if we try to update two columns in the JSON, two values inside the JSON. So I will set the state and postal codes to some new values and call save changes again. And this time, if we check the generated update statement, we can see that instead of modifying the individual attributes of the JSON, it's sending the whole billing address as a JSON. You can see it here in the parameters. So this is the whole billing address sent as a JSON to the database for the update statement. So this is the way entity framework works with JSON. If you modify only one property, it will update to send to the database only the individual attributes that you are modifying in the database. But if you are modifying several properties, it will update the whole JSON object. So let's see some more examples. This is new in Entity Framework core. So remember, contacts is a collection, and it's stored as JSON. So here we are filtering based on the contacts. We are getting employees who have contacts whose name starts with John. So before Entity Framework version 8, this query would not work, and you had to write it manually with SQL yourself. So if we run this query and inspect the generated statement, we can see here it generated the filter condition for our query. So it's using the OpenJSON function from the SQL Server database to get the JSON inside the context and do the filtering for the contacts and return only the corresponding rows. So I'm using the preview version of Entity Framework Core, so that's why it works in this demo. So if you try it with Entity Framework 7, it will fail. So don't forget to update to Entity Framework version 8 if you want to try this before the official release. So this new features which allows us to filter by the contacts by the collection. It also works for projections. So if we find employees who have at least one contact, we can now also use this new functionality in the projection. So we can select the name and the phone of the first contact, and also get the total count of the contacts. So if we run this query, we will see that Entity Framework will include it in the select clause as well as the where clause. Entity Framework can also filter on the nested properties. So here we have primary contact rules dot maximum messages per day, and the generated SQL contains, as you can see, again, JSON value, but now here we get the whole path for the nested object. And we can also modify the nested properties, which will get saved to the database. Again, the whole JSON is sent to the database. And also regarding the primitive collections, which is the new feature in Entity Framework 8, we can find we get the employees who have links and linkwith.com, and we can modify the collection as well, remove the item, add a new item, and Entity Framework Core will generate the corresponding where clause for us and generate the update so that the primitive collection is updated in the database. So this is for the demos. One more thing is for performance. Every time extracting the individual values from JSON can slow down the engine of the database. So for this, we can create indexes to speed up the performance. And to index the JSON columns, we need to create a computed column on the table. This is the example of creating a computed column which extracts the state from the billing address column, and then we use this computed column to create the index. And we can also do the same in Entity Framework Core. We can see here in the configurations that we have a state property, which is defined with has computed column SQLs. This means that this state property will be generated in the database as a computed column. It will not take any additional space, but it will contain the state from the billing address column, and then we can use the asIndex methods that we use in Entity Framework for any kind of indexes, and we can create an index on the state column. So this is how JSON works with Entity Framework Core. Next, we move to the temporal tables. So with temporal tables, as I said, we can keep track of all the history of the table. And for this, so temporal tables is a feature of SQL Server. With temporal tables, every table, the table gets 2 new columns, datetime 2 columns that are used by the system to record the validity start date and end date of every row. And we also get a new history table, which is used to keep the history of our data. So the main table will store the current values, and the history table will store the history of our data. And this is the example of how to create the table manually. But we will see in our demo that we can also create temporal tables with entity framework. It's just, for example, how we can specify the period start and to see that we have the period start and period end columns. When working with temporal tables, you cannot insert or update the period columns. So the period end and the period start table, period start columns cannot be, the values cannot be specified manually. You can't also make any changes to the history table. You can't delete or update rows from the history table. But you use the main table the same way you use any other table. You can query, insert, or update the table that you do with non-temporal table. The period columns are hidden from the user. So if you don't explicitly include it in your select query, you won't get the values for the period columns. So why use the temporal tables? It's frequent to need data auditing for your tables. So if you want to keep the history and know what changes were made and when the changes were made, or if you want to do trend analysis, for example, to make some to get some insight from your data, like how the value was changing over the time, or if you want to implement comparison of versions between different times and allow the users to undo the changes, you can use the temporal tables. It also has some disadvantages, like there is no built-in way to restore data, so you will have to implement that manually. So with temporal tables, let's see how the temporal tables look in the database. I have a database with temporal tables. So we have the persons table. You can see it says system version because it's temporal, and there is the second person's history table, and this is the table which will store history for the person's table. So if we select the rows from the current table, it has some rows. You can also see period start and period end columns, which indicate when this record became active. And if we take this ID here, and if we query the history table, we will see all the changes that are made to this record. So let's run this statement. So you can see this is the earliest record. This was created on 24th and was active until 25th. And the values of the first name and last name were this. Later, I changed the values to my name from on the 25th at this time. And this was active until today morning. And the current value, which became active after this time, is in the current table. So you can see that this period start is the same as the period end here. And the current value is, again, my name, but in Georgian. And this is the current valid record. So how do you query the temporal table? For current data, you just query the current data the same way that you query any other table in SQL Server. And for historical data, you query it with the additional for system time clause, and SQL Server gives us the option to query the historical data for different in different ways. We can use as of clause to get the data that was current at the specified time. We can get all the records that were current from one date until another date with the from, to, or between and end clauses. We can also use the all clause to get all the data, including current as well as historical data. And we can also use the contained in to get all the rows that became active and inactive in the given period. So to use temporal tables with Entity Framework Core, no additional NuGet packages is required. It's all supported from EF Core version 6. The only thing is that when configuring the table, you just need to specify the table as temporal with the isTemporal method call. You perform the CRUD operations on this entity on just like the way you do it on any other table, and you can also query the historical table using the new query operators, which corresponds to the clauses that I showed here on this slide. So we have the methods temporal, as of, temporal, between, and so on, which we will see in a moment. Just keep in mind that when you query the historical data, because there is no way to update the historical data, there is also no change tracking for the historical data, because it does not make sense to track the changes made to the historical entities, because there is no way to save those changes to the database. So let's see the demos. So as I said, the only configuration needed is we specify that these tables we want it to be temporal. It's the isTemporal method call, and that's all. No other changes when configuring our model. And let's see how we can query the data. So here I have this query that is getting the persons with the data that was active 10 hours ago. So let's run this. So here we can see that this first record, this has my name in Latin alphabet, because 10 hours ago I have not made the change yet, which changed my name in Georgian alphabet. So that's why we see this values in. So these values are coming from the history table, and if we look at the generated query, we can see that it's generated the for system time as of and the date time 10 hours ago that I passed. We can also when selecting the data from a history table, we can also use shadow properties to get the values of the period columns, because the period columns are not part of our entity model. So we use this ef.property syntax to get the period start and period end calls. So I'm here selecting all the records that were active starting from 3 days in the past until current time. Because of this contains 51 records, but so the one record is coming from the history table and 50 records are coming from the current table. And again, if we look at the generated query, here we see now it uses the for system time between and passes the 2 dates that I passed in the query. So one more interesting feature of temporal tables is that if you have two temporal tables and if you are joining between them, which I'm now doing in this next statement, I'm including the address navigation property. I'm getting the record that's corresponding to me that was modified, and so this will fetch the current. So this will fetch the current information. So it will show my current name and some current address. But if I do as of in the past, it will now get so my first name and last name now are coming from the history table, but the address is still coming from the current table. But if I now go in the past a little bit more with minus 20 hours, we can see now that my name is still same. That was 10 hours ago. But I think I need to change the time a little bit more. Yeah, so if we do this, if we try this 30 hours ago, we can see that the name as well as the address is now coming from the history table. So when you are using include, both tables, persons as well as the address table, both of them are queried for this time, and we can see it in the generated query as well. Here, for system time as off is specified for the persons table as well as for the addresses table. It's using the same values for both of them. And now let's try deleting this record. If we delete the record with ID that we just saw, we can now see in the table that this record has disappeared from the current table. But if we select the data from the history table, we can see that the record that was current before we started the demo is now in the history table as well. Now, just keep in mind that if you want to recover data from the history table, there is now no such functionality built into the either SQL Server or Entity Framework. So you will have to implement it manually. And one thing to keep in mind is that if the ID is auto-generated, if you select the data from the history table, like I did now, so this deleted variable points now to the record that was deleted. It's used temporal and sorted it in descending order and getting the first one. So it will get the value that was deleted. If you insert it in the persons table again, because the ID column is identity and automatically generated by the database, it will now get a new value. So if we query this table again, we can see that this record now has a has an ID of 52. So even though we inserted it again, there is no way to get the old ID back. So it might become tricky for you to delete and recover to track which record was which one. That was the demo of temporal tables. A few words about the limitations of temporal tables. If you are storing large amounts of data in your table, like globes or NVAR charts or so on, then the size of the history table will also become huge. Truncate operations on the tables are not supported by the temporal tables. Also, you don't get any primary or foreign keys for the history table. This is because for one record you can get many records in the history table. So obviously there is no way for the primary key to work, and there is no built-in way to undo changes. So you will have to implement it yourself if you want to undo some changes based on the historical data. Now let's move to hierarchical data. So first of all, what is hierarchical data? Anytime you work on a human resources application, for example, where you have the organizational structure with people reporting to another people in the organization, or you want to represent file system data in the database for some reason, or you have tasks in the project and you have some tasks that are children of another tasks and so on and so on, or you have pages on a website. All of these are examples of hierarchical data. And if you have worked with it, you probably know that it can become tricky to query the ancestors and descendants of the data. So that's for this reason, there is a built-in hierarchy ID type in SQL Server, which has some useful functions for querying the hierarchical data. So here is an example how you use the hierarchy ID. You use it the same way, just like any other database type. Here we can see that we have the positions table, which has path column, which has the type hierarchy ID. So the hierarchy ID is stored in the database as binary, and it has this interesting feature that if you have two nodes which are hierarchy ID values, you can always generate a new node that is in between these two nodes. But hierarchy ID also has some disadvantages. Well, not disadvantages, but some shortcomings that you should keep in mind. For example, if it does not enforce any uniqueness, and or it does not make checks for cycles, and you can have one record which is pointing to another record in the same table, and have that same table and have that same item reporting directly to the same item, so you can get cycles in the database, in the data. Or if you have record A which has child record B, if you delete if you delete the parent, the A item, you get B with no parent, so there is no built-in way in hierarchy ID that checks for validity of your data. So the hierarchical relationships are not enforced on the database itself. You need to make sure in your code that you don't insert any invalid relationships between the hierarchies, or you don't delete any records so that you leave children without parents. Hierarchy ID type comes with some helpful methods, as I said, to get either answer source or get the level of the current item or get the descendant. So this will help to simplify querying the hierarchical data in your database. Entity Framework supports hierarchical ID starting from version 8. Again, this is a new feature, so you will have to use the preview versions if you want to try this out. You need to install the package from NuGet, which includes the hierarchy ID type, and once after that, you simply configure the in your data context to enable hierarchy ID with this method call. So let's see some demos for hierarchy ID. So I have first look how the hierarchy ID looks in the database itself. So you can see that this is the path. This is the binary representation. But in your code, in our code, the same data looks like this. So this is the root node. This is the first child. This is the child of the first child, and so on. This is second child. These are children of this node, and so on. So you can use this human readable text to parse the human readable text into the internal binary representation. And as I said, you just need to use use hierarchy ID to enable the hierarchy ID in your project. So let's see how we can work with the hierarchical ID from Entity Framework core. Let's first, I have the query which gets all of the data and renders it as a tree, so that we can see what data we have. So here we have the CEO and we have different deputies and so on. So this is the representation of the positions tables that we just saw. So this table, when you convert it to hierarchy, this is how it looks like. So what can we do with hierarchical queries? For example, we can get all the positions on the specified level. For example, get all positions on level 2. We just do a query like this for every position. If the path level is equal to desired level, it gets returned to us, and the query is, and the generated query includes the call to the get level method. So all the filtering happens on the database side again. So this will return all only those positions that have level 2, and we just print it to the console. We can also find the descendants if we are interested. For example, to do that, we use the is descendant of. So we get one of the positions from the database, and then we find all the records that are descendants of this path. The only thing is that SQL Server considers the item to be descendant of itself, so we need to include this inequality here to exclude this item itself from the result set. And then we just order it by level in the ascending order. And again, if we look at the generated query, we can see that Entity Framework converted our query to the is descendant of method call here. And order by calls also includes the get level and pass. So this is how we find descendants of some specified item. We can also use it to find ancestors. We just switch the positions here in the where condition. So we get the position, some single position from the database, and then we find all the ancestors of this position in the organizational structure that we have. And again, the generated query contains the call to is descendant of. The hierarchy ID also comes with the get ancestor method, so we can use it to find the direct ancestor of some record. So if we have this title, we can find the position that is the direct ancestor for this item. And again, Entity Framework just translates it to the get ancestor call on the SQL server side. Also, a common task in when working with hierarchical data is to find common ancestor of two different items in the data. For example, here we get these two positions from our table, and we use this query, so we find all the descendants, so all the positions that this position is descendant of, and all the items that this second position is descendant of. And when we order them in a descending order, we will find the common ancestors for these two positions. Finally, we can see how we can add a new item to our tree. For example, if we want to add someone to be a descendant of this item, first we need to find all existing descendants so that we know where, so that the new item is the next item for these descendants. So if we find existing descendants, then we find the maximum pass. So the maximum pass in our case is 1/2. So the next descendant of this item will be to get the position for the new item. We call the get descendant method. We pass the existing maximum pass of the descendants. So the new item will be descendant of this item. So it becomes 1/3. So it will be in the tree, it will be next to the on the same level as descendants, but next to the rightmost descendant. So if we create this new position here and call save changes, we can see that Entity Framework is sending the human readable value for the pass, which will get inserted in the database, and we will get a new item in the tree below this record. So that's all from my presentation. I hope you enjoyed it, and if you have any questions, I will be happy to answer them, or reach out to me on Twitter or on GitHub.
Yeah, I added myself back already. Rachel will also come.
Here we go. Yep.
Thanks, Giorgi, for this session. It was nice. We actually have a lot of questions. Let's dive right into. Yeah. So my first question was, what brought you to the idea of going kind of beyond relational?
Well, for JSON, I had to use it in one of the projects. So I actually had to use it in one of the projects. So that's how I got into it. The other ones, the temporal tables, I found it on the blog of the Entity Framework core team itself. So it solves many problems that I have solved in the past with some tricky code and some clever code, and there is so many hassles. So it's like, why did not I have it in the past when I needed it? So I think it's a useful feature, and same applies to hierarchical data. If you have used it, you know that you have to use common table expressions for recursive queries, which can be a pain to write and to read later. So these features provide many helpful features that I wish were available when I was working with them when I needed it.
Gotcha. Hearing myself.
Yeah, there's a weird echo.
Don't worry, let's power through.
Yeah.
Rachel, you have the next question.
Yeah, so Lucky Uranium was asking, what are the minimum versions of SQL Server or Azure SQL that support these features? And a sub-question of that is, are temporal tables and EF still only supported with Microsoft SQL?
Yes, so temporal tables are only supported with SQL Server only because it's only supported by SQL Server database itself. So other databases don't support this feature. So obviously, Entity Framework can't support the temporal feature if the database engine itself does not support it. But I don't remember the exact versions of the database of the SQL servers that supports this feature, but I think any modern SQL server will probably support it.
Okay, so second question from me, and actually also from chat. Is there a way to prevent Entity Framework from updating the entire JSON when updating 2 or more fields? For instance, if you modify only 2 fields in a big JSON structure, or does that perform worse? Let me add also a second question about performance. Which one performs better, manipulating data inside JSON column or dedicated table column?
Yeah, so for the first question, I think I'm not sure, but I think it was implemented like that it's sending the whole JSON because the Entity Framework team itself found that doing 2 round trips to the database was actually slower than just sending the whole object in one network call to the database. So that's why they implemented it this way. They are just doing only 1 network round trip to avoid extra network call. But if you have a huge JSON and want to only update 2 properties and not send the whole JSON again, the simplest thing probably would be to call 2 save changes between these between saving these 2 properties. Now it may not be desirable, or it may not be possible because the code also will get messy, but I don't know of any other way to update. Or maybe you just update it with raw SQL and don't use entity framework in such case.
Okay, I'm not too sure. We might not have too much time to ask more questions. What I would like to ask.
A quick, easy one, though.
Okay.
Yes, no, which is, can you add constraints to the JSON properties? Constraints.
Oh, constraints. In SQL Server, no. I think the only constraints that you can add is to ensure that the column is actually valid JSON, and that's all. No, but no, you can't add any constraints, I think, in no database at all. So if you want to enforce relations, then don't use JSON and use ordinary columns.
Okay, good. Giorgi, again, thank you for your session. Like I said, there are a lot of other questions, so it would be really great if you can take a look at the chat right after. I'm sure people would love to hear your perspective on that. Rachel, we will do a raffle maybe in between now.
Yeah, raffle sounds good. So
one more raffle. A good question would be, which host is dropping now?
Sorry, I didn't hear
me.
Oh,
no.
Okay. Yeah, who's
good.
dropping now? Yeah, we got to onboard Matt, and Matthias gets a break. I'm in here for a little bit. So I guess we'll kick off the raffle in between, like sending you off and bringing Matt on, and give people a little bit to think. So there's 2 questions that we have, but I think one might be too easy for y'all to look up. So I'll go with what year did we release our first .NET product, which would be ReSharper? I mean, you probably can look this up, but it might be a little more difficult. So that's our raffle. Well, whoever has the correct answer, I guess, first. Hurry up, get it in there. Nope. Eventually, you're going to go through all of the decades. Someone's going to get it. Josiah just got it, 2004.
Okay, who said that?
Josiah Bradbury. So you can...
Please send us a message at the
send us a
email
message
that we provided there. More years incoming.
All of the at least everybody's in the right decade and generally in the right half. So it's not bad. Decent memories if you're around. So.
Okay, so Matt, I'm gonna add you. Gonna replace me. Hello.
Hello, Matt.
Hello, folks. How's it going?
It's going.
Wonderful so far.
Yeah, I'm thoroughly enjoying it so far. It's been a great set of presentations to watch.
All right, Giorgi, you and me, we will disappear now.
Yeah.
Goodbye, everyone, and you too.
Has to go into the chat and start answering the rest of those questions.
Right. Yeah, there's lots of good questions. Very good questions. Great presentation. Thank you.
So have fun, everyone. Bye-bye.
Bye, guys. So, all right, it's us. And next up is Layla Porter. So,
yeah, always good. Looking forward to this session as well. I'm looking forward to all the sessions. This is good. This is nice to have lots of sessions. Hey, Layla, how's it going?
Layla. Hello. I keep muting because my asthma cough has just flared. I don't know. It's the excitement of coming and joining you lot. So I'm trying not to die right now and like cough my lungs up live
please don't.
on show.
Yes, save it till later, I think.
Okay, I'll try and get through the presentation.
Please. If you could, that would help us out a lot.
Then pick my lungs up off the desk and pop them back inside. Yeah? Okay.
Sounds like a plan.
Good.
Okay, then. So should we get straight into it then?
We're ready. I'm ready.
That's fantastic. Let's fire away then. And good luck and enjoy your talk.
Thank you. Alrighty, so lovely to see all of you. I hope you've all been having a fantastic day. Welcome to my segment where I'm going to talk to you about understanding microservices. It's a guide for a monolithic developer, which I still am. I'm still very much in the monolithic camp. But when I joined VMware 2 and a bit years ago, they're big onto microservices, so I had to learn a lot about them, and I found it really hard. So this was a talk I developed to share the sort of knowledge and answer some of the things that I had, and it's grown over the years as I've accrued more knowledge. So let me get this here. Who am I? Are you going to actually change? Yay. Okay, I'm Layla. I'm those things that you see beside me. I just got my 5-year MVP. I'm very proud of my blue disc. I wasn't sure I was going to get it. So I've been around for a while. So yes, that is me. All right, let's get on to the important things. So you have decided you need a microservice. Okay, so there is one question I need to ask you now. Okay, now that you've decided this, are you sure? And you should be asking yourself that as well. If you've watched all the videos and you've talked your CTO down off the brink of bleeding edge and converting everything into microservices, and you actually have come around to their way of thinking, and you actually genuinely, absolutely do need microservices, this is where you are now. Okay, if you cannot answer this question affirmatively, then you are not ready for microservices. That is my caveat. Okay, so you've asked yourself this question, and okay, you've definitely decided you need microservices. Okay, and this is where the big brain overload starts. Okay, there is so much to think about. Now, I'm not going to go into the depths of whether you should or you shouldn't. This is like, you have answered this question affirmatively and you are ready to go. All right, so the first thing that came up for me was, what is all this gobbledygook? Now, for those of you who don't know what gobbledygook means, that is a phrase for like jargon and weird words. And oh my goodness, is there a lot of weird gobbledygook jargon when you delve into microservices? I mean, generally in tech there is, but particularly when I started investigating microservices, I thought, oh, wow, there are a lot of new words to go on here. So that's the first thing you'll come up against. And then where do you start? I mean, honestly, where do you even begin? You have your monolith and you want to get it all the way over to microservices. That's not an easy thing to get your head around. I mean, how do you even go about creating a proof of concept? It's just a complete overload, in my opinion. So this is the big question, where to begin? And it is the hardest part. You have that blank page. So you could be migrating an existing application of some sort of architecture or something over to microservices. You could be fortunate enough or unfortunate enough to be going with a greenfield development. It doesn't really matter. The ideas about it are all going to be the same. You still need to think about how to support microservices architecture. How are you going to manage your teams? Do you have enough people to do that? But remember, you've already said yes. So you've solved all of those problems first, haven't you? You know how you're going to organize your team. You know that you have enough people, okay? So we've assumed that that is the way, okay? So how do we go? Well, there is a big word here that you must remember: incrementally, okay? This is not something that you do all in one go. This is little tiny steps, little chunks of work, and this is how you are going to get through it, okay? So I'm going to show you how we can start thinking about this incrementally and doing it. All right, so I feel that we need a glossary of certain terms. So these are some of the ones I came up and I was like, oh, I don't know what those are. So the first is service discovery. And this is how your applications and services locate each other. We'll look at that in more depth in a little bit. A load balancer, you've probably already come across that. Some of these are not specific to distributed systems, but load balancers are important, as are circuit breakers and any kind of policies around resiliency. We're not going to cover those today because they're an implementation and a how rather than a big picture, okay? API gateways, again, you may have seen those before and looked at those, but they're a real key fundamental part of microservices. So that is a nice pinch point for everything outside to speak to everything inside or in the back end, okay? And then external configuration, this is where all of your configuration is stored elsewhere in a shared repository. So that could just be a file on a server, or it could be a whole configuration server somewhere, or it could be in the cloud somewhere else. And then the bounded context is all of the things that your microservice does, the sort of models and concepts and relationships and rules. And that's almost like a public facing thing. And that's for other services to look at. And so that's where you cross the boundary so that one service knows how to talk to another service, okay? Now, I love a good demo project, and usually they are always around food. I'm a big fan of food, and this one we're going to be looking at Taki Tacos. So this is an e-commerce food ordering site, and things get crazy on a Tuesday for, guess what, Taco Tuesday, and we want to scale to meet the business demand. This is a hugely growing, successful food truck business. So just go with it. And we also want to be able to add additional services into the system without disrupting anything. Things like order tracking, you know, so you can see if the delivery person is nearby, so you can warm the plates ready for your food, things like that, you know. So we want to be able to add all these things without disrupting the broader system and to be able to scale dynamically. Okay, so what we have at the moment is our monolith, and it's got all of these things. Now, I'm not going to say how this is architected underneath because it doesn't matter, because I don't know how your applications are architected. That's very specific to your systems. And this architecture could be anything. It could be a big ball of mud. It could be a beautiful, clean onion or a hexagon. It could be vertical slice. It could be anything. It could just be a jumble of 25-year-old code in, who knows, in classic ASP. Who knows, okay? It doesn't matter. This is what you've got. But how it's architected is going to determine how easy it is to decompose into microservices, okay? So that's something that you're going to have to deal with on a case-by-case basis. So decomposition, that's what we call the breaking down of a monolith into little pieces, okay? So we have various options ahead of us. So let's have a look. I stole this chart from a teammate who in turn stole it from someone else on my team who stole it from someone else. So I don't actually know the origins of this diagram, but it's a good one. And thanks, whoever made it. So along the bottom, we have modularization. So that is distinct units of code. And then we have distribution. Now we're going to just call this the big ball of mud down in the bottom left-hand corner. But that doesn't have to be a big ball of mud. That could be a very nicely architected monolith. They are not one and the same, okay? Just this diagram happened to say big ball of mud, okay? Because it can be a problem. We have all this like lack of decoupling going on in a lot of these monoliths. Over time, they just sort of become more closely coupled and more tangled. All right, so what we want to do is this, isn't it? We want to go to microservices. We just want to go there. But if you go this direct route to microservices, oh, I keep deleting this. I keep deleting that bit of text and it keeps coming back. I don't know what's wrong. You'll probably end up here, okay? It's like the 5th time I've deleted it. It's the line of text that just will not go. Okay, never mind. That says you will end up here. Okay, and why will you end up here? Because as you start to break down your monolith into microservices, you're going to take a unit of work or whatever it is, that's the wrong term, a chunk of your code. You're going to be like, this is my microservice, and you're going to take it off, okay? But then you'll come across something else in your application and be like, oh, that really belongs with that microservice, but oh, that's deployed, it's working. I'll just stick it in here with this one. And you deploy that. But now you've coupled those. And another example of this is also if you don't have distinct databases. So you have to deploy another service at the same time as the one you're working on to update your code. So anytime that you cannot deploy a single service in isolation, without having to touch any other services, you have made a distributed big ball of mud, okay? You are not truly distributed then. You have made a big old mess for yourself. You are in the worst place of everything. You have none of the cohesiveness and ease of deployment and debugging that you have with the monolith, and you have all the pain of the distributed systems without any of the gains, okay? So you do not want to end up in that distributed big ball of mud. So what you will need to do is go via a modular monolith and up to microservices. Now, you don't have to go the full hog on a modular monolith, and that's a whole nother talk, okay? You just need to go through and modularize your code and tidy it up so you have things ready to go, okay? And I like to call this the Kit Kat pattern, okay? Now, if you think about a Kit Kat, you can just take it out the packet and take a big old bite of it. You'd be so wrong to eat a Kit Kat like that. Let me know if you eat a Kit Kat like a monster. I'm sorry, I didn't say a monster. And take a big bite out the corner without snapping it off, okay? But let's just say you have your Kit Kat and these are all your modules. And then when you are ready to break one off and scale it and make it a microservice, you snap it. And now look, you've got 2 chocolate bars, okay? You've got your big one, and then you've got your individual one, and that's kind of like your application. So I like to think of your monolith, your modular monolith, being like a Kit Kat. At any time, you can snap one of those fingers off, and you have it ready to go. It's its own discrete chocolate-covered biscuit, ready to go. It didn't need any help from the others with chocolate. It's ready to go, okay? So how does that look? Well, when you're starting with your decomposition, think large modules, okay? As big as you can. That's a really good start. You do not want to get too small and too granular when you start. Remember, we're doing this incrementally. So we're going to keep our nice, big, large modules. Now, as you progress, you can easily break those large modules down into further modules without affecting any of your other modules. And now you're getting more distributed little microservices, okay? So this is the way you can go. And the thing that you have to bear in mind is loose coupling and high cohesion. That's really the crux of what you're doing when you are decomposing your monoliths, okay? So by this, I mean that you have high cohesion. So everything in your module, which will become your service, or even if you're just going from greenfield and you're creating your service from scratch, it needs to be closely related. It's all very similar data, very similar functionality, and that has high cohesion. But it can all operate on its own without any assistance from another API in another module or service. So that's your loose coupling. And so that is really, really vital that you maintain that. Okay, and as long as you've got that in the back of your mind at all times, that's going to be really, really beneficial. All right, so let's go and have a look at our monolith. So we've got our KitKat modular monolith, or your nice tidy monolith, and now we're ready to snap things off, and I like to call that the satellite pattern. Okay, so now we've snapped off biscuits and we've got those around our KitKat. They're satelliting, they're orbiting your monolith. So in the case of Tacky Tacos, we have our monolith, and then we have our satellites. In this case, we have a customer, the client, and then we have a notification service. Now, things like a notification service are really well suited to being broken off into a satellite. They're not functioning all the time. You'll have peaky workloads, perhaps when you're sending out a newsletter. It's a slow process because when you're sending out emails and stuff, it chugs through them, and you don't want that slowing up your main application. So it's a great thing to take out and throw into a serverless function or something like that, that will scale to nothing, okay, and cost you nothing. So that's a really good reason to have satellites. And that may be where you stay for a while. You have your monolith and you break off all of these little satellites and you go along with that. And then as you progress, you incrementally increase the number of satellites your application has, okay? So that is basically what I mean by incrementally building your microservices, okay? You break something off, you test that it works, and then you carry on. Okay, so now is a really important time to talk about scope. And this all comes down to that high cohesion. Let's think about our taco food truck. Okay, so at the moment, we're being served excellent tacos. They have a nice choice of tacos and they're delicious, okay, because they're just making tacos and they're really good at making tacos. But someone says, hey, we should diversify. Let's make hot dogs. Okay, it's kind of like a taco. It's a thing and with a thing inside it. It's kind of like a taco, similar. Okay, that's all good. Oh, let's make a hamburger. Okay, we're diverging a little bit more, but it's still kind of similar. And now we've got pizza, and now we've got noodles, and now we've got rice, and then we've got sushi. I mean, I'm not going to eat that sushi, okay? I'm not happy about someone who is making tacos also doing the sushi. I just don't think it's going to taste good, okay? So now it's all doing too much, and then now they're going to add cake, okay? And it's all gone out the window, all right? So your applications can do this as well. They'll start to get too many things happening. And another thing that you need to bear in mind when you're building is that a service should do one thing and do that one thing well. Just like that food truck should have stuck with just making tacos, okay? So this is a really key, important thing to remember, is that it just needs to do its one job. Now, that doesn't mean it's one method or something. That's just a whole load of cohesive, similar things, like all around orders, okay? And people often say, well, how big can a microservice be? Well, as big as it needs to be and still do its one thing well, okay? It may be a couple of lines of code. It may be thousands of lines of code. As long as it's highly cohesive and loosely coupled, that's what matters, not the number of lines of code, okay? So let's have a think about the scope of each of our services. Now, we've broken it down into big chunks. We have that customer UI. We have our order service. We may break that down further at a later date. We've got a payment service. We've already talked about the notifications. And we have a food service, which is like dishing up all of the recipes. Okay, so this is how we're going to break things up, and we're just trying really hard not to overcomplicate stuff, okay? In this example, I haven't even got like the catalog management portals or the admin sites, okay? So we're just thinking they may all still stay in your monolith for a while, okay? But what this does allow us to do is to start scaling on that Tuesday for Taco Tuesday. Okay, so we've already got that scalability just starting to come through by having these incremental changes, and we're already going to start to see the benefits of this system. Okay, so now that's kind of the overall picture of how you start approaching the decomposition of your application. Let's think about some of the key things that you need to think about. Now, we've got all these services. There's something that they all need to do, and that's communicate with each other. They all need to be able to chat. Otherwise, everything's going to go rather awry. So how should they communicate with each other? Well, there are two ways. The first one is synchronously, and this is not to be confused with things like async and await in your code. This is to the bigger picture. So with a synchronous thing, the type of communications that are synchronous, HTTP and REST, gRPC, SignalR, like WebSockets, TCP. So, you know, all of these things are what we would consider synchronous. And that's because they send out a request and they expect a response, and they will wait for the response or timeout. Okay, so that's what makes them synchronous. So in our services, we have our customer client, and we want that to be able to synchronously communicate with the order service and food service. Now, a general good rule of thumb, I would say, is that when you're deciding what type of communication each service should have, is if it's talking to a person, it should be synchronous. If it's talking to a machine, it should be asynchronous, okay? Rough rules. So our customers are going to come up and they're going to want to order some food, and they're going to go, hey, show me what's on the menu. They need a response. You don't want the system going, okay, I've asked for some menu stuff, I'll get it eventually. You don't want that. You want it, hey, give me some food menu items to show my customer. Great, got them, showing them. Okay, so that's kind of it. Same when they're posting their order. You don't want to be like, yeah, I'll let you know maybe if your order is placed. You want to say, yep, order's placed. Okay, you want that positive response. Okay, so those are the things that are synchronous. So those are definitely synchronous communications. So you've guessed it, the other way is asynchronous communication. So the first example of asynchronous communication is queues or one-to-one comms, or buses, one-to-many comms. Okay, so you've probably heard of service buses and things like that. And I'm sure other Layla was talking about that earlier on today if you saw hers. Okay, so we're going to sort of think about service buses and how they work, and message brokers, and they kind of work very similar. And that is, we have a producer and they send a message, and that's it. They don't care anymore. They've done their duty. It's kind of like fire and forget. They've put a message onto the message queue, whatever that might be, that the message broker is doing. And then our consumer, the service that is interested in that a message, will go and dequeue it. Now, this has built-in scalability because you can shove as many messages as you like on that message queue, and the consumer will just chug through them at their own pace. Okay, there's not going to be a like, oh my god, no, can't cope, flat, can't respond, nothing, bound, collapsed. Okay, it's just going to be able to chug along and process that. So you can see now that that's the kind of thing that would be great for email notifications, or doing things that are long running, such as PDF creation. All those types of things are great to shove onto a queue. And now you can see why they don't get an immediate response. So in our system, we're going to be looking at everything where machines are talking to machines, okay? And we'll send out that notification. So the order service is going to publish to our message broker, in this case, a pub sub, which is a publication subscription model, okay? So we're going to publish subscribe model. There we go. So it's going to publish things to it and other things are going to subscribe. So we'll have an order and that will be published by our order service. And they'll be like, okay, there's an order. And then the payment service will be go, oh, I'm interested in new orders. I'll take that and I'm going to go and process a payment. And the notification service might also be interested and it's going to come along and go, oh, yeah, I'm interested in that. I'm going to send them an email saying, yes, we've received your order. The kitchen is definitely going to be interested in that. They'll be like, oh, we've got a new order. We better start cooking. And so you can start to see how you can talk to lots of different things as well, which is really good in these types of systems. Otherwise, the order service is going to have to go through and make several API calls like, hey, payment service, go do a payment. Hey, notification service, go do a notification. Hey, kitchen, here's a new order for you. It's going to have to do all of those things. And that's not great, okay? It's outside its scope. It shouldn't have to worry about all those different things, okay? So take that away from it. All right, so those are all asynchronous, and you may have heard that this is sometimes referred to event-driven architecture or event-driven design, and message-driven design or architecture. Okay, that's what it's talking about, this sort of asynchronous stuff behind the scenes. So putting it all together, we have now sort of the front-endy stuff is synchronous and the back-endy stuff is asynchronous. And then we can start adding in as much as we need to. So for example, the admin site, that's human-y contact. So that needs to be synchronous and we could do gRPC there if we wanted, because maybe it's a Node app or something, I don't know, and you fancy doing that. Kitchen service is going to publish its orders to a screen in real time. So we'll use SignalR or WebSockets. So we've got that synchronous, but it's going to receive new order notifications from the pub sub. So you can start to combine it all together. And as you start layering in all of these new features, you won't be disrupting the existing ones, especially if you are sticking to that high cohesion loose coupling, okay? All right, so that's our communication data, all right? And what do we do with it? Now, as a monolithic developer, you're probably used to a big old bucket of data, and we've got this one database for your entire system, okay? So you may well be tempted to just keep that one database for your entire system, okay? And maybe you did your modular monolith, and you just kept the single database because, hey, it's a monolith, okay? But remember this, the distributed big ball of mud, that's what's going to happen, okay? Or it's a strong likelihood. You are going to create a big ball of mud because, I apologize for the DIY going on. I don't know where that's coming from, if you can hear the banging. So what will happen is, let's say you're doing a migration from your application to your database. Okay, you're going to do a migration. If you're sharing that database across multiple services, you are now going to have to go and update your models on all your other databases. Same if you update your database schema. Every application that uses that database is going to have something done to them. So you can't just update a DB and deploy its single microservice with it. You're now having to go and touch a whole load of other things. And that is our definition of the distributed big ball of mud. And you've just made everything really hard for yourself. Okay, so we don't want to do that. Instead, we want to have a DB per service. So this is vital. This is a non-negotiable. Okay, this must happen. You have to do this. Okay. Sorry if that's not what you want to hear, but you must do this. I'm not very definitive about a lot of things. I'm usually very sort of, well, it depends, you know, on this factor and that. No, this does not depend. This is something you must do. So, okay, my strongly worded Layla is gone. And so why is this such a good thing? Well, there's already the reasons I told you, but now you are free to choose the type of database that suits your service. And this will also have a cost impact too, hopefully for the better. So let's say our food service. Well, that's just storing a whole load of menu items. That could be cheap and cheerful table storage. The payment service, that's probably going to be high volume. So it's also probably not going to be relational. So we can use something like DocumentDB. And then our order services and user data, we probably want that in something relational. We'll probably want great redundancy and all of these things. So you can now tailor your databases to your service. Now, you may be wondering, well, how do they all sync up? Well, that's something called eventual consistency. And I mean, in theory, this takes, you know, in practice, rather, this takes a few seconds to actually get everything consistently lined up. But eventually, all of your data is going to match, okay? So how do we decompose the data in the code? Well, there's two ways. Data first. So you split off your module of data from your main data, and then you sort of combine that to a module of functionality inside your monolith. Okay, and so this has the benefits that data is generally harder to separate than code. So if you really struggle, you can do something different. Okay, and then the other option is code first. So you'll get quick results because you've whipped out that that code into a service. But this is where you might be tempted to leave it talking to your main database. So this is danger zone. You can't leave it here. You must pluck that data out, okay? And it may be really difficult and you may have to change things, okay? So you'll have to look at whether you should go the route of code or data first. All right, so on to security. And I can hear you all groaning. Don't worry, I'm not going to go deep into security. We have two types that we need to think about. And the first is machine to machine. And this means that only approved, authorized, or authenticated apps can talk to your backend services, okay? Because let's just say you don't authorize machine to machine, any service will be able to connect to your non-authenticated app. So for example, if someone comes to look at your website anonymously to see what food you have, you want to be able to show them. You don't want to have a user come and, oh, well, to view the menu, I need to sign up and create an account. No, I'll go look at the other taco shop. Thank you. You need this authorization for anonymous chit chat between machines, okay? And that means that no one else, no other applications can come and talk to your backend services. And then, of course, you have your user, your usual authorizing and authentication via sign-in. And there are the usual options that you have here. You have cookie, you have token and claims, you have like an identity access management, whatever you choose to do, whatever you need for your system, you can do, okay? But the one golden rule is don't roll your own, okay? Do not roll your own, just use a approved, unapproved way of doing so in an approved library, okay? All right, so that's your security, and something that can really help with the ease of implementing security is an API gateway. Now, I mentioned this earlier, and it's one of those things that, see, isn't restricted to distributed systems, but is a major part of it. So what is it? As a reminder, this is, it sits between all of your front-end applications and your backend services, okay? Sometimes called a reverse proxy. And what it is a single entry point. And this is really key. It's one entry point to secure, like having a single front door. You don't have to go around checking 5 different front doors to make sure they're all locked when you go to bed at night. So without a gateway, all of your clients are going to have to authenticate and authorize with each different service. So you're going to have to implement that again and again and again and again. And that's going to be really painful. With a gateway, you can have that single entry point and you can do all of your identity and your authorizing and authenticating there. You can store all your stuff and then everything connects through there. This is now more of a single point of failure, so you need to put in resiliency tactics there, but you've just made your securing everything infinitely easier, okay? Now, if you want to see a demo of that, I have a nice video on my YouTube channel of doing it with YARP, which is my favorite reverse proxy. I find it very easy to use. It's a great little .NET library. It was built by folks at Microsoft, so definitely go and have a play with YARP for yet another reverse proxy. So yeah, I have a video on that that you can go and check out. Okay. So the next thing, service discovery. And this is sometimes called a service registry. And this is really key. If you've got a food truck and it's going to park in a random car park somewhere, you need to tell people where it is, don't you? Or else no one's going to be able to find it. And the same goes for our services. What good are they if the other services can't find them? So how do you go about doing this? Okay, well, this is where we do some service discovery, particularly useful if you've got lots of instances, because you can combine service discovery with load balancing. You can also combine service discovery and load balancing with your API gateway. I have various blog posts on how to do that as well. So basically, your client will call into, let's say, your API gateway, which is running your service discovery client, and it will say, I'd like to go and look at this service, please. And you've got 4 instances of it, and those have self-registered with your service discovery. That's key. You don't have to do anything. They register themselves. So your service discovery client is going to go, oh, okay, here is the IP address of that, and it will route them on through. So it's really useful when you've got lots of services and lots of instances, especially if they're scaling dynamically, because they self-register. They'll be findable, and that is what's so beautiful about a discovery client. Okay, I have some demos of this as well that we can look at towards the end. So we've got some common service discovery options. There are so many out there. There's Netflix Eureka, there's Zookeeper, and then we have HashiCorp Console. Okay, so there's some good ones that we have available. All right, so let's think about actually writing code. Okay. This is the big thing. You need to have done all the research. You need to have thought about everything as you go along, and then get to your code and have your plan of action going forward. Okay. So things to bear in mind. You want to plan the scope of each project. By project, I mean this chunk of work that you're going to do when you start breaking down something into your scoped project, and plan the right solution for each project. Now, you may be really tempted just to do everything in .NET. I would, but there may be other services, other languages or frameworks that may be better suited. So keep an open mind, okay? And then layer in the complexity. So when you're building something, get it working without security, then layer in your security, get big modules, and then gradually decompose them into smaller modules, and just be flexible, okay? There is definitely a balance between over-engineering and safeguarding against technical debt here. You want to like fail fast, okay, and iterate often on this. This is going to be really helpful when you're doing it. All right, so let's have a look at some demos, okay? Hopefully you're all still with me and still awake. So let's go and have a look. So the first one I'm going to show you is some messaging. Now I like using RabbitMQ as my message broker. And that's not just because I work for VMware and we own it, but it's because it was the very first message broker I used at my very first job. And I've always liked it. So I have RabbitMQ running in Docker. So you can see that here. You don't need to read this, but if I scroll through, where is it? Oh, yeah. So you can see I've just got it running, and I'm running the management one. If I make that bigger, you can do that. So what the management one means is that I have this thing here. So it gives me an overview. You can see everything that's happening. You can see any connections and channels, exchanges, queues, and all of that. All right, so we're going to be looking at writing a topic exchange. That's the pub sub, okay? And that's what we were writing. So let's go and have a look at code. I think it's useful to see it in situ. Okay, so in this bit of code, I have 2 applications. Let's go and have a look. And this one, you can imagine, is like our kitchen service and our order service. So as an order comes in, we want to update the kitchen that we've got an order. Okay, that is going to just publish to an end route via SignalR, but the application needs to get the information about the new order from the pub sub. Okay, so in this case, I've got all my RabbitMQ implementations in this separate project. Now, that is fine for something like this, but you want to strongly think about how you separate out code like this, because now, guess what? I have coupled my kitchen service to my order service because they now both have a dependency on this RabbitMQ project. Now, if you made that into your own private NuGet package or something like that, you could maybe get around it, but you probably wouldn't want to separate this out into a project. You would duplicate it. Drier, don't repeat yourself, isn't always better, okay? So you need to get away from that. So here you can see this is going to cause us problems. So I thought it was important to show you that. Let's start with our order service then. And I've set up the RabbitMQ. We have a host name, we have an exchange name and an exchange type. And if I go and have a look, let's go check out the order service program file where I register this. Actually, I don't. I do it in that naughty separated file. So if we go over here and I show you what I'm registering, I go and get some settings from my user secrets. That's where they happen to be locally. And then I create that, bind it, and then I add that. Now, I have a whole blog post on how to do this. And this is so that the channels and everything are correctly disposed of. Okay, so I'm not going to go into that, but we create a channel and we create a topic exchange because that's our exchange type down here. And we give it a name. So now that is registered on the program file of both of our applications. So if I go down here, you can see there is our setup RabbitMQ. Okay, so you can see this could easily become a NuGet package that you install, and then you've got that as a little bit of middleware. So on our producer side, so this is the thing producing the messages, we have this Rabbit sender. So we've got our channel available to it, and we go and get that. And basically, we have a publish message generic method. And what this does is it goes through and serializes that whole model. And this is where your bounded context comes in. You'd need to know what to deserialize to that at the other end. So you have that shared interface between your applications. And then we go and publish it to our pub sub. Okay. So that's pretty simple, but on the Rabbit receiver, so this is the consumer, we need to be listening. And that means that we need to have it running as a background service. So if we go and look in our program of our kitchen service, don't worry about that, that's signal R. You can see I've added our receiver code as a hosted service. Let me just come in here. So you can see that is going to begin on startup and just be constantly listening. So if we go and check out this code, we've got the channel passed in, and then we start it and we stop it and we dispose of everything as we do. So our do stuff method, which is down here, it's just going to be listening for any messages coming in. And Topic Exchange has something called a routing key available to it. So this is how you flag a message with some information so that other services can say, oh, I'm listening out for an order.cookwaffle message and get it. Okay. And then you just deserialize it and then you have your message. So if I start to run this, I'm going to run both of them. Let that get going. Let me go back to my code and we'll just run the other one. And I go in here and I'm just going to try it out. Note that there's nothing on here. Okay, it's magic. Execute. Ta-da! Yeah, okay. You're like, yeah, okay, that could have been an API call. But let's go into our Rabbit. You'll notice we now have a waffle messaging topic exchange. You can see type is topic. We can come in here and we can see my two messages that I just sent to it. Okay, so I've just proven that I sent it via the messaging. Okay, so I do have a blog post covering that. All right, so I quickly want to show you service discovery as well. I can see we've got a little bit of time and I'm good with that. So we'll stop all. And the library I'm using for service discovery is something called SteelToe. It's another VMware product, but you can use another one. I just happen to really like how this one is implemented because it's really easy. I bring in the discovery client. Let's go and have a look in the dad joke. You're going to get some dad jokes. And bringing in the NuGet package, and then you just add discovery client and it will connect. Again, my discovery client I'm using is Eureka and it's running in Docker. So all you need to do is add it like that. And now this application is going to self-register. Okay, that's it. That's it. We have some things in our app settings that we can set. Was that the wrong app settings? It was. So you can see down here that I'm going to say it should register or it should fetch. So you may want something to only register it because it's never going to go and look up stuff on the registry. And you might only want stuff that goes and looks at stuff on the registry. So you can set that up. I have that on both applications. And I also have a web interface for Eureka. And you can see I have nothing registered with it. So I have my apps ready to go here. And I'm going to run 2 instances of Dad Joke API. So the first one is going to be on localhost 5005. So you can see that. So let's get that running. All right. And the other one is going to be on localhost 5006. Let's get that running. Okay. So they're up and running. And if I go back and look here and I refresh, you can see now they have registered. They default to the name of the application. So you can request Dad Joke API. You don't need to know anything about their APIs or their IP addresses. And then the other application, this one, if we go and have a quick look, has a long running service. It's a hosted service, and this is just going to go through. We can use the discovery client. We can inject that. It's available to us, and that's how we can go and connect to it. And I just need to cast it as a discovery client because it's you can only get the iDiscovery client. And then I've got a whole load of APIs available in my discovery client. So I can go and get the registered applications and then we can do some stuff with it. So let's go and run this and see what information we can get. So if I run that, here come the jokes. You can see it's picked up both instances. We've got the first one and the second one. And you can see here it's going to 5006, 5005. You can start to see stuff happening over here. You're getting a whole host of terrible dad jokes. But you can see it's just round robining. Actually, it's not. It's doing a different type of load balancing, but it's just going and fetching from those two APIs, okay? And none of these services are aware where the other one lives, okay? So that's really how simple you can get it running, okay, just with that NuGet package. Okay, so those are the quick demos I wanted to show you. And now let's just go back into our slides and we'll just finish off. So, okay, there are some other stuff that you need to think about because this topic is vast. We don't have time for it all. So things that we haven't covered is deployment. I'm not great at deployment stuff. Kubernetes might be your friend, other stuff like that. You need to talk to someone who's better at that kind of stuff and listen to their talks. Monitoring, this is so key. Telemetry is so vitally important and is a whole topic, a whole workshop on its own. You need to monitor everything. As you do each incremental thing, you're going to need to be looking at how you implement those and how your apps behave. So that's going to be really good. And scaling and load balancing, we've touched on, but you'll want to have greater control over that. Okay. And there's a whole lot of other stuff that you need to think about, but these are the main things that you need to do. I think, oh yes, so resources, we've got Steel Toe I mentioned, there's Dapper. I don't actually get on with Dapper, 1P no E, but a lot of people do. Project Tie, I'm not sure if that's still running, but it's worth having a look at. And then YARP. Okay, those are some of the things that I like to use. Or not. You can check out my YouTube channel. I'm at Layla Codes on YouTube. You can see access denied. Yarp says no. There's the video. Yeah, thank you. I'm trying to leave a bit of time for some questions because there may be some, and also I get to chat to people as well. I get to chat to Matt and Rachel. So this is me. You can get the slides on bit.ly, understanding-microservices-23, and everything else will be linkable off there. And you can go to layla.dev for everything else. So there we go. Thank you very much. I'm imagining lots of rounds of applause, not boos, lots of applause.
Yes, lots of round of applause. Thank you very much. That was a pretty fantastic talk. So yes, we will give you plenty of rounds of applause. And,
yay!
As much booze as you want, really. If we're talking dad jokes.
Yes.
Sorry. No, fantastic session there, and we've got a whole bunch of questions as well. There's a whole lot of great advice going on in there as well. It's a really useful way to get yourself from a big ball of mud into something a little bit nicer.
I like the big ball of mud analogy. Is really what it looks. It's what it looks like. It really does.
It's always good to have a spinny big ball of mud on a slide as well.
Oh yes, I was very proud of my big spinning ball of mud.
And the chat also liked gobbledygook as well. So the people were pleased about gobbledygook and your various analogies for architecture and layers went down a treat as well. Who does eat like that? That's the only question.
Don't know. Well, I gave a talk somewhere. It was at a company, and that's where it came up. Someone said, "Oh, I eat my Kit Kats like that," and I went, "You monster!" live on stage, and they were like, "Oh, I'm really sorry."
No, I think it's always good to insult the company you're just giving a talk at. It's the best way to do it, and you're right. So there is that.
There is a proper way. I mean, just for some things.
Yeah.
And everybody just knows the proper way as well. They don't have to be taught it; they just know it. It's the thing. Anyway, we should probably ask you some proper questions about your talk. We did have a question about eventual consistency. Is one of those saying, what methods can we use to guarantee consistency when dealing with multiple services that could be down or not available?
So this is where you need to put in a lot of contingencies around your message brokers. So you need to make sure that you're managing them better, that you've got replay on there, that you're storing them, that you put in proper acknowledgements. So that goes deep into configuring your message brokers. Okay, so that goes also into the event-driven design side of it, so the replayability of certain messages. I managed to go through the whole talk without coughing. That was great. So all of that sort of eventual consistency stuff comes down to just proper contingencies, I guess. If a service goes down, that it knows where it last got a message from, and so it can pick up where it left off. So it's a lot of configuration and testing that. This is the thing though, when you start breaking things into these distributed systems, you are layering in all of this complexity. That's why it's so important. Like at the beginning, I ask you, are you sure? Because you are opening up the biggest can of worms. This is not going to be easy. You are going to get some consistency issues that you're going to have to address. So this is where proper logging and telemetry and configuration of your various systems is absolutely vital.
The other part of that as well was about bad data. So if you're doing things sort of asynchronously, what about bad data?
Yeah.
In what sense? There's lots of bad data type stuff out there.
Yeah, so I guess just the question really was about sort of eventual consistency. You know, how do you deal with it if the services aren't available, or if you send it something which it can't handle,
again,
for whatever reason?
I guess it's going to be having resiliency policies in there. So if something comes in, you log it and make sure that it doesn't make your whole system go splat, that you put in contingencies everywhere. This is all pivotal on having proper resiliency policies in there. So if bad data comes in, you log it so you can go and investigate it. Where did that come from? Why did it happen? Why was it not picked up? And then you have your system carry on as if it never happened, so that nothing goes down. And so this is where incremental changes really help, because you write a lot of tests around it. So there shouldn't be bad data going to your systems. It should all be accounted for. All of this resiliency should be around protecting everything to prevent that. And you can put in resiliency patterns, not just on API calls, but on data calls. You can be putting circuit breakers and retries on everything. Anything where you think something might fail, you should be putting it in.
So considering all of this that you just said, all these things you need to consider and more. Good segue to the next question is, well, once you've determined this is the right thing, convince your boss. What do you do about that? The people problems are actually the hardest technical problems, aren't they?
They are. So I think you need to be 100% sure on all of your data points as to why you need this, why you need to, because you're going to need new team members. You're going to need a lot of new people systems in place. So I guess it's going to be financial. Your boss is motivated by financial costs. So being able to scale more horizontally and scale to zero is going to be more cost effective. That we're going to be able to update things more quickly and earn more money from our customers because we have a faster iteration cycle on our code. So you can keep going with those things. So I think pinpoint the financial benefits, both cost savings and being able to make people pay more money to you for your services. So that's how you need to pitch it to your boss.
Yeah, your slide with the "Are you sure?" Because I've seen this talk of yours before, and both times I'm like, add that extra slide, going like, no, really, are you sure? Because I don't think you are, unless you've asked this at least 5 or 6 times.
Yeah.
Because I can't tell you how many people I know just completely train wrecked on microservices because it's the thing you have to do, except it's not just a thing you have to do. It's all of this stuff and stuff you can't even cram in, an hour's talk here. It is that complex.
It is unbelievably complex. And now I keep hearing stories about people reintegrating their microservices into modular monoliths. My personal opinion is stick with a modular monolith and then have your satellites for your scalability. It'll be so much less painful. And then when that's really bottlenecking, when that's really on its knees, then just break off more satellites. Because the microservices, unless you have the complete people infrastructure, the knowledge, it's just complexity that nobody needs.
Right.
So that's a good question of breaking off your satellites. How do you identify what would be a good satellite?
So try to hold that
sorry,
in while I mute.
I'll just fill for a second while you just
oh my goodness,
have a moment. So,
lungs okay? Stay in.
You're doing fantastic job so far.
So
bricks. We'll go with the food thing here. Something.
You what?
Always your food references.
I've lost the plot now. What was my question?
I was asking about satellites and how you would identify a good satellite.
So this is where you need your telemetry in there. If you're seeing that it's so many factors in here. You need that observing, you need to be observing and monitoring and looking at all of that stuff that's going on with the system. And you're like, actually, this is really high traffic. This is really maxing out. This is hogging all of the CPU on this instance. This needs to be broken out. We need to create, start scaling this particular section. Without all the telemetry in there, you're in the dark. You will be guessing about where your bottlenecks are. So that's a really key, vital part of it, in my opinion, is it has to be well observed.
I'm going to say this would tie back into the talking to the boss question as well, because now you're going to actually have some data to give them, like, here is a hot spot where we need to do something about this. Maybe here is where a microservice might help.
Yeah,
which is just, again, the satellite, not like every single piece of software you own, which
just the satellite.
Just the one little the micro in there.
Definitely. Data bosses love hard facts, not just like, well, I think this would be the no think. What's it going to cost me? That's all your boss wants to know. That's the bottom line. And having that data and being like, okay, this is what's slowing us down. This will stop us getting more orders through the system or whatever. We need to break this off into a satellite. So I need like 3 weeks of labor to do this, blah, 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 whatever you need. That's how you pitch it, with hard facts. Any more?
Oh yes, we've got more. I'll dive in. So I guess it's kind of related to the satellites, and it's about the splitting up of your database and stuff. And it's probably related to the big ball of mud. And it's a kind of couple of questions really. It's like, does splitting up the database not increase a lot of the sort of response times you've got? So instead of being able to retrieve all the data that you want in one go, don't you kind of have to go off and talk to different services and get things and combine them and stuff?
Well, this is where you have to architect your schema correctly. And this is where you are going to get duplication. Okay. We're not, what's the word for where you try and get everything down? Oh my goodness, it slipped my head. In databases, you want to have normalization. That's the word. Thank you, Rachel. It just completely flew out my head. Okay. You really need to denormalize your data. Okay, that's the key. We are not going to multiple services. That now you are coupling your services too much. Okay, you need to denormalize your data. That is how you are going to speed it up. If that service needs all of that data, stick all of that data in your service. It's not the data controller for that. it's going to get that data updated via eventual consistency, but it's got it. It's got that duplicated over there. You may have other systems running in the background that are duplicating your data and syncing things up. And that's why it gets so complex, because you need to think, well, this service needs all of this. So I need to make sure that I've got fat messages. So I don't like this terminology, but you've got thin and fat messages. So you've got thin ones, which are events, like this is happening, hey, something happened. And then you will get a service to say, oh, okay, well, hey, I'd really like all of the detail around that event. And now you've got a fat message. So this is starting to come through in that way. And so let's just say you've got an order and your producer sends out, hey, there's an order and its ID is 123. So the service that says, okay, well, I know there's an order, can just grab it. And they don't need all of this data. They just need like an order and how much it is and a credit, and a credit card. Okay, their payment service is going to do that. But the food one needs to know all of the nitty gritty, what's on the order. So it's like, okay, there's an order. So it's now going to make a request for all of that order data. Okay, it's just going to send out a message saying, hey, I need this, all this data. And so then you can start to get a fat message coming through, and that's going to be all of the bulk of it, all of like how many tacos, what type of tacos, and it's going to update its system to do that. But the payment doesn't need all of that information. So it's how you start architecting your messaging as well, and what messages are sent where and to whom, and to who's actually subscribing to those particular messages. So that's how you start getting everything going with everyone. And then this is just the complexity, but I love systems, so I find it really exciting to see all these systems starting to come together.
Does security cause troubles with that though? Because I like the idea of having sort of separate services for things like orders and inventory and notifications and things like that, but then something like authorization is a cross-cutting concern and applies to so many of those things. So how does that fit in this nice sort of siloed serviced world?
So security is like a pain everywhere. So you need to be authorizing certain things. Okay, so you're going to have something going around. It's, you have to look at it on a case-by-case basis, Matt. It's not easy. Security is like the bane of every developer's existence, let's face it. Okay, so yes, you're going to have some security issues around there, but we are in the back end here, so you can have this completely isolated from the outside world. Okay, so making sure that you've got your queues and things properly secured, and all of your backend has no back doors, that's going to help with that. But keeping these messages as minimal, like oh my god, all the terminology, all the gobbledygook is flying out of my head. At least privilege is something that you really need to embrace with this, just to keep going. Okay, you had to ask the security question, didn't you? Where I was just going to go, yeah, security sucks. It's hard.
No, I think we're all okay to say security sucks. It's there's a special breed of developer who likes security, and everybody else should just use the official things.
Yeah.
Yeah. The reason why they specialize in it is that, yeah. So, well, I mean, why not keep this going about security then, sort of? No, well, sort of. I mean, so another question was about API gateways, right? So one, wouldn't that be responsible for authorization, or is that pre-service? But in context of a larger question saying, isn't an API gateway a massive single point of failure? So negating the minimized blast radius of microservices, and then into, isn't that responsible for authentication or authorization also?
Yes, yes, and yes. It's
unanimous.
Yes.
We've answered that one. Tick.
It is a single point of failure. It's adding in complexity. It might add in latency. You can put your authorization and authentication on there, they do scale. So you could negate that single point of failure as well. But you have to have some pinch points and some controls on here. That's why we don't have big wide open fronts on our houses, but we've got lots of rooms in them still. You know, it's you have to have compromise somewhere. And I think having centralized authorization and authentication is where I would want to do it, because it's to have that. It's just a big no to have that per service, because that is just going to create the worst headache, the worst kind of hell I can imagine, to be honest, to put it succinctly. So if I have this bottleneck and a single point of failure, at least my application is secure. And that's where I would like to go personally.
I like the analogy there of your house and the pinch points, and
Yeah.
it's a nice secure front door, but lots of rooms inside. Yes, that one. I like that one.
So yeah, that's kind of it. And I like all the analogies. You see, I'll pluck them out of my head. Like, I'm full of them. I think they help. So I'm glad that they're landing well with everybody. So it's been fun to answer all the questions. I love getting all these questions. I don't normally get so many questions, so this is really good.
This has been very well received. So yes, lots of questions.
Yeah.
Any more, Rachel? Are we done?
Yeah. Well, I think you kind of answered this one little bits with all the rest of the questions and other things you said, but I just like the way it was phrased. Is what if your monolith is a really nasty monolith? Just the fact, I have this nasty monolith. Like, for example, where orders are linked to inventory and dispatch and notifications, but it's nasty.
It's nasty.
I like
that. Well, right at the beginning, I said, I don't know what your application looks like under the hood. I mean, I
feel like a lot of them, before JetBrains, I did a lot of consulting for decades, and nasty is really how I would describe the bulk of the software out there at most major corporations.
We've all seen it. We've all seen some nasty software.
Yeah.
Mm-hmm.
So yeah, it's if it's really that nasty, I think you need to start definitely with modularization and tidying it up. There's no way you can skip that step. You need to start teasing out the knots and smoothing everything out into nice highly cohesive bundles, and gradually, step by step, incrementally. You're going to have a much longer process to get there, but you'll discover that by moving more to modularity, that you've already improved the maintenance on this application, the feature implementation times. Everything is going to be getting easier as you are modularizing this code. And then, if you've got a nice discrete module, you can bang that off into a satellite. And this is why it's so important to take these little tiny steps and not to rush yourself, and just to go through in little bits.
This reminds me, I have a talk similar about microservices and architecture. And one of the slides I have, it has a giant poop emoji on it, and it says monolith. But then the next slide is like 10 little tiny poop emojis. And it's like, now it's microservices. Keep that in mind. That's often what happens.
Oh yeah.
You don't want that to happen. You kind of want to get rid of the poop, right? That's the point, not just to scatter it about.
That's it.
Nobody wants to scatter poop about.
No. Unless you're hippos. Unless you're hippos.
Yeah.
Okay.
On which note, I think we should wrap up. Layla, thank you very much for your session, and thank you for battling through with your cough there. You managed to survive until the end, so I'm pleased to hear that.
My lungs are still in my chest. This is good.
That is the minimum we require from the speakers at the end of the session. As long as you're still, this is good. But thank you very much. And I think it might be time to
another session
move
where
on.
no one died.
Yeah.
Yay! Have a great day, folks. Thank you so much for all the questions, and thanks for having me. Bye.
Bye now. Thank you.
Okay.
Okay, I think we're probably time to bring on our next speaker, who is Mike. Hello, Mike. How's it going for you today?
Hello. It's going well. I also have a cough, but the chest X-rays came back all okay. So hopefully it won't be too bad.
Yes, very pleased to hear that as well. And we'll just you know, get through the next session, and I'm sure we'll be fine.
Yeah,
I mean,
we've got our fingers crossed for you.
The excitement of talking about Avalonia is just going to push me through it. So we'll get there.
Great. If just running that on pure adrenaline alone is going to be fantastic. Right then, I think we'll get straight to it. You're going to be talking to us today about Avalonia and cross-platform UIs, I believe, yes?
Yeah, that's right.
Fantastic. Well, let's get the screen up, and we'll drop off and leave you to it. Good luck.
Wonderful. Thank you. So yeah, in this session, I'm going to be talking about Avalonia and why I think it's the best cross-platform UI technology available, and why I think you should give it a try. It's going to be a kind of whirlwind tour. There's quite a few little demos that I'll be showing you. But let's start right at the beginning. So my general feeling is that Avalonia is an overnight success based on a decade of hard work. So not many people know about Avalonia. I think it's the best kept secret within the .NET community, but it's been around for a decade. It's been developed by people from all over the globe. In fact, our 10-year anniversary, I think, is December 5th this year. So the plan is to get some of the team together in Italy, and we'll have some pasta and some nice sparkling wine to celebrate all of the hard work that's gone into building Avalonia. But it's an open source project that, as I say, it's been developed by the community over the last decade. But what actually is it? Well, it's a cross-platform UI framework that enables you to build applications for Windows, macOS, Linux, iOS, Android, and WebAssembly. Now, we have some new platforms kind of in preview. So we have Tizen support coming. I think there's a pull request for WebOS support as well. And we've been experimenting with Vision OS support. So the new the new goggles from Apple. So yeah, we can run across a myriad of different platforms, but we can do this all from a single .NET project. So I say .NET Standard, but it's, we're targeting, you can go all the way back to .NET Standard. You can run on .NET Framework if you want to, but most people are using .NET 6, 7, or even .NET 8 runtimes to build their Avalonia applications. And as I mentioned, it's been developed over the decade by hundreds of contributors from all over the globe. So this isn't created by some large corporate entity and then gifted to the community. This is kind of grassroots movement to develop a competitor to WPF that runs across more than just Windows. It runs across a myriad of different platforms. And this kind of growth has been quite significant. So here we are compared to Maui. I checked the stats this morning, and we just about surpassed them. I think there's like maybe 15 stars difference between us on GitHub. I mean, it's a total vanity metric, so it doesn't really mean anything, but it's still nice to see that we're up there in terms of popularity with the official solution from Microsoft. We're also part of the .NET Foundation. So when we look at the kind of engagement with Avalonia on a month-by-month basis, or even on a slightly longer-term basis, what we tend to see is that we're the most actively engaged community project within the foundation. So this is something we're really proud of. So it depends what metrics you're looking at. Some months we're most commits, some months it's most pull requests, some months, sadly, it's most issues. But people are using us, they're engaged. And that's fantastic to see. Now, I think that these kind of technologies, they live and die by the ecosystem that they exist within. And since I joined Avalonia, this has kind of been my real focus, because when I joined, we didn't have a huge amount of third-party partnerships. And that's something I've been working to try and solve. So we've partnered with a myriad of different companies to expand the ecosystem. These are just a couple of the logos. So there's JetBrains on there. Obviously, our favorite IDE is JetBrains Rider. JetBrains are using Avalonia, which I'll talk about a little later. But we've partnered with control vendors as well. As I say, to grow the ecosystem so that you're not just stuck with what's available from the open source community, which, while fantastic, if you're building an enterprise application, you might want to have those pro controls. So we've got a long list of other control vendors that we're working with that we're not quite ready to talk about publicly yet. But as I say, the ecosystem is growing massively, which is fantastic to see. And in terms of who is using Avalonia, well, I mentioned JetBrains. Assuming you're using Rider, and you should be, if you've ever done any like performance testing of your application, maybe you've used .memory or .trace, so you're profiling your application, then the graph views and that view within Rider is actually an Avalonia application. So the original app was built using WPF, and JetBrains wanted to take it cross-platform, and they assessed all of the different technologies available to them, and ultimately decided to bet big on adopting Avalonia. So you've probably already used an Avalonia app without knowing. We also have other large, well-known companies using us, like GitHub, Schneider Electric, Unity use it for their source control application. Then there's Canon OutSystems and Moody's Analytics. And what we seem to see is that obviously we're a very enterprise-focused technology in terms of company adoption. They've typically got experience with WPF or some other XAML technology. Perhaps it's Silverlight, or they've tried WinUI or UWP. And they want to leverage those existing skills and often existing code whilst being able to target more platforms. So being such an enterprise technology, we've got many users of Avalonia that are Fortune 500 companies. So it's, I think there's a lot of weight put behind it because it's got this decade of engineering and work gone into it. It's a stable and mature platform to build on. And it's been, as I say, it's been adopted by some absolutely huge companies for mission critical applications. So it's kind of a safe bet for when you're looking to find a cross-platform solution for your application. Now, the ecosystem, there's multiple options for you. We're not the only one. So I think it's worth discussing our architecture and what sets us apart from the competition. So this is a typical slide that I show when I talk about our architecture, and I don't think it's the cleanest, but it does get the job done. The key thing here is really to understand the colored boxes and what's inside of them. So if we start right at the bottom, we've got this eye-rendering platform. And this is how we push pixels to the screen. So we're not using native UI controls. So if you've used Xamarin or Maui, then that's an abstraction API on top of the native UI controls. We're drawing everything to screen ourselves, so we need some form of renderer. Now, on Windows, you can use Direct2D, but that obviously isn't cross-platform, so it kind of defeats the whole point of using Avalonia. So if you want that cross-platform functionality, then you'll want to use Skier instead. So this is the same approach that Chrome is using. So if you've used Chrome web browser, then that's a Skier-based application, but also any application built with Flutter. So we're in really good company with this approach, and it gives us a huge amount of flexibility in terms of creating applications that look fantastic across all of these varied platforms, but also has an incredible performance. So in order to support a new platform, I mentioned we've got Tizen coming, we're playing around with Vision OS. We don't really need a huge amount to make it work. So we have that Skier, which is responsible for drawing the pixels and the rendering perspective. We need a window in order to push pixels into. So we use Win32 on Windows. We use our own binding approach on Mac OS. So there's no dependency on what used to be Mono Mac and then Xamarin Mac. We have our own approach because, say, we just need the window and very minimal APIs that are platform specific. And then on Linux, we use X11. But Linux is an interesting one because because of this architecture, we can run on some very low-powered devices, and we can use the frame buffer to output our pixels. So we can push pixels to the screen via just the Linux kernel. We don't need to install a full desktop environment to run our application. So our competitors, I mean, they used to have Linux support. I think there's a community version being worked on, but they're dependent on GDK. So they need, quite a heavy dependency in order to support Linux. We don't have that, so we don't need it. We can just push the pixels using Skia and push the pixels to the screen using the frame buffer or KMS or the DRM. In fact, I've got here next to me, this is a Raspberry Pi, and it's running a HMI application. It's not a full screen. It is just like it's using the frame buffer. So there's no concept really of a window here. We're just pushing all of the pixels to the screen directly. And in fact, this is using the Meadow SDK. So if you know of Wilderness Labs and their embedded electronics platform that they're building for .NET developers, they have an SDK that makes integrating with stuff like Raspberry Pis incredibly easy. And you can attach sensors to the pins here on the device, and then you get the sensor data updating your UI screen on the screen. So we're seeing an awful lot of adoption of Avalonia by companies that have typically built with Qt or Qt. I'm never quite sure how to say that. I think Wiki says that it's Qt, but it always feels odd to describe it as such. Qt, we'll call it Qt. But it's C++, and it's very much targeting embedded. And they've built these applications, and they're finding the development experience just isn't great. So they're migrating over to Avalonia, and they really appreciate the fact that, number one, we support Linux, and it's a first-class support for Linux. We've got a very broad range of distros that we support, but also that we have that embedded play and that we can run on very, very minimal hardware. I think the lowest powered device I've seen us run on is like a CPU from 2002, a 32-bit ARM processor with like 500 megahertz. So really, really low powered in the scheme of trying to run a managed language like .NET. Obviously, we have full AOT compatibility. So yeah, this is I've kind of digressed a lot here. I wanted to skip past this slide pretty quickly to show you the architecture in a way that you might be more familiar with. So on the left-hand side, we have the MAUI architecture, which is that abstraction API. And then on the right-hand side, we have the Avalonia architecture. And the really, really key thing here to understand is the rendering is different. As I keep saying, we use Skia. So there's no abstraction on the native API, on the native UI controls, which means that it's very easy for us to add these new platforms. The other difference, but it's not really one that you'll notice too much, is that our runtime is slightly different. On Mac OS, you'll be using the standard .NET runtime. I've got .NET Core here, but the naming with .NET is terribly difficult to keep up with. But it's .NET 6, .NET 7, .NET 8. And then we only use the mono runtime for iOS and Android. So yeah, the key thing here is that rendering layer is unified across all of the platforms. So if a new platform becomes extremely popular, it's very easy for us to add support. And as I said right at the beginning, we've got Tizen coming, and that's a community effort. There's a guy in the community that's been working on that. So it's not the most I mean, it's a lot of work, but it's not a huge amount of work to add new platforms for us. I think the smallest amount of code required to add a platform, if you check out the VNC example, I think it's like 200 lines of code. Because once we can push pixels to a screen and we can get user interaction events, maybe it's a mouse click or a screen tap, then the application can run on that new platform and we're basically good to go. Now, what this also means with this approach is that we're not really tied to using like Mono, for example. There's the experimentation around Bionic compilation. And we played around with this earlier in the year to see what kind of performance could we get if we ditched using the standard mono runtime. I'm just going to load this video. There's no audio. It's just a video, but you can see here that this approach to compilation and how fast the apps load here on Android. So it's incredibly quick to launch the application. You can see decent performance there. And then we switch to the more traditional. This is just a Xamarin application, or using the Xamarin runtime with AOT. So you can see it's a little bit slower. It's still okay, but it's not as fast as that Bionic approach. And then I think lastly, this is just a normal Xamarin without AOT, and it's significantly slower to load the application. So this is just a proof of concept that we created to explore the idea of using Bionic with Avalonia to see what we could get in terms of performance. It definitely needs fleshing out. But what I like about this is it shows that we're quite happy to not always require what's coming from Microsoft. If we think we can do something slightly different, then we'll embrace that approach. So let's get rid of the browser. We don't need to be there. Perfect. So in terms of how your application looks, you have full control. So, oh, excuse me. This is an application called Fluent Search. So this was created by, he works at Microsoft, but this is developed in his spare time. And this is an Avalonia application, but I think we can all agree that this looks totally fine on modern Windows 11 PC. You wouldn't assume that this isn't using the native UI toolkit. You would think, this is probably a WinUI application. It's not. It's just a really well-themed Avalonia application. And we can see this in multiple different applications. So this is Speckle, and this is using a community-provided material design theme. So this would look, right at home on Chrome OS, or if they wanted to create an Android version of this application. I think for this one, it wouldn't make much sense, but if they wanted to, it'd look right at home there. And we've seen lots of users of Avalonia adopting material design as their theme. And then this is a Cupertino theme that I put together in about 2 afternoons work. So, it was pretty quick to get this built. And it looks like, I think it looks passing resemblance to how Mac OS looks. So it's very, very easy to style your application to whatever you want. And I'll show you some examples of how we do that in the demos. And then in terms of the developer experience, so I think if you're building with Avalonia, you should just use Rider. So we do have extensions for the other IDEs. Those that shall not be named, but those are built by us. And to be perfectly frank with you, we are not experts at building tools for IDEs. And for example, the XAML completion, I won't use the word IntelliSense, I think that's trademarked, but XAML completion, that's like a PhD just on its own, or code completion. And we don't have that experience. So whilst it works, the best developer experience is coming from Rider. And the key part, or the key reason for that, is because JetBrains is using Avalonia. They have invested in creating top-notch tooling. So Rider really understands Avalonia XAML and the entire project. So you get a lot of nice features just built into the IDE. And then if you want to take it one step further, you can download the Avalonia Rider plugin from the marketplace, and that will give you the XAML previewer window as well. And that's actually maintained by a JetBrains employee, I believe. So yeah, the built-in IDE is fantastic on its own, just vanilla Avalonia code completion. But if you want that additional ability to have XAML previewer built in, then grab the extension. So that's enough waffling. Let's jump into the IDE, and we'll create a new project, and I'll walk you through it. So we're going to do file new solution. Now I've installed the templates. There's a couple of different templates. We have MVVM, which is a bit like MVC, but with more V's and N's. Then we have just a vanilla .NET app, and this is more that code behind. So if you've ever done like Win Forms, where you double click on a button and then you put the code for that click event in the code behind, this is the template for you. And then we have a cross-platform template, which includes stuff like the browser project and iOS and Android projects. But the desktop, if you're just building for desktop, then you can just go Avalonia.NET MVVM app as your template. I'm going to leave the name. It's not important. And there we go. So give it a second. There we go. It's restored the NuGet packages. The project structure is pretty familiar. If you've ever done any WPF development, then you are already an Avalonia expert. You'll see that we have XAML. I did see someone was doing some experiments with Razor syntax, which was very interesting to me. But most developers are using XAML, but you don't have to. You can, this window here, if I command click it, we're going to get to I mean, this is what I absolutely love about Rider, just being able to command click my way into the internals of libraries. We can see this window. It's Avalonia control. We can create an instance of this through code. So everything you see me do today with XAML is entirely possible to do through code as well. So if you like to develop purely in C#, or maybe it's F#, or maybe VB.NET, maybe there's a few of you out there that like to indulge in VB, then you can also use Avalonia without having to learn or embrace XAML. Now, I happen to love XAML, so that's what I'll be demoing with today. So yes, we have our main window here. It's got some code behind, but we're not animals, so we just ignore that and pretend it doesn't exist. And then we have our view model, and I think the template here is using reactive UI. So let's command click on that, and then yes, we can see we're inheriting from reactive object. So that's providing like the iNotify property changed goodness that we all know and love. So the view model has just got this greeting, which is welcome to Avalonia, and we're creating a binding to the text block here, and we have the design data context, which is useful. So if I build this, excuse me. Let me find the B key. I've got a microphone in my face. I'll build that, and then I'm going to press this button, and it's showing me the live previewer. So I have to do that build at least once in order to get the previewer to start updating. But now I can start typing some code, some XAML, and it's going to update live for us. We'll do 50. We'll do background, and you can see I'm getting this full XAML completion. So we get a kind of .do situation here. I don't actually really need to know the API. I can just kind of browse my way through what the IDE is suggesting to me, which is super nice. And then obviously I can just hit run. And once that's running, hopefully I'll have enough time to drop into the CS prod so you can see what's going on here. Oh, it's very quick. But there we have our cross-platform application, and I can take that and I can go and run it on, the little Raspberry Pi that I've got here, or I can run it on the iPhone, on Android, or even the web browser. So we don't have to worry about installing workloads or any nonsense like that. We just Microsoft.NET SDK, output type win.exe, and in this case I'm using Net 7. I could update that to Net 8. It already works. In fact, I don't think we even needed to do any changes to make that work. It was just built in. So I'll show you something slightly more interesting. So this is a really old application. I think I wrote this about 2 years ago because I decided I wanted to learn how to do RX or reactive programming. It turns out that I can definitely build a project that uses RX if I dedicate a couple of weeks to reading books and blog posts. The problem is I've forgotten how all of that works. So I now have a project that I can't maintain. But I did update it a couple of days ago to the latest version of Avalonia, which is 11.0.4. And it still runs on my machine. But the reason I wanted to show you this application, again, to kind of show you a little bit more of an advanced project. It's, you know, it's not super advanced, but there's some really nice things that we get just by using Rider. So for example, I've got this XAML namespace with the view model here, and it's, you know, using LFO test.view models. If I command click that view models, I get a list of all of the other classes that exist within that namespace, and I can click on it and it's going to take me straight there. So just navigating my project within Rider is just, it's so nice. And you know, I've got this binding here to this main view model because it understands that that's my data context, and then dot rate slider value. If I command click that, I get to go into the view model and see where that property is defined. You can see I'm using, where are we? Here we go. Here's some of that RX goodness that is completely over my head nowadays. I wouldn't dare try and edit any of this code because it would probably immediately break. So another nice feature of Avalonia is that we have the ability to create templated controls. So this is a templated control. Well, let's use some of the nice features. There we go. We'll tidy up the code as we go through. So this is a templated control. The style for it is defined elsewhere. I'm just defining the feature of it, which is, you know, it's got a property of is selected. So it's not, you know, the most advanced control by any stretch of the imagination, but the actual look of the control is defined elsewhere in this playback fader.axaml. Now it's axaml. You could have it extension as XAML. It would also work, but we get the previewer appear here. And we can see that this is the XAML that is defining the look of this control. And we can interact with it in here as well. It's fully interactive. And again, just like before, we can update properties, and it should, I mean, let's change that to red. There we go, instantly update. So that's pretty nice. I'll run this so you can see what it's doing. Because it kind of makes sense for the next demo, so you understand what that application is for. So I got into Avalonia because I had a WPF app where I wanted to control lights. So like when you go to a concert and you see the lights wobbling around like it's a rave. Here we go. I'm going to pop that over there. We'll start. This is just a very simple test application so that I can... It was to play around with effects generation, so I can do stuff like add oscillator. There we go. I'll do sine wave. I'll set some random values, and then it just starts moving around. So it's not the most advanced application, but it was just to play around with RX. Now the nice thing about this, you know, this is very dark, but this is very light, and my retinas are kind of screaming at me. So I'm going to go to the OS, and I'm going to say switch to dark mode, and look at that. Instantly, the application is aware of the operating system style request, and it will update for me. And this is using the built-in Fluent theme that we provide for you. So you get a pretty nice looking application without having to do a huge amount of work. Then obviously as I change back to light mode, the application updates for me live. So that's pretty neat. But sometimes you want, you know, you don't want to just use the themes that we provide. You want to create something from scratch and something a bit more complicated. So this is, well, this is like the big brother of that application. This is designed to run on a big console with faders and buttons, and a huge project now. What's that? 15 projects, 2 unloaded. I've got a slight error in my command line parsing, which uses Antler, but I don't think I referenced that. So let's get this running. And you can see an application where I've gone kind of a bit crazy on trying to style everything to look a little bit different. And this is a real benefit of using a technology like Avalonia, is that I have complete control over how my application looks. So if you care about how your app looks, and you've got specific kind of brand guidelines or styles that you're trying to achieve, if you go with other technology, you can probably get there, but you're going to be reinventing the wheel for every platform that you target. You're going to be having to customize for each platforms like iOS, Android, Windows, and the Mac. Whereas with Avalonia, you do it once, and it runs the same everywhere. So let me show you some of the some of what I've been working on with this little application. I mean, it's pretty basic at this point. It's not hugely complex, but it allows me, like you saw before, I can control lights. So in this case, I can add a lot more lights. You might be able to see behind me on right on the desk over there on the shelf. There's a wobbly light, which is this one, which if I plugged in, I could blind you all through the camera, but I won't do that. But yeah, so we have, as I say, full styling. So these are buttons that I've themed to look like physical, like Cherry MX buttons. So if you're a noisy typer with those mechanical keyboards, this might look a little bit familiar to you. And we've got, smooth animations and all of that goodness. So yeah, that's a kind of very brief overview of the open source Avalonia experience. And now I want to talk a little bit about something slightly newer. I say slightly newer. So this is something we announced in, I think it was November last year. So we talked about the Maui hybrid. So this approach was that you could take Avalonia and embed it inside Maui applications, which is, that's great. There's a lot of demand for that. It allows you to have stuff like the nice data grid control that we have available to you in a Maui application. But as an Avalonia developer, I wanted to go the other way. I wanted to be able to take Maui controls and bring those into my Avalonia app. So we created a sample recently that allows you to do that. So this enables you to mix and match both ways with Maui. So if you've got a Maui app, you can bring in Avalonia controls. And if you've got an Avalonia app, for iOS and Android, you can bring in those mobile specific UI controls, both from the community, so like the community toolkit, but also from the likes of Syncfusion, GrailKit, Grape City, Telerix. It's like 150 plus UI controls that are mobile specific and now available to you on mobile with Avalonia. So I'd like to show you a little demo of that. So where is it? Avalonia Maui hybrid. So it's the Maui sample we showed last year. Ryder doesn't understand the XAML because it's a bit complicated because we've got Avalonia XAML embedded within Maui XAML. It understands much more the Avalonia approach, so putting Maui into Avalonia. But you can see that this is just like before, it's a standard Avalonia application. We've got this XAML namespace, which is Avalonia UI. We have a main window. Within that, we have the main view. And it's within this main view that the magic is really happening. So we have some Maui controls. So we've got the namespace for just your typical Maui controls. We have a progress bar that's coming from Syncfusion. And then we also have a media player that is coming from the community toolkit. And so we can mix and match that. And we just have the one view model. Let's command click it. Not a lot happening there. We do have some code behind as well. In this case, we are animals, it turns out. So we have it that when the media control is playing, we update the progress bar. So let's jump back into the XAML. We have here, this is a nice feature. If I remove this, I think, there we go, look at that. Ryder is intelligent enough to show you what row that's going to be on anyway. So if you don't explicitly set it, Ryder will tell you, oh, that's going to be on row 0, which is just another lovely little feature of Ryder. So anyway, we have this, which is for command click it. We can see the grid is coming from Avalonia. We have a text box. Let's click that. Oh, look at that. It's from Avalonia. The button is also from Avalonia, but then we have this controls Maui control host, and within that we have Maui control.button. If I click that, we can see, oh, that's a Maui control. So continuing down, we have the progress bar, which is coming from Syncfusion, and then below that we have a text box, which is Avalonia, and then we have the media element, which is coming from the community toolkit. So there we go. We've decompiled that as well, so you can have a look. And now let's run that on the simulator. Here we go. So Avalonia, 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 Maui, Maui, and then this control here is Maui as well. And I can skip forward and we can see the progress ring from Syncfusion is moving as expected. There we go. So this is absolutely excellent if you've been looking at Avalonia and you've been thinking, oh, I'd really like to use it on mobile, but they're missing this control, they're missing that control. Then you now have the ability to mix and match in both directions. And so as I say, it's over 150 plus pro controls are now available to you within Avalonia that are mobile specific, which is fantastic news. So moving on, Avalonia XPF. So this is something I'm really excited about. We created a company, the core team, so there's about 12 of us now, that had been working on Avalonia for years. And there was a huge demand from businesses to help them migrate to Avalonia. Now, it would either be support contracts or development services. And if we take development services as an example, large companies would pay us to port their applications to Avalonia, typically from WPF. And there's a couple of problems here. Number one is the cost to the customer is quite high, and the time it takes is quite long, especially for very complex applications. And then from our perspective, we don't really want to grow old porting WPF applications to Avalonia. Like we can do it. There's no problem with it if that's what you really want, but it's not ideal for you. You're going to have to spend a lot of money and, kind of put development on pause for a few years. You're not adding new features. You're just reinventing the wheel to stay in the same place. So we decided, well, why don't we fork WPF, rip out the internals and replace it with Avalonia? And it sounds mad, but that's what we did. So right now we support Windows, macOS, and Linux. We do have internal previews of iOS, Android, and the browser, but we'll be shipping those kind of licenses and selling licenses for that next year. So with this approach, by utilizing WPF and replacing the low levels with Avalonia, we can take your application to new platforms with little to no changes. So this is absolutely huge. And this means that the core team can pivot from, instead of creating applications specifically for one or two customers that nobody gets any real benefit from that other than the customer, we've now got a source of revenue that allows us to continue to build Avalonia for the greater good of the community. So we're really excited about this. So in terms of the architecture, we've got WPF here on the left and XPF on the right. So presentation framework and presentation core are largely unchanged. There's almost zero changes that occur within these two layers. Where the difference begins is in this mill core layer, which is the composition engine of WPF. So WPF is very similar to Avalonia, or Avalonia is similar to WPF, in that people talk about it being a native UI toolkit for Windows. Well, it is. It comes with Windows, but it's rendering everything to a DirectX canvas. So in the same way that we render everything to a skier canvas, we're both just rendering, and there's a composition engine to do that, to take all of your UI controls and the animations and all of that goodness and turn it into pixels that we can push to a canvas. So that's the layer that we've gone ahead and replaced with Avalonia. And then we've had to do a lot of work around implementing GDI and some Win32 APIs to run cross-platform, things like the registry, which are very common for applications that kind of sit at the top layer all the way up here, that they expect to be there. So yeah, your application sits up here. We update the project SDK, we hit F5, and then it starts running on XPF, and we can run that on macOS and Linux, and obviously Windows, and new platforms coming soon. So I'm going to show you a demo. Let's start with family show. So this is a packaged application. So in fact, I'm just going to show you. We'll show in Finder. There it is. Let's do package content, Mac OS. We can see these are all just native libraries. So we've done a ahead of time compilation, which is impossible to do with WPF. We've made it possible with XPF. So this is a really early example application that was made for Microsoft to demonstrate just how cool WPF is. And with very minimal code changes, we've got this running here on macOS, and we can also have it running on Linux as well. And this is available to download from our website if you want to try it out. But yeah, so it's a properly packaged application. But let's look at some other things. So here we have a sample application from Syncfusion. So this is an interesting one because third-party control vendors, they have absolutely zero concept of XPF because a lot of these control libraries were built before XPF existed. So we have to make sure that these control libraries continue to work. With the only changes that we're making is within the CS proj. So you can see I've updated the project SDK. In this case, I'm using a local build of XPF that I have on my machine, but we also have a NuGet packages that are available, private NuGet feeds to paying customers who are using XPF. But apart from that, it really is just a WPF application. So let's pull out some. Here we go, XAML, and we can see, the namespaces. It's all just WPF. And obviously, Ryder is quite adept at understanding how to deal with WPF XAML, even though we're not on a PC. It understands how to use that, and all of these types are resolving as they should once we update that project SDK. So I'm going to hit build, and we're going to run this. Now, we haven't worked with Syncfusion to make this work. These are the standard NuGet packages that you can go and find on NuGet today, but they're now running on a Mac. Now, the first thing I think that is really quite obvious is that the window decoration is entirely wrong for a Mac, and that's because this is a custom window provided by the Syncfusion SDK, and it obviously is designed to only run on Windows. So they had no idea that we would be savages and try and run it on a Mac, but it does work perfectly. So our general advice is you probably just want to use a native window when you're using XPF rather than these custom windows. But there's all of these showcase just work, and we've got stuff like I quite like the 3D charts. Here we go. And again, zero code changes. This is just the standard code that is coming from Syncfusion in those NuGet packages, and it's their sample application that we've taken and we've made run on macOS, powered by XPF. What else have we got here? We can add some text. Say hello world. Yeah, bold, perfect. What else? I mean, there's a few other controls. So you can see these complex controls just working. And we've got great support. Oh, we'll ignore that. We'll pretend that it will just work perfectly. We've got great support for a huge amount of control vendors. So ActivePro, Syncfusion, DevExpress. We're working with SciCharts to enable those charts to run on XPF as well. And this is another example application, this time from Infragistics. And again, we're just updating the project SDK. The rest of the application remains unchanged. So we're interested in Microsoft stock price over the last, maximum whatever. We can see it's all very performant. In our internal benchmarking, we're seeing fantastic performance, and customers are letting us know that they're seeing increased frames per second and increased performance, which is great to hear. So you can grab a trial for XPF and test it with your applications. Just go to avaloniaui.net/XPF. And if you do buy a license, then it goes towards supporting us to continue to build the open source project. And lastly, I'm almost finished here. We've got hybrid XPF. So in some situations, we found customers they want to migrate to Avalonia, but there's one or two controls that just aren't available within Avalonia that they want. And while I'm growing and working to grow the ecosystem, we're not there yet. We're not our final destination. So we asked, wouldn't it be great if you could take one or two WPF controls and embed them within your Avalonia application as a kind of stopgap, so that you can still ship a cross-platform application to macOS, Linux, iOS, Android, and the web, but have this dependency on this critical WPF control that you need in order to make that project a success or even viable. So that's what we've got with Avalonia XPF, and I will show you a demo. Dun, 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 dun. Here we go, hybrid XPF. So in this case, I have my main window, which is, notice, a XAML, so that's Avalonia XAML. We have our shared main view model, but we have this XPF container. So the XPF container has then got this scheduled view, and if I command click that, we can go to the XAML for this, which is just here. But this is a WPF control, and in this case, we're using Syncfusion, and we're using their scheduler. So I'll run this because I'm running short on time. There we go. So this is a WPF control embedded within an Avalonia control. So this is the hybrid approach, and this now brings over 700 Pro UI controls to Avalonia for you to enjoy. And that is a wrap. If you want to learn more about Avalonia, I recommend heading over to our GitHub, which is Avalonia UI/Avalonia. And we have a really active community of developers on Telegram who will be more than happy to help and assist you if you have any questions or get stuck. And there's also getting started in documentation and all of that goodness that you can find on our website, which is avaloniaui.net. Thank you.
All right, that was a great talk. A lot of good stuff in here. Yeah, I really like that whole success overnight after 10 years of development and hard work. It's really true. Yeah, definitely true.
It's been a journey.
Well, it's looking fantastic. I got to say, I was very impressed with some of the demos there. Actually, that's it looks really cool. It looks really good. And yes, we're using it in Rider as well. So if you're using the profiling tools, the .memory and .trace style profiling tools in Rider, those are actually Avalonia controls embedded in Rider. So there's lots of cool magic going on with all of these things. It's brilliant stuff. It's cool. So thank you very much for the demos there. I'm going to dive straight in with a fairly basic question, because I'm aware of Avalonia, and I'm aware that it's like a cross-platform UI toolkit based on XAML, and it's like, well, I also know about WPF, and that's a UI toolkit based on XAML, and it's like, well, what's the relationship between the two XAMLs there? Avalonia XAML is not WPF XAML, is it?
Yeah, so we're inspired by WPF, but we're not a one-to-one copy. So we're really similar, but there are some places where we've made changes. So I think styling is the most obvious one. Our style approach is more like CSS. But yeah, if you've built with WPF and you've experienced with it, then you're basically an Avalonia expert. It will take you a couple of days to get up to speed and be really proficient with it. So because we're so similar, there's a natural journey for WPF developers that want to go cross-platform, or they're looking for a modernization technology, being worried about the future of the technology and wanting to future-proof their applications.
Yeah, that's really cool. It is. It's just I think XAML itself is just confusing, because you hear XAML and therefore you think WPF, and so when you come across it in somewhere else like Avalonia, it's like you're not quite sure what the relationship is. So it's nice to know that it's similar, but it's your own flavor of it then, I guess.
Yeah,
and also very impressive. Sorry.
I was just saying, we didn't want to be tied to, WPF is very much a Windows technology. We've made it run cross-platform, but what we see from a lot of customers is that they're using it as a stepping stone to migrate fully to Avalonia and get all of the benefits of a modern XAML UI framework.
Yeah, and also very cool that you can actually, is it the XPF which can run WPF applications? That's some pretty cool magic going on there as well. So very nice stuff. Yeah, sorry, Rachel, were you going to say something?
No, agreeing. Very nice. Good. It is almost like magic. There is another question here. It should be kind of an easy one, I guess. Can MAUI controls also be embedded on Mac and Windows?
On Mac and Windows, they can't. So on Mac, MAUI is using Catalyst. And as I mentioned right at the beginning, we have our own, we call it microcom. So we've got our own bindings to what is AppKit. So that's kind of the older way of building macOS applications, which means that we can support a broader range of versions of macOS. So there's no path for that for macOS and Windows, but MAUI embedding is just iOS and Android right now.
Okay. Next up, actually, before we go on with more questions, do we want to do a raffle?
Oh yeah, let's kick off a raffle, and while that's running, we have some more questions. So yeah, we have a question for that. Nice one. If you've been paying attention, you should know the answer to this one. What is the cross-platform rendering platform that many UI frameworks are using to deliver experiences on Windows, macOS, and Linux? As a tip, Avalonia UI is using it. So we'll see if anybody's been paying attention right at the start there. And we'll see. Oh, straight in there, Alex.
Oh, right away.
Oh, that was clearly too easy.
I was
thinking we haven't mentioned it for a while, and it's too easy. Of course, the answer is Skia, and that's the underlying library that you're using to power all of Avalonia.
So it looks like Alex L got to it.
Yeah, Alex L, if you send us an email, we will then arrange the raffle prize for you there. So we'll jump straight back into a question then. I'm speaking of rendering engines. Someone was asking about Skia and also asking about Impeller. So like if you've used Skia, what about other rendering engines such as Impeller, which I'm not aware of, to be perfectly honest?
Yeah, so Impeller is the new rendering engine that's going to be powering Flutter. I don't think it's GA yet. It might be, so forgive me if I'm wrong on that, but it's certainly it's focused on mobile. So right now it supports iOS and Android. It's something we're aware of, and I've kind of talked to the team about maybe we look to support it in the future. But our strength is very much desktop. So Ski is working very well for us right now. We can swap out the rendering technology pretty quickly. It's not a huge amount of work for us to do that because we're so well architected in terms of clear separation of concerns. So yeah, it might be something we look at with V12 potentially next summer. It might be a slightly more longer term depending on how the project progresses.
Cool. Rachel, have you got a question?
Yeah, yep. Here's not so much about the code per se. How about the job market? What is it like for Avalonia developers? What's the uptake from businesses? And are people moving from WPF? So yeah, that's interesting because I do a lot more web stuff. I don't go over there. What's it like over there?
Yeah, so there's a huge amount of enterprises looking for Avalonia developers. And it's very global. We have some data on where people are when they're building or consuming Avalonia, and it's very much a global technology. So yeah, there's a huge amount of demand for developers. But I think that if you're struggling to find jobs and when you're looking on like Indeed or other job search websites, a lot of companies are still looking to hire WPF developers and then start that migration process. So as I say, if you have experience with WPF, then you're already an expert.
Gotcha.
That sounds good. It's nice to have transferable skills with that then.
Yeah,
that's good. Another quick question, and I think is about the binding system. Do you support compiled bindings?
We do. It's switched on by default.
Okay, I must confess that I don't know what compiled bindings are. So would you mind elaborating a little bit?
It means that we can do ahead of time compilation, so that rather than having to resolve the binding at runtime, it's all done ahead of time, and it just means your application is going to be faster, and the views are going to load faster, and it's going to be just much more responsive.
That sounds good. That's the kind of thing we want. Brilliant. Do we have any more questions, Rachel, or should we move on?
There's one more left, which is, can Avalonia support or embed Blazor components or Razor syntax similar to how Maui Blazor Hybrid does this?
Yeah, I saw somebody in the community was working on this last week. I saw, and even before that, I've seen examples of someone playing with it like a year or two ago. It is possible. It's not something we support as a first party from the core team, but there are people in the community working on enabling that as a solution.
Okay.
Yeah, that sounds fantastic. Okay, then I think we'll wrap up. Mike, thank you very much for a fantastic demo there and a presentation. It's a really impressive bit of technology, and it looks very cool. And they're getting a lot of love in the comments there as well. A lot of people impressed, and I think they might be wanting to try it out. So this is very good.
All right, thank you
very much. And we'll drop you off the stream. And I think it might be time to bring in our next host. So who is it we've got coming? It's Khalid.
Hey, USA!
Yeah.
You sound disappointed, Matt. What the heck? What the heck?
That wasn't disappointment. That was just pure love.
All right, thank you. I appreciate that. The hosts have been doing a great job. Mike just did a great job. That XPF stuff is completely mind-blowing. And that family thing is just out of this world. Like, the performance was just insane, I think. So
yeah,
it's crazy. So
it does. It looks pretty fantastic, and it's nice to see that we've got so much support in Rider. And again, I think that comes from actually using it in there as well. I don't think we'd have been able to bring the profilers cross-platform without it, to be honest.
There was one thing that I think kind of like I can feel our Rider devs kind of sweating a little bit, which is like mixing Avalonia XAML syntax with like WPF XAML syntax all in one view. I can just feel the drops of sweat coming down.
That looks like a headache waiting to happen, doesn't it?
Yeah.
But yeah, our devs are great. They'll figure it out. But yeah. So Rachel, thank you so much. I don't want to, I don't want you to wait any longer than you have to, but you're welcome to stay. But if you need to go, I'll take over here, and Matt and I can kind of just chill out, think about.
Yeah, this is good.
Yeah.
We could just take it easy,
Yeah, we'll just vibe a little bit, think about our next guest that's coming up. Actually, our next speaker probably has some of my favorite features that have come out in Rider recently. Like, I'm a big fan of our next guest. I know he's sitting there in the green room. I could see him. Nobody else can see him, right?
Not yet. Should I bring him in?
He looks happy. He looks excited. So let's introduce him. Andrii, thank you so much. How are you feeling?
Thank you, folks. Yeah, I'm great. How are you guys?
Pretty good.
Doing well.
Now that Matt says he loves me, I feel a lot better. So
the things you say when you're live streaming, honestly. At least it's not recorded and be played back to me lots of times.
Yeah, I'm gonna clip it. It's gonna be a YouTube short, and
yeah,
it's gonna be great.
This is good. Anyway, we should let Andrii get on with talking about his session. So Andrii is one of the developers we've got here at JetBrains, and yeah, we're gonna let him take it away and talk about working with WASM applications.
Yeah, hi folks. So let me start. So hello, my name is Andrii, and I'm a software developer at JetBrains, and I'm working at the Rider development team. Today, I would like to talk about the implementation of debugging functionality for Blazor, WebAssembly, and other types of the .NET WebAssembly applications, and how they differ from regular debugging. In addition, we will consider the anatomy and structure of such applications. A little bit about myself. At JetBrains, I'm involved in the support and improvement of the debugger for Blazor applications, anti-framework and anti-framework core tooling, as well as some features of run configurations. For example, the configuration for debugging Roslyn source generators or multi-launch configuration. In addition, I also do some open source contributions and develop my own projects in my spare time. Below, you can see the links to my social networks as well as to my blog. Let's start from the very beginning, namely, what are the members of the already not so small family of .NET WebAssembly applications. Historically, Blazor was not the first. There were some more and less well-known frameworks for Microsoft and third-party authors that made it possible to run .NET in the browser. Consider, for example, Silverlight or the more recent but already dead Bridge.NET framework. But Blazor became the first-party framework for .NET in the browser through the WebAssembly technology. I would like to know that for this talk, I will exclude the Blazor Server, Blazor United, and Blazor Hybrid frameworks because they are a topic for separate big conversations and are technically implemented very differently. Currently, Blazor WebAssembly can be used as an independent single-page application that will be hosted using the dev server that comes with .NET SDK, or if you have your own .NET Core backend in it. According to our observation, this is the second one is the most frequently used option because Blazor is primarily about .NET full stack development rather than only front-end one. With the appearance of .NET 7, two new options appeared as part of the new new SDK workload, which allows you to build not only Blazor but also almost any .NET code in WebAssembly. Along with that, two new runtime identifiers appeared. It's browser WebAssembly and the console WebAssembly. The first is to run WebAssembly in the browser. The second is to run it within the Node.js runtime on the terminal, a local machine, or remote machine. In .NET 8, a similar workload will also appear, but for the WebAssembly system interface, a very popular standard for WebAssembly, which will make it possible to run WebAssembly code not only in the limited environment of the browser and sandbox mode, but also outside of it. For example, it allows to access the file system, network environments, system calls, and etc. WebAssembly System Interface SDK, or WASI SDK, is a short-term prototype of what was already mentioned above, so it's not so relevant anymore, but it is still working. And native AET-LVM WebAssembly project is a rather experimental way to compile an application and runtime using the special scripting toolchain, which is a part of the native AET-LVM project. From the runtime lab of .NET, and into almost fully precompiled AET code. So this approach has many advantages over the convenient mono ahead of time compiler, but is currently not ready for use in real production projects. So let's move on to the first chapter. We'll look at what exactly almost any .NET Web Assembly application is. Let's start with the regular Blazor WebAssembly. First, let's create a new Blazor project from the template that comes with the .NET SDK by default. And then go to a newly created directory, and let's see what index.html looks like. Here you can clearly see where Blazor boots up and initializes. The principle is almost the same as in ordinary single-page applications. So we have a div with some ID, which is the framework knows about and which is fully populated, rendered, and managed by the framework itself. And now let's build a project. And if we go to the directory containing our compiled binaries and analyze its contents, we will see several interesting files. First of all, it's blazor.boot.json. It is responsible for what dependencies the application has, the versions of these dependencies, and other less interesting posts. And among other things, we see .NET.WASM, and this is our .NET runtime. Mono 1 to be more precise, which was specially compiled using AppScript into a WebAssembly binary. It is this runtime that runs the application code that we created, and in the same directory we can see the .NET.wasm file, and next to it the usual DLL dynamic library with the newly created application. You can also see the already known blazor.wassembly.js, which glues all other files together and configures the runtime. Well, now let's look at the process tree. Let's go back to the main directory of the project and let's run the application through the usual .NET run. We are interested in exactly what the processes that the framework will create after executing the launch command will look like. So using the process hacker on Windows or htop in Unix, we can build a tree. The nodes which will continue to display the command line that was used by the .NET SDK to launch relevant processes. So since we created the project from the default template, the static files with the Blazor frontend discussed earlier will be hosted using dev server, which is a regular .NET application. And this can be seen from the first arguments to .NET command, and the second argument contains the path to the application itself that needs to be launched or executed. Now let's repeat the similar experiments with the project template installed together with WASM experimental workload. For this, we need this two workload to be installed. And after that, we are able to create the project from the new template. And let's go to the folder with the project that we just created and look at the index.html file again. We see that there is no Blazor anymore, and the JavaScript code from main.js is located as a model for execution. This is very different from the Blazor approach, where we have very little control over the breakential launch process. Well, now it's interesting to look at main.js. We can see that here we already have some more control over what happens to our application code at startup. This allows you to make fine-tuning of settings by passing parameters to mono configuration, such as network download policy settings in the case of using WebGL. And in the case of using WebGL, it's quite simple to specify the canvas to be used for rendering, for example. And to chart the logging level of monologues, it's also possible to adjust any possible mono runtime settings like logging. And it is very important when porting the regular desktop or console application to a web one. Let's also look at the build result. So unlike Blazor, we have an unbundle directory that consists of slightly different content. A monoconfig file has appeared that is generated automatically from the project settings, and which also gives a more accurate understanding of what exactly will be performed. It immediately becomes clear that there is an entry assembly and in which directory it can be found. All DLL files move to manage directory, and next to .NET.wasm, we have the same API with the main.js, which is the entry point for the runtime API. And instead of boot.json, we have runtime config.json. Let's take a look into it. Let's remember, WASM experimental projects add a new runtime identifier, which is why the runtime config.json file was created. Such files are also created for some older .NET targets when publishing. And here you can also see a link to the entry assembly as well as to the index.html file that loads our application code into the browser page. Well, let's look at the difference in the process tree of such applications. We immediately see that the project is not started using dev server, but using an internal application called WASM app host. It is something like a server as before, but is not installed using the .NET package, NuGet package, as it was in the Blazor where you have the server or dev server package, for example. But it's taken from the WASM experimental directory in the .NET SDK from the workload that you installed previously. It is very likely that this approach will be used for Blazor itself in future versions of the .NET SDK, because it's more authentic and understandable from the point of view of tooling. And now it's clearly visible where the runtime config that we discussed earlier is used. As you can see from the command line, it is used directly when running .NET Run. And let's make intermediate summary here. Almost any .NET WebAssembly application runs with the mono runtime. This is very important to understand because despite the fact that you specify the compatible version of the language and the target framework, some C# functionality that you compile will not be understood by the runtime. A recent example is, for example, using the newest feature of generic arguments in attributes. It's okay to compile the project with such features for the WebAssembly, but at runtime it will fail because of some internal mono runtime bug because it just not applied this feature in the mono runtime itself, and you should be ready to face some issues related to runtime and compatibility. As application developers, we can configure the runtime for the required behavior. And the .NET WebAssembly applications can be distributed and in different servers. Dev server that comes with the NuGet, and the WASM app host that we have in new workload, and SNET Core, your own SNET Core backend that most likely you will create for your real project. And but several open questions remain. How exactly will the debugger work with our application runtime, and how will the debugger manipulate the browser and vice versa? Before revealing all the cards, let's stop at debugging a regular .NET desktop application. We have some runtime. The runtime runs the code of our application, and when the runtime starts, it waits for the debugger to connect to it, and then continues executing the code. In the case of local debugging, the debugger client is in almost the same environment as the runtime, so the lifetime of these entities is understandable and expected. But yeah, now let's move to the .NET WebAssembly applications. First of all, we have a Chromium-based browser. The browser hosts the user page in the form of tab. The tab hosts a regular WebAssembly runtime that can execute special .wasm code. The runtime starts the mono runtime, which is already able to decode and execute a common intermediate language assembly DLL file. And finally, as part of this runtime, the code that interests us from the point of view of debugging is executed. Rather complex onion-like architecture emerges, and through which the debugger needs to be able to monitor and decode execution process and receive events in reverse direction. And such a mechanism for doing so exists. It's called monodebug proxy, and in this section we will look at it in more detail. Let's go back to the process tree. If we run it in debug, throw rider to see the difference, we'll see a new child process. This process has some interesting arguments. First of all, this is the process ID of the parent process. It is necessary to correctly monitor the change of its state to the operation system and react accordingly. It is not of much interest to us, but DevTools URI is the one key element of work of all this stuff. Let's return to our scheme with the missing puzzle found. So now everything is in its place. Bug proxy, let's call it that for simplicity, when starting receives all the information it needs to work both with the browser tab to somehow influence and receive events from the browser and with monoruntime, which hosts our application in itself. The intermediate level of abstraction simplifies the implementation of the debugger for the client, because now it only needs to correctly implement work with only one entity and nothing else. So let's summarize. The client does not work with the browser type directly. The bug proxy acts as a kind of communication bus between the browser, the debugger client, and the runtime. If we talk about interaction with the browser, we primarily mean the transfer of calls and events to and from the browser page, if they are not related to the .NET world. For example, information that the page has downloaded something or navigated to some URL and so on. The same applies to the calls and events from the .NET world, which do not need to be given to the browser. Unfortunately, since this is a rather specific part of the .NET SDK and is used only in the .NET in the IDE tooling domain, it does not have a stable API. And in order to maintain a correct contract, you need to research its source code. So we already know the concept of how these three components will work together. But what about the implementation? How exactly does a handshake and communication take place? It's time to talk about the protocol used when all these actors of the system communicate. So I'll start with handshake. This is the most complex and unstable process in the entire mechanism, so it must be reviewed in small details. On the right, you can see the sequence diagram, so you don't get lost in these caps. First of all debugger client starts a process with the application. If done correctly, .NET will figure out how to host the application. In case of ASP.NET Core, it's easier. We just take and run the backend as in the case of regular ASP.NET Core application. The infrastructure that is added using the use Blazor debugging method at the startup stage. As a result, we have the bug proxy as in one of the previous slides with 3. After waiting for the application to start, we check this using a special HTTP health check. The debugger client starts the browser in debug mode. Currently, only the Chromium family of browsers is supported because it is because of limitation on restrictions of the debug proxy protocol itself. It is important to make a clarification here. We launch the browser not with the actual or final page of the application, but with a special URL that we call a placeholder. We will talk about why this is needed later. At the time of startup, the browser stores the port and path in the special file inside the user's directory, which is required to create a debugger connection. After that, debugger client creates a debugging endpoint, a special WebSocket URL that includes the port and path obtained after reading the file from the previous point. Having a suitable debugging endpoint, it must be given to the debug proxy so that it can be make a connection to the browser. To do this, we make a GET request, which is processed by the use Blazor debugging middleware that every Blazor backend has, and the link format used in the request may be familiar to some. The template for this request is stored in launch settings in a profile property called inspect URI. Let's go further. The bug proxy responds to our request as follows. It makes all the necessary connections to the browser and the monoruntime, and then returns a special status code of 302 redirect, and as well as a special URL in the response body. Having the URL from the redirect, our debugger client already creates a connection to the debug proxy. And after that, the logic begins, the implementation of which is necessary for the correct functioning of the debugger. First of all, we send over the protocol all breakpoints that were added by the user in the editor before launching the application itself. Let me remind you that we started the browser with a placeholder page or empty page, so the runtime has not yet been loaded. And therefore, the debug proxy will record all requests and will implement them or send them only when the runtime is ready to receive. If you do it differently and loaded the user page right away, we wouldn't be able to do necessary configuration in time. For example, the user set a breakpoint at the very beginning of the main method. There is a high probability that the runtime would have executed this line of code before we notified the debug proxy about the error, and it simply would not have run in time. More formally, we may receive a classical race condition here in such a case. Next, when the necessary preliminary requests have been completed, the debugger client can finally open the actual user page in the same tab instead of the placeholder. By the way, this is an example of request that is proxified into a tab and doesn't handle by mono. As you can see, navigate is just proxified and not handled in mono. The last step, the debug proxy finished all activities related to activation of the runtimes, loading assemblies, etc., and sends a signal to the client that is ready to work. And at this point, finally, initialization can be considered complete. A moment of recap. Such a rather complex process creates the probability that anything can go wrong, and not to mention that variety of environments that can be on the user's PC. So it's very important to cover the whole Blazor debugging lifecycle with proper automated and manual testing. A workaround with placeholder pages allows us to delay the initialization of the runtime and accordingly the launch of the application code as much as we need. So there are other technologies such as sending a pause signal to the debug proxy to pause it at some point at the very beginning, but as they are not so reliable, we use them and we can't rely on it. There is one more nuance related to Chromium browsers. It's not possible to run two browsers at the same time that share the same user's profile directory. If you try to do this via the command line, the tab will open in an already existing browser. And quite often, users need to test applications in the environment of their real accounts and settings. Such cases should be tried to be correctly identified, and users should be informed about it. So what kind of protocol itself is used that we are talking about? And why we need a WebSocket connection. So Chromium browsers implement the so-called Chrome DevTools protocol. Those who have worked with Selenium or other front-end test automation tool may know about it. Through this software interface, you can do almost anything with the browser and pages within the limits of the user security settings. Fortunately to us, this interface is well documented and versioned. Structurally, it consists of so-called domains or modules, and which in turn consists of types, something like a structure or record that participates in the transfer of specific data, methods or calls that the client can make to the Chromium instance. And also there are the methods that the Chromium instance sends to the client. On the right side, you can see examples. By the way, In our case, debug proxy is also considered as a virtual Chromium browser because the concept of connection to it is identical to Chromium. In order to consider the domains of the CDP protocol in detail, you can use the official API Explorer. The link is on the slide. Debug proxy has some additional methods and events. There is no official standard for them, so we created our own fork of the API Explorer, which we update as soon as we find something new in the source code and update our infrastructure as well. The link is also on the slide. Now let's talk more specifically about the transport level. First of all, what is obvious, the protocol is based on WebSocket. On top of WebSocket is a somewhat informal variant of JSON RPC 2.0, which is a format for describing remote calls using JSON payloads. Also used in, for example, in Visual Studio Code and Visual Studio for as a part of the language server protocol implementation. Messages from the client are always ordered. There are three types of messages: requests, response, and events. Events are not ordered, while the requests are ordered. What is very important, you can create several so-called sessions within the single connections. This is necessary, for example, when we want to control both the browser and the browser tab at the same time without creating a new connection. Here you can see the example of payloads for requests, responses, and events. There is also the concept of a target for attaching the session. There are many types of targets. So first of all, we are interested in the browser and the page, but there are many different types of targets depending on what behavior you need when using the protocol. By default, when you create a connection, you immediately connect to the browser targets. It is not based and can have nested sessions such as pages. Finally, we can now move on to some examples of the implementation of protocol itself. First of all, it is an API that is required to create and maintain a client for CDP connection. We have developed a fairly simple SDK for it. On this slide, you can see the connection being made on the comments and the comment being sent. A comment corresponds to the method in the CDP terminology. It can be sent waiting for a response or in fire and forget mode. In this example, the setDebugger property method is called in the .NET Debugger domain, which is defined precisely in the debugger proxy extension to the protocol. Since almost the entire set of domains we need is supported by developers in the form of JSON specifications, we decided to write code generation to create all the necessary methods, events, and types automatically. We dispense with the use of source generators because in this case, the input data is not related to C# or Roslyn, and also because they will be updated quite rarely, and several dozen classes need to be generated for each class for each domain, which will be very frustrating for the development of for our tooling. And we are also investigating the possibility to use incremental source generators as possible performant alternative to just console application that generates everything that we have now. The result is a lean API with minimal manual intervention. So everything is generated automatically, except the runtime of this API. So in addition to sending messages, it is also possible to listen for events, as well as create new sessions, which are called scopes. And we are trying to avoid binding to CDP terminology because we will be extending this SDK to the Firefox debugging protocol as well in the future, because debug proxy itself will support Firefox protocol as well. So let's go further, here you can see the example of connection utilization already in the form of the code. And also you can see corresponding methods from the API Explorer itself. Since user-invoked methods must be ordered, they are not sent directly, but are put in the special queue, in a special long-running task in particular. So they are sent, and they are sent with assigned message ID. At the time of sending, a special task completion source is created for the same message ID and stored in a special concurrent dictionary. This source will be needed later when the API user wants to wait for a response. A separate long-running task also listens for incoming messages from the browser. They can be both events and responses to an already sent message. In the case of an event, everything is simple. We call the appropriate delegate, but in case of responses to messages, we get the corresponding task completion source that we created while sending, and no one needs ID. And depending on whatever it is a result or an error, we set the task completion status, task completion source status. Back to the examples. Breakpoints in CDP protocol work in such a way that we first send a reference, namely a file or a regular expression string with a pattern, and runtime loads different assemblies and source maps from different debug symbols one by one, as soon as it finds a candidate that matches our file name or pattern, it sends a special breakpoint result event. On the slide, you can see a simplified code example of how it's processed. It is very important to do this in a timely manner, so the IDE user does not see valid breakpoints grayed out in the editor. Processing of the logic of sending messages regarding the creation of new and deletion of old breakpoints is also done in the form of a queue. This is already due to specifics of the Debugger infrastructure in Rider. On the right, you can see a screenshot from the API Explorer page with a more detailed description of the method that we are using here. Although we did not have time to consider all the topics related to the debugger, so the logic of calculating expressions, watches, and call stacks remain outside of this talk. They are not unique from the point of view of implementation for the Blazor. So at the end, I would like to say a few words about the hot reload. The hot reload topic serves a separate conversation, but I would like to know the basic points regarding both .NET WebAssembly and ordinary .NET application. First of all, without debugging, hot reload is already possible using .NET Watch. In addition, just a few people know, but completely competently using startup hooks and startup assemblies feature, it is possible to inject the NuGet version of .NET Watch into the runtime environment without modifying the user code. There is currently only one option for hot reload during debugging. It's edit and continue. And let's describe the edit and continue work algorithm by one point. The user somehow gets into the paused context. For example, the runtime encouraged breakpoint. Then the user makes some change in the code. Then user made some changes and finished changing and clicks continue or apply changes. The new code is compared to the old one, resulting in three very important components. The changes that occurred in the IL code, the changes that occurred in the assembly metadata, and the changes that occurred in the debug symbols. Roslyn compiler infrastructure can calculate all these variables, but it's very important to correctly track the user's actions in the virtual workspace in Rider, for example, so as not to lose even a small change. The debugger then sends the changes from the point above to the runtime. Runtime accepts these changes and changes the ill code itself, metadata, and PDB. And debugger sends then the breakpoints to runtime again, because the old ones have already lost their relevance. And after changing the code, the user also may change the number of lines in files. So that's why it's important to update breakpoints. And now everything is ready. The debugger gives the go-ahead, and code execution continues from the point in code where it stopped. And yeah, that's all. Thanks for your attention.
All right. First of all, Andrii, that is like mind-blowingly difficult and complex.
Yeah, who knew it was all quite so complicated as that?
Oh man.
So steps to get through.
Well, my favorite part of the talk was when you were showing .NET debugging, and it was like one jump to a process, and then you switched to WebAssembly debugging, and it was a labyrinth of layers. It was like,
yeah,
it was like digging into the core of the earth. So thank you for all the work you do on WebAssembly. But I have a question for you. You were talking about .NET workloads, and specifically about WASM experimental. A lot of people, when they hear the word experimental, they think, oh, this is going to be unstable. Maybe it's not production ready. From your experience implementing and working with the workload, how accurate is that experimental word when it comes to using that workload?
I think that these workloads should currently be used more in for just trying it out, because currently it's the most stable way of writing the migrating from the desktop or console one or console application into the WebAssembly world. And this workload still exists for .NET 8, but at the time of when I created this whole presentation stuff, I relied on the state of development ecosystem for the .NET 7 version of the .NET. And I think that in .NET 8, with the upcoming Blazor United and all the stuff, I think that in some way it will be made more stable and ready to use. But yeah, currently it's quite experimental. It means that it is stable to use, but the flow and the build structure and all the stuff may change. But I think that concept will remain the same.
Mm-hmm. Yeah, I know that the Byte Code Alliance is doing a lot too with the specification around WebAssembly and WASI stuff. So there's still a lot of unanswered questions when it comes to this technology. It's really stable, but I figure that's why it's experimental, because while Microsoft is doing a lot of the workload work, they're still dependent on outside parties to kind of know if anything's about to change, right? So they don't want to make any promises and guarantees in terms of this is going to be the same, because they don't have control over that.
Okay. I would like to also to mention that the biggest problem with any WebAssembly development, not only in .NET but overall, it's the standardization process, because there are a lot of features that are implemented in a lot of runtimes. Basically, it's something like from 5 to 10 different runtimes for the WebAssembly exist, and they implement different set of features, and the overall centralized standard is moving very slowly, and that's why many features implemented differently in different runtimes, and they collapse when doing it together. For example, WebAssembly threads and WebAssembly system interface threads. It's different threads model, and this is really a complex topic to correctly for people that trying to use WebAssembly, because it exists already a couple of years, but still lacks some stable standard to use.
Mm-hmm. Yeah, that's so true. Matt, do you have any specific questions?
Well, I mean, firstly, I'm surprised to see that the WebAssembly stuff is all sort of built on Mono, really, and that the .NET side of things there is using Mono, while we've kind of got, you know, a lot of, very familiar with very comfortable with using the new .NET 7 and 8 versions on desktop. Is there a particular reason for that? Is it tied to the protocol that you're using, or is there any plans to move to a newer version? Do you know?
Yeah, basically regarding the runtime, regarding the Mono runtime itself, I would like to know. I think that the reason why for WebAssembly stuff Mono is used nowadays, it's because it was just simpler to port to the WebAssembly itself. So we have CoreRT and other runtimes, but when Blazor was initially created, it was simpler just to use Mono, and the only project that tries to avoid using Mono is native AT LVM project, because it uses it does not use Mono at all, and I think that maybe it will in future it will also be possible to use it in stable manner of Blazor or WebAssembly.NET development.
Because Mono is well, I guess .NET Core, to look at it that way, .NET Core is more advanced than Mono in many ways. You know, there's I forget now who shares whether they share the garbage collector or not, but you know, .NET Core's garbage collector obviously is cutting edge, whereas Mono, I think, might be older now. So it would probably benefit to move to .NET Core.
Well, I'm gonna say, well, actually, I'm gonna push up my glasses here, but Andrii maybe could elaborate on this. One of the specifications that the Bytecode Alliance is working on is a standardized garbage collector, right? So that languages like .NET or like runtimes like .NET, whether you're writing C#, F#, or VB, I guess there's still some VB people out there. If you're writing it, you don't have to bring in the garbage collector. There'll be that kind of standard garbage collection that happens across different runtimes. Is that correct in my understanding of what's happening?
Yeah, I think that in future, when the standardized way of garbage collection will be introduced in and adopted by the runtimes, I think that it makes sense, because currently a big problem for those who are trying to write some plugin system or something like that using WebAssembly as a target assembly format is that WebAssembly itself is very coupled on having the ahead of time compile stuff. So it's really hard to embed. Not all runtime supports deployment format that, for example, has Blazor currently. So when it has some Mono runtime that sits and runs the .NET code, but it is not comfortable to be used in the current runtimes for the WebAssembly. And I think that in future, if this change will be adopted in some long-term perspective, it will be cool, really, because it will allow us to compile more garbage collector languages like Java or .NET or other ones without such problems.
Whoa, this is the .NET conference. Don't say the J word. Don't say it. I think we're gonna.
Don't upset the J word people here, as well, though. Come on, we can all get along.
Yeah. Go ahead, Matt. I think you have a question that you wanted to ask.
Well, yeah, I mean, looking at the complexity of the internals of everything you've had to build there to get debugging working, what do you think was the most challenging problem to get it going?
Yeah, the most challenging problem is currently what I'm working on. I'm working on the hot reload support with Blazor WebAssembly, and this is the most complex stuff here because, yeah, you know that not all parts of .NET infrastructure are open sourced ones, and it's more like reverse engineering and from like dealing with the tooling as a black box. It's quite a complex one, and yeah, I think it will be really interesting experience at the end, and this is the more complex, I think.
Yeah, I mean, I guess a follow-up to your hot reload journey. You mentioned when you were talking about hot reload that you know, a user might be working on code, they make some changes, maybe add some breakpoints, but during the proxy conversation between, say, writer and the browser, what's passed across back to the browser is the deltas, right? Like there's like state management happening between writer and the browser. How big are those deltas typically? Are we talking like full assemblies, or how do those deltas work?
These deltas basically, this whole technology, edit and continue, is highly limited of amount of changes that you can do without rerunning the whole application. So these deltas are basically, it's more like for changing some couple of lines inside the method, or adding maybe some simple method, something that doesn't break the overall structure of the execution code. So I think that they are quite small because in another, as you can see, for example, when you use .NET Watch for some hot reload, sometimes you see the message that you need to rerun your application and so on. And this is where a hot reload feature exceeds its limits. So yeah.
Yeah, that makes a lot of sense. I mean, I've talked to some of the folks on the Roslyn team, and just they're kind of whittling down the edge cases in terms of what code you can change that still can give you that hot reload capability. But there's still some edge cases where, like, you know, if you remove a method completely or something like that, you just can't do that delta-ing and have to restart. So Matt has an interesting question. I think it's more around, like, I guess, different WASM runtimes and potentially debugging. So
yes, this one's come from the chat, actually. Someone's asking, how about debugging WASM running in other environments to the browser? You know, so this all seems to be very dependent on the Chrome debug protocol. What about other environments?
Yeah, so in other environments, for example, if you're talking about console WebAssembly project, it will be slightly, it will be like made in slightly different anatomy. So it will also be debug proxy, but the host itself will look like a browser page, but it will be actually running just running an application that can proxify some messages, because actually you could debug, for example, you see the Chrome DevTools protocol, it also used, for example, to debug in Node.js applications itself. So it's not tied on browser, it's more like JS ecosystem. So you can also it also enables you to debug remote targets. And so debugging the such .NET application running not in browser, or for example in Node.js, it will be done in such a way. You could it just replaces the browser itself with an application, but the overall flow with debug proxy will remain the same.
Okay.
So I guess a follow-up to that then really is, do you need to build a new proxy for every environment that it runs in?
No. I think that this proxy, Microsoft made this proxy in such a way that you don't need to carry all things that they just enables you to have one single, let's say, gateway that you use, and it will just work. Ideally, yeah. So it has some issues like some breaking the JSON RPC standard or something like that, but in general, it should work like that. Yeah.
Okay. Hey, I have a follow-up question too, since we're talking about debugging. We talked a lot about Chrome and the Chrome DevTools protocol, and I thought I heard you mention that you're working on Firefox support. I know a lot of devs love Firefox. Like, what is the big difference between, say, Chrome DevTools, Firefox, and for macOS users like Matt and I, will there ever be Safari support?
Yeah, so currently we don't have we don't spend a lot of time in this direction because we don't see a stable support from Microsoft in debug proxy, and without this support we can't do anything for Firefox related. But I already investigated a bit the Firefox debugging protocol. It has some differences, but in general, it's quite similar to Chrome DevTools protocol, just different, let's say, modules and stuff like that. But I think that in future it will be looking at the source code of debug proxy itself. It will be just the similar connection experience, but with additional switches to use the Firefox. So it has some common abstractions, common layers there, but it's more a question, I think, for folks working on the debug proxy, because from our end, it's just we need to support the protocol, generate models, correctly calls methods, but proxy and communication will be done on their side.
Okay. Okay, very cool. But I'm definitely excited to see WebAssembly and kind of this model proliferate. I think I did a webinar. Folks can check it out on JetBrains TV with a previous guest. But one of the things I'm really excited about is the intercommunication between .NET and other ecosystems. Have you experimented with pulling in different WASM artifacts into one .NET application? So maybe one part's written with Python, one part is written with Rust, and kind of having them all operate in the same application.
Yeah, so there is a project exists that is called Xtism, and this is a plugin system that was made just for that, what you're talking about. So it allows you to have a host. We've implemented in one of the supported languages by WebAssembly, and have a set of plugins that could be written in any supported language using their PDK, and you just create a contract between them, and then you could just embed in your application different plugins in different languages. And also, as far as I know, in one of the future releases, it will be also possible to write plugins in .NET. So currently, it's only possible to use .NET as a hosting application, but it will be also possible to write plugins in .NET, and it's very cool. It has overall idea of having such let's say intermediate language, but not for .NET and for a lot of languages, for Rust, for example, for language named like G word, but yeah. So it has huge potential, but yeah, currently it's also like in not so stable state, but I'm looking into it. It will be really cool. And I think that it has great potential. Yeah.
Yeah, the two things I'd love to see come to .NET is a source generator that can look at a WASM file that implements the interface that's exposed in that WebAssembly artifact. And two, I'd love to see WASM supported in NuGet. So you could like add a WASM reference versus a package reference. Like that would be super cool. So
yeah, it's a great idea.
Oh, you're gonna implement it. I heard you heard it here first here, right?
Yeah. There you go, Khalid. You're over promising again. You get it the other way around.
Yeah, I'm trying to get people to make commitments here. That's what I'm trying to do. But no, I think it's great. So Andrii, this has been pretty awesome. Do you want to stick around and maybe we could do a raffle? I have a raffle question and I want to see if people get it. So we mentioned Mono a lot, but can someone tell us what the first UI framework that used Mono in the browser was? Okay, set, go. Let's see if folks can get it.
I don't think I know the answer to that one.
Oh, there we go. Yes, it is.
Oh, I should have known that
one. So
wait.
Moonlight.
Moonlight was the mono version of Silverlight.
Yeah, that's true.
Well, we got because Silverlight was WPF everywhere, and that was Core CLR. That was where Core CLR first came from, wasn't it?
Yeah, it's interesting. I think the answer is Silverlight, but maybe we can give away 2 prizes. The Moonlight one is really, really smart. I'll give it to Jason for coming up with that. So maybe I'll talk to Martin and we'll discuss it. So Attila and Jason, please contact us.
Martin's in a generous mood. Look at that. He's giving away 2.
just making it rain licenses on this webinar
this
here.
Good.
So Andrii, thank you so much. Thank you so much for this talk. It was really enlightening. No pun intended, enlightening, light, Silverlight.
Let it go. No, it's a fantastic session. Yeah. Deeply technical, and I didn't realize things were so complex in how debugging worked with WASM. And congratulations on implementing it, and thank you for implementing it. You know, it's
thank you. Yeah,
it's
from the bottom of all
stuff.
Of our hearts. Yeah. So thank you so much, and enjoy the rest of your day. Yeah, I think it's time to maybe segue to our next guest. So Andrii, we're going to say bye to you, and our next guest is waiting in the wings. They're from Engine, and I think they're going to be talking about high performance JSON serialization with code generation on C#11 and .NET 7. That's a mouthful of a title, but it's super exciting. So Ian, thank you for joining us.
Thank you very much for having me. It's great to be on.
You know, it's funny. Right over your head is WPF, and that's been a big subject for today. So
I wrote that book. So I have a pile of books I wrote in the past and haven't sold, holding up bits of my bookshelf. Those are structural.
Well, it's good to find a use for these things, isn't it?
Yeah. So yeah, if you're ready, Matt and I will be in the wings, and we'll give you the stage, and we can go from there. So good luck.
Yeah, I'm happy to go. Thank you very much. Okay, thank you everyone for coming and listening. I'm going to be talking, as it says here, about high-performance .NET JSON serialization with code generation. So I am going to be talking, first of all, about the performance issues that exist around what you might call old school JSON serialization. So anything using the Newtonsoft JSON.NET libraries. They're great, but they're not as fast as they could be. So we're then going to look at what has changed since then. How do we do things if we're targeting modern .NET? So what are the options in today's .NET 7? What's going to be like in .NET 8? And we're going to look at the performance enhancements that are available there. And we're going to see why they're able to go so much faster than the Newtonsoft versions of these libraries. We're also going to look at how the .NET SDK includes functionality that can take advantage of C# code generators to improve certain aspects of JSON serialization performance. And we're going to look at where that does help and also where it doesn't, because it's quite targeted the way in which it can improve things. We're also going to look at how you might go beyond what the SDK does and use some open source code generators to provide very high performance JSON deserialization in a way that has a lot of the benefits of regular serialization, but with some of the performance normally associated with much more kind of difficult APIs. So it kind of brings the best of both worlds. And we're going to look at how that's possible and how it works. So let's start with Newtonsoft JSON. what's up with it? I mean, basically, Newtonsoft JSON is great. It's everywhere. It's one of the most popular .NET libraries out there. Like forever, it was at the top of the NuGet package list because everything used it. So Newtonsoft JSON, or JSON.NET, as it's sometimes also known, hugely popular. Does everything you might want of a JSON library. So what's the problem? Why aren't we just still using that? And in fact, many projects still are using that. Why might you not, though? Well, performance-wise, it's got three major problems, two of which are kind of fundamental. The third of which could be fixed, but probably isn't the biggest one. The first two are basically inherent to how it works. So the first single big problem with Newtonsoft JSON is that it doesn't understand UTF-8. It's been designed to work with .NET strings, and .NET strings do not use UTF-8 encoding. For historical reasons that made perfect sense 25 years ago, .NET uses UTF-16 as its encoding for strings, but that's not how anything out in the wild works. You encounter a real JSON document over the network or in a data store or data lake or whatever, it is almost certainly going to be in UTF-8 form. So the first major hurdle that Newtonsoft JSON has to overcome is that the JSON you're going to want to process is going to be in a different encoding than it understands. So you've got to convert it somehow, convert the text format. So that's a problem. Another problem with Newtonsoft JSON is that it tends to allocate lots of objects and lots of strings. And although the .NET garbage collector is pretty good, it does an amazing job, the fact is that the more work you give the garbage collector to do, the less time your program can spend doing useful work. And so it's fundamental to some aspects of Newtonsoft JSON's design that it can't really avoid quite a lot of the allocations that it does. And these essentially limit the performance it's able to offer. And the third thing is that its serialization engine relies on reflection, and that has some issues. It's not the biggest of the three, but it is an issue. And all three of these things are addressed by the modern .NET JSON APIs. So let's look in a bit more detail about why some of those things are actually a problem. Here is some JSON. So this is a very straightforward JSON object. If you look at it closely, you'll see the top level is an object. It's got a property called name, whose value is a nested object. And one of that property's nested values is an array. So it's not massively complicated. It's got a little bit of structure like most real JSON objects will have. And so this is typical of the sort of thing we might want to process. I mean, maybe we're going to process 10 million of these things because they're sat in a data lake, but the basic structure might be just like this. So here is what it looks like in UTF-8 form. That might be a bit of a blur. The actual numbers aren't hugely relevant, but basically that shows you roughly how many bytes there are going to be for that much JSON. But as I said, Newtonsoft JSON works with .NET strings, and .NET strings don't use UTF-8. They use UTF-16. So one of the things you're going to have to do to work with Newtonsoft JSON is to get your JSON data into .NET string form. And this is how big it looks in UTF-16. It's twice the size. And if you peer closely, you'll see half of those are just zeros, because that's what you mostly end up with most JSON. Now, if you've got large volumes of non-English text, then maybe it's not so inefficient, because UTF-8 does get bigger as you use non-ASCII characters. But most JSON certainly has a high proportion of ASCII range characters. So in practice, your data can easily grow to be twice the size just in the process of converting it. So there's already two costs up front. One, the cost of conversion, and two, the cost of storing, 3 times as much memory as you really need it. You've got your original data and a copy that's twice the size. So you're already starting on the back foot before you've even begun to look at the first character. Now, let's look at what happens if you try and deserialize this with our sort of performance goggles on. So let's say we've decided we've got a .NET type that represents the structure of the JSON data that we're looking at, and we just want to convert that JSON data into an instance of that .NET type. Pretty straightforward, right? That's how we tend to deal with JSON. So this is a person object. It's got a name and a birth date, and that name, if you look at the JSON, is actually a sub-object broken down into given name, family name, and so on. And so when we deserialize it, we just expect those properties to be populated. And actually, that's quite a lot of objects, right? Because we've got an object to allocate for the person name. That's got 3 more properties. 2 of those are strings. Another one's an array with 2 more strings again. And the birth date's yet another string. So we've got 1, 2, 3, 4, 5, 6, 7, 8 .NET objects just for this one bit of JSON. It's not horrible, but it is a fair amount of data to allocate. And if you're dealing with very high volumes of data, you can start to give the garbage collector just too much work to do. You can basically end up spending huge amounts of time in the garbage collector as it cleans up after you. And that's not ideal. It's not the best way to be spending our CPU cycles. Now, some of this overhead is inherent to this style of serialization. This really isn't specifically Newtonsoft JSON's fault. You can deserialize it in exactly the same way with system text JSON, and you will have all the same problems for the same reasons. You know, you're going to have to allocate this many objects if that's the structure you're looking for. But there are also some JSON.NET specific overheads, largely around the data format that's coming in. So let's take a look at what this means in practice. Slight pause there because we have discovered every time I switch windows, we get a slight break in the audio. So I will stop talking every time I switch windows. Sorry, but we weren't unable to work out how to stop that in the tech check today. Anyway, I have a benchmark. So I'm using benchmark.net here to measure the performance of various things. I'm going to kick this off running right now so that by the time I finish describing what's going on, you will hopefully be able to see the results. So that's going to run in the background. So what do my benchmarks do? Well, they all basically do the same thing. I've got several benchmarks that are all trying slightly different ways of doing the same thing. They're all essentially looking through an array of objects for a particular value. So let's look at the data that gets set up first. I'm going to go into my base class. So this thing, basically the job of this base class is to set up this array here. So before every single test runs and before the timing starts, this constructor here is going to run. And it's going to populate this array with the JSON data that I'm going to parse as part of my test. So what's going to go in here? Well, basically 10,000 objects. So here's the actual .NET version of the data that we're going to load into the array. This person serializable class, this is basically a .NET representation of the exact same JSON data structure I was just showing you on the slide. So we've got a date of birth property, we've got a nested property representing the name, and inside that we've got given name, family name, and an array of other names. So it's basically exactly what you were just seeing on the slide, but in .NET type form. So this array, this loop down here, just creates 10,000 of these things, and is going to write all of them into that JSON UTF-8 thing down here. So we end up with a great big JSON array. Now this part's not being timed. This is part of the test setup. This is just giving us some data to look at. And the main thing to know is that every person here has a different name. So we're going to create 10,000 entries. The first one's going to be called Arthur1, because we tack an I on the end, then Arthur2, Arthur3, Arthur4, and so on. So they've all got slightly different names. They've all got slightly different birth dates. And so they're all just about slightly different from each other. And then our tests basically are going to parse that UTF-8 data. They're going to then somehow get that data into a form that we can wrangle, and the different benchmarks do it in different ways. And then we're going to look for a particular piece of data in that array. So we're going to look for the item whose given name is Arthur 5000. There are 10,000 entries in my array, so that one's going to be right in the middle. So we only actually need to look through half of the data to find that thing. But this is simple, but doing enough work to be representative. We have to be able to parse the JSON. We have to be able to go and look at nested properties of objects in the JSON and work out if they're what we're interested in. So that's not totally unrealistic. So let's look at what this first one is doing in detail. Takes our UTF data, wraps it in a memory stream, wraps that in a stream reader because we need to deal with the fact that this is in UTF-8 format, and JSON.NET doesn't do UTF-8. So the stream reader can be told the encoding, and then it can read all the data back out into a string for us. Now, some of you might be thinking, hold on, that can't possibly be the most efficient way to pass data into Newtonsoft JSON. I did try a load of different ways, and they're all basically indistinguishable in this benchmark. So this was the simplest and was not noticeably slower than any of the others. So that's why I've gone with this. There are some very tiny differences between exactly how you feed data into the deserializer, but they're so small that they make no meaningful difference to this benchmark. So we get all the JSON data as a .NET string, which remember is going to convert it from UTF-8 to UTF-16. And then we feed that into Newtonsoft's JSON convert.deserialize object method. And we tell it, I would like you to deserialize all of this JSON as one .NET array of person serializable. So my result, I'm expecting that to be an array with 10,000 entries in it. And then I'm just using link to objects. This is data.first. That's the link to objects implementation of first. It says, please find me the first element that matches these criteria. And then we rather arbitrarily return the date of birth. Why am I doing that? Well, I found that with benchmark.net, if you don't return something, you can occasionally find that the thing you were hoping to time gets optimized out of existence, which rather invalidates your benchmark. So by returning something, it makes it harder for the optimizer to get over enthusiastic. So anyway, that's my first benchmark. And let's see how it did. Are my benchmarks finished yet? Let's have a look. And I think I froze again for a second there, but hopefully I'm back. Let's see if we can scroll down to the end of that. Yeah, they're all run. Okay, so wow, that is a lot slower than it normally is. Probably because I'm running with the stream stuff simultaneously. However, the basic ratios all look the same, just everything's gone a bit slower than normal. Normally, I'd expect this first one to take about 34 milliseconds today, and it's done that in every dry run I've done so far today. But now on live, it's gone a bit slower. But it doesn't really matter because the ratios between the numbers are all consistent. So this is our first one. It took 50 milliseconds to process 10,000 entries. So that's about 5 microseconds per object. And if we look at the memory usage, you can see it actually ended up allocating about 22.5 megabytes of data in order to process those objects. And it's also told us how many garbage collections happen. So these are average, by the way, which is, you might be wondering what 0.18 of a garbage collection is. That's just the average across the number of times it ran the benchmark. So this caused an average of about 2,800-ish generation 0 garbage collects, 1,272 generation 1. These numbers are high. This is a lot of garbage collections for a single iteration of a benchmark that only took 50 milliseconds. So that's not great. On the other hand, 5 microseconds to parse some JSON is not that horrible. But this next benchmark, 11 milliseconds, is clearly a lot better. So let's go look at that one. So this next benchmark, still on Newtonsoft here, starts off similar. We wrap the JSON UTF-8 data in a stream and then wrap that in a stream reader. But now we're going to pass that into this JSON text reader. This is a streaming API. This doesn't try and decode the entire document in one go. We repeatedly call read and it passes us the JSON one sort of feature at a time. So we say, let's wait for the array to start. And then once we're inside the array, keep going until we hit the end. And then individually deserialize each object that we come across. And crucially, stop as soon as we find the one we're interested in. This ought to run a lot faster because this doesn't bother to look at the second half of the objects. So Arthur 5000, that's halfway through. It's never even going to try looking at the second 5,000 objects because as soon as it finds that one, it's going to stop. So this should be a lot faster. It should be twice as fast, right? Because we're doing half as much work. But actually, it's a lot better than twice as fast. 50 milliseconds versus 11.5 milliseconds. Okay, normally when I run this, that's 34-ish, and that's 9-ish. So it's not quite, it's a bigger ratio than normal. I think this test ran a bit too slowly. Normally, though, this is about 3.5 times slower than the second benchmark. Why is it 3.5 times slower when it's only doing twice as much work? That's peculiar. Well, let's look at the memory characteristics. So in terms of allocated memory, it managed to allocate a little bit under half. The main reason for that is that with this first one, it's trying to return me the entire array in one go. And to do that, it's actually building up a list object. And it doesn't know how many elements it needs to start with. So it just guesses how many elements might fit. And every time we run out of space in a list of T, it just allocates a new buffer that's twice the size. So it ends up sort of throwing away all the too small buffers it created on the way. So actually it's a bit wasteful. So it's going to allocate more than twice as much memory as the more efficient version. So that's why that's a higher number. But look at the garbage collect generations. So we've got well under half the number of Gen 1, but Gen 0. But the Gen 1 and Gen 2 are way lower. There's only 15 as opposed to, 1,200 Gen 1s, and there are no Gen 2s here. Now, that's really significant. That's the main reason that this second benchmark actually runs so much faster. I mean, yes, it's doing half as much work, but it's going, in this case, almost 5 times faster, but usually over 3 times faster, despite only doing half the work. And it's because it's not clobbering the garbage collector. This first one is way slower than it ought to be because it's spending so much time in the GC. So let's look at why that is. So going back to the first benchmark, and this will all be relevant when we get to the system text JSON stuff. Going back to the first benchmark, we're saying, I want you to return me the entire array in one go. So what's going to happen as this starts to do its work? This deserialized object is going to start churning through the string we've given it, gradually creating objects. Eventually, it's going to create 10,000 of these things. And actually, we worked out there's about 8 sub-objects per thing. It's going to create about 80,000 objects. And the garbage collector is going to go, you seem to be creating lots and lots and lots and lots of objects. Maybe it's time for a garbage collect. Maybe we can get some of that back. And so it halts the thread, looks at what you're doing, and discovers that it can't really free anything much because this deserialized object's going to have to hold on to everything until it's ready to return it to you, because we've said, I want all the data in one great big lump. And so the garbage collector goes, oh, well, you've created thousands of these objects, but they're all reachable because you're not done with them yet. It's not going to be able to garbage collect anything until we get to about here. That's the first point where we're not holding on to all the objects anymore. So this inherently can't free up memory, but the garbage collector doesn't know that until it tries. So it's desperately going, oh, you've allocated so much, I'm going to try again. Oh, that didn't work. Maybe a Gen 1 will help. That hasn't helped either. Maybe a Gen 2 will help. Oh, that hasn't helped either. And it just doesn't realize that we're just building objects that are going to live for a relatively long time. So that's not good, and that's causing the GC to behave inefficiently. Whereas this second one, which deserializes the objects one at a time, so there's no array brackets on this one. We're saying just the current object, please, just that, deserialize that, and then we take a look at it and go, was that the one? If it was, we're done. If it wasn't, well, we just move on. And this object here being returned here is no longer reachable. So if the garbage collector does run, it will be able to recover that memory. So this usage pattern is much better suited to the way the garbage collector expects things to run. You will allocate objects and then almost immediately cause them to be unreachable. And the GC is really good at that. It copes very well with very short-lived objects, which is why this thing goes over 3 times faster, even though it's only doing half the work. We get a bigger boost from the GC efficiencies than we got from simply doing less work. Okay, so that's some analysis of Newtonsoft JSON. So now let's take a look at how things look in .NET today. What would you use for JSON deserialization in a modern .NET app that's targeting .NET 7 or .NET 8 or whatever? You would almost certainly use system text JSON. So this is built into the .NET runtime libraries. So it's right there. You don't need to add any extra dependencies to get hold of it. You don't need to worry about whether you're depending on a different version from someone else. It's going to be serviced as part of the runtime, so you don't need to worry about security issues being discovered with NuGet packages and all that kind of stuff. It simplifies your deployments. But it has some advantages in its design. Biggest one being that it works directly, natively, with UTF-8. So this does not need data to be converted from UTF-8 format into UTF-16 before it can start to work with it. So it doesn't use the .NET native string type internally as it works. But that's not the only thing. It offers a wider range of trade-offs between performance and convenience. So we saw with Newtonsoft that we could either just deserialize everything in one go, or we could use the streaming API to process things one item at a time, and then we could fall back to serialization for each individual thing. Or if you want to, in Newtonsoft, you can go streaming all the way, but that actually makes code a lot more complicated. Now, those are both options with system.text.json as well, but it also offers a couple of other flavors of using JSON that offer different trade-offs, different places on that trade-off between complexity and performance. So, for example, there's an API known as JSON Element. It's a pair of APIs really, JSON Document and JSON Element. And this offers a read-only view over some JSON data. It's basically an object model, except technically they're structs, but it's like an object model. You can't modify JSON with it. You can only look at an existing JSON document with it. But its superpower is that it's very low allocation. It does not allocate very much memory at all when it's working with JSON data. There is also another object model which is modifiable. So the downside of the ultra high performance read-only one is you can't actually generate a new document with it. You can't build up a description of a new document. You can't load a document into memory and then edit it and then write out the edited version. That's not available with JSON Element, but it is available with this other modifiable model, which is not as efficient. It can't be as efficient as the read-only one because being able to support modification comes at a cost. So it's not free, but it's still pretty efficient. And it also, as I say, supports serialization and streaming, just like Newtonsoft does as well. So you've got those benefits, and also it's possible to get system.text.json to do compile time code generation to drive its serialization engine instead of using reflection. It will use reflection by default, but you can make it not use reflection, and that improves performance in certain ways that I'll discuss when we get to that. So these are the differences. Now let's start to look into that. So let's take a look at our benchmark. So this is the Newtonsoft one. If we scroll down a bit, the next one here, find whole array, system.text.json deserialize. This is basically exactly the same idea as our first benchmark. If I quickly scroll back up to the first Newtonsoft one, what did we do? Well, we loaded in the entire UTF data, parsed the whole thing, deserialized it as a person serializable array, and then used link to objects to find the object of interest. And this third benchmark here does precisely the same thing. We are deserializing all of the JSON into a person serializable array, and then we're using link to objects to find the item we wanted. The only difference is we're now using system.text.json JSON serializer to do our deserialization. Notice we can pass the UTF-8 data in directly. There is no need to do any sort of conversion before we do this. Otherwise, literally the same code. So the actual thing that's processing the results is identical to the previous version. So let's see how that compares for performance purposes. So we're now looking at this third benchmark. Again, usually that's a lower number when I run this, but it's in with the same ballpark. So the main thing is it's a fair bit faster than this. Normally, I'd expect this to be about 23, whereas this would normally be about 34 every other time I've run it today. So for some reason, these two have gone a bit slower today. Don't know why, they just have. Probably because I'm sharing my screen. But look at the memory usage. The the Newtonsoft JSON one took about over 22.5 megabytes, whereas the system.text.json 4.86 megabytes, a lot less. And a big chunk of that is down to the fact that it hasn't had to convert it into a UTF-16 representation. It's been able to just use the UTF-8 data exactly as it is, and hasn't had to kind of convert to .NET strings before it even begins to parse the JSON. Now, it is still having to do some of that conversion because we've asked it to deserialize this into objects. Some of those objects have string properties. And so the values of all of those properties are going to have to be UTF-8 strings because they're .NET strings. However, most of the JSON data isn't actually string values. Most of it's like structural or it's property names or stuff like that. So the amount of data that it's had to do that for is much smaller, and the memory footprint is correspondingly a lot lower. And this is reflected in the garbage collection costs. So whereas the Newtonsoft one caused over 2,800 garbage collects in Gen 0 alone, our system.txt.json version of the same thing was just 687.5 on average. The Gen 1 is similarly lower, so 1,272 versus 625, so that's about half. The Gen 2s are also lower. Now, it's still not ideal. You don't really want any Gen 2s if you can help it. You don't want that many Gen 1s, but it's certainly better than this, and that accounts for a significant chunk of the performance improvement. Now, what you will have noticed is that this first attempt at system.txt.json is actually quite a lot slower than our second attempt at Newtonsoft JSON. So what this illustrates is that upgrading to a faster library probably isn't going to save you from bad performance decisions, because the fundamental problem with this first one also exists in this second one, which is we're asking to deserialize all 10,000 objects before we even look at them. And that causes two problems. It means, first of all, these end up deserializing 5,000 objects they never even look at, because the object we're looking for is about halfway through the data. So that's a waste of effort. But also the fact that we're asking these two things to both return us one massive array with everything in it all at once is responsible for this garbage collection pattern, the fact we're seeing lots of Gen 2 collects. So simply upgrading to system.txt.json isn't going to save you from yourself. If you were making certain kinds of mistakes before and you carry on making those same kind of mistakes today, you'll have the same kind of problems. I mean, I'm calling them a mistake. Maybe it doesn't matter. If you are not in performance critical code, then, you know, who cares? It's fine. But this is a talk about high performance JSON processing. So presumably you do care about the perf, and this is not a good look. So it's definitely significantly faster than the direct equivalent in Newtonsoft. It's definitely a lot lower memory consumption than either of the JSON ones. Even the efficient JSON ones still took nearly twice as much memory as our inefficient system.txt.json one. And that's interesting, actually. The fact that we're allocating less memory could mean that the difference between these two in this simple test, that would actually look a lot closer in the context of a real application, just because the amount of allocation you do has a system-wide impact. But let's look at this other one. Per element system.txt.json deserialized. So that's obviously better, although you'll notice it's still worse than the Newtonsoft one. I'll explain why. Let's look at the code. So this is the second of the system.txt.json ones. And this one, it's kind of similar to the second Newtonsoft one. So the Newtonsoft one, we basically blast through the array one object at a time and deserialize them, and then we stop as soon as we find the one we're interested in. That is kind of what's happening in this new one. So we're sort of looping through all the elements in the document, deserializing them one at a time and stopping when we find the one we're interested in. So it's pretty similar. It's not quite the same, though. We're not using the streaming API here. We are just using the we're going one element at a time through this JSON elements API. And this comes from JSON document. And you'll notice that we begin by saying JSON document.parse all of the UTF-8. So we are actually, logically speaking, saying, please read the whole document in. Now, it doesn't deserialize the whole thing, but when you load data into one of these things, it does actually do a certain amount of processing. It essentially builds up a little kind of index in memory to keep track of where everything is in the document, so that all subsequent operations, everything you do with the JSON in that document, will then go faster as a result. But it does mean in situations like this where we don't even look at half the JSON, this is actually doing a bit more work than it really needs to. That explains, that's part of the reason why this one is not as fast as our best Newtonsoft JSON effort. But don't worry, we will get much faster than that. So what is this doing? We're saying, I'd like to read the whole thing in as a JSON document. I'd then like to retrieve the root element, and I believe that's an array. So I'd like to iterate over all the elements in that JSON array. This will throw an exception if I turn out to be wrong about that, by the way. If I'm mistaken and it's actually just a string or an object at the root, that just won't work. But it is in this case, that's fine. And then for each element in the array, then we're going back to deserializing. So we're deserializing one at a time and failing as before. So that's the code. Now let's go back and look at the benchmark results again. So I believe the reason it's actually a teeny bit slower than the Newtonsoft version is because of that initial document parse where it does look at the whole document. So this is at a slight disadvantage. However, it's using a lot less memory, only using 4.6 megabytes as opposed to the 9.3 that is being used by Newton, our best Newtonsoft effort. And the garbage collection counts are much better. Not only is it the lowest Gen 0 count we've seen so far, only 546 and a bit per test iteration, so about half what the best Newtonsoft effort was able to achieve, but also no Gen 1 or Gen 2 collections. And that matters more. So you might find that even though these two benchmarks look fairly closely matched, the fact that this one is making the garbage collector work much less hard might mean that on average your application performance goes better because the garbage collector is not having to step in and sort of freeze threads as often as it has to. It's not having to move data around as often as it otherwise would do. So the collateral damage that this one does by allocating twice as much memory might actually have a larger impact on your overall app performance than is visible through these kind of micro benchmark measurements. However, you're obviously looking at these two down here. Why am I talking about these slow ones up here when there are clearly some better ones available down here? Okay, let's talk about this next one. And I'll get to that in a second because that's not as simple as it looks. So this next one, that's a clear winner, you know, so that's saying 4. Again, these numbers are different from what I've seen every time I've run this test recently. Normally, I've seen that come out at about 3.5. So it's about 10 times faster normally than this one here. Yeah, not far off, 4 milliseconds and 50. So order of magnitude faster, even with these slightly wonky test results I'm getting today. And, you know, 3-ish times faster than this version. But wow, look at the memory. 222 bytes. Just to remind you what this test is doing. This test is looking through 10,000 JSON objects in an array, and it's allocated 222 bytes of memory to do that. That's not per object. That's 222 bytes to process the entire JSON document. So less than 1 byte per object on average. That's clever. We'll talk about how it does that in a moment, but let's look at the code first. So it's this next one, find system text JSON element. That's not a typo. So this benchmark is for system.text.json, and we're looking at direct use of JSON element. Now it starts off the same way as the preceding test. So we basically load the whole thing into a JSON document, and we go looking at the root element like we did last time, and we're still using the enumerate array as before. But now I'm actually using link to objects again. I'm just using the first operator to find the first thing that matches my criteria. But the big difference here is I'm not deserializing individual objects. I still want to do the same thing. I want to look at the name.given name property and see if it's equal to that, but I'm not going to do that through deserialization. This time, I am going to use the JSON element types methods. It offers a try get property method, which says, does this thing, is this an object, and does it have a property of type name? If it does, please return true and put that property, so the name value pair, the whole property name value pair, in a new JSON element here. And then if that worked, we're going to look at that new JSON element that holds that name property value pair and say, well, is your value an object, and does it have a given name? And if so, sorry, I misspoke. These are not pulling out the key value pairs. These are pulling out the values. Sorry, there's a separate way to get the property without the value. So yes, sorry. This first one gets the value of the name property if it's there. The second one then drills into that to get the nested given name. So we're doing name.given name, but we're just doing it without using serialization. We're just saying, well, I just want to go looking for these properties by name. And if that succeeds, then we say, well, okay, I'm expecting this to be a string. Is it equal to this value here? Now, this one's a little more subtle. Up here, I'm using serialization. So I'm saying, please just take the JSON and turn it into a .NET object. And then I'm just retrieving the given name property and using ordinary string comparison to say, is this the one that I'm looking for? For this to work, that given name property has to contain a string. It has to have a .NET string in it. So I'm forcing this deserialize method to create a .NET string object for every single given name property of every JSON object that's in that thing there. So it's going to have to allocate 10,000 strings in order for this code to work. But here, I never actually asked for the property value by name. I'm saying, give me the JSON elements that represents that property value, but I'm not going to ask you to turn that into a string. I'm saying, can you just tell me whether it is equal to this other string over here? Why does that matter? It matters because this does not need to allocate anything on the .NET garbage collected heap. That's a string constant. It's going to be interned. There's going to be exactly one allocation of that string across the entire lifetime of the process. So, you know, that's essentially free once you're up and running. And this thing doesn't convert the underlying JSON data to a string. Instead, character by character, it looks at the JSON data and just says, is the stuff in the JSON the same characters as this string I've got here? Never allocates a .NET string. It just compares an existing string I've passed in with the raw UTF-8 data. Now, it is having to do some conversion there. It is actually having to convert from this .NET string format into UTF-8. We could actually avoid that, by the way. You can stick this on the end of a string in recent versions of C#, and that will then actually end up passing this as a byte array of UTF-8 data, which will go a little bit faster. But actually, for the purposes of this discussion, that's not the most important thing. The most important thing is that this code doesn't allocate anything except for the iterator that is required by link to objects to do this first thing. Each of these JSON elements is a struct, so they don't need to live on the heap. And the way I've called it here, they're all going to end up being hidden local variables. They're all essentially going to live on the stack frame. So there's no heap allocations done in this code other than the one for link to object, which is why our allocation is just a couple of hundred bytes for the whole thing. That's basically link is consuming that. And it's not nothing, but it's very little compared to the others. 220 bytes as opposed to several megabytes is a big step forward. That's a large part of why this goes so fast. So you can see it allocated so little that the garbage collector never felt the need to step in and do anything. Phenomenally efficient. And we were parsing 10,000, well, 5,000 records really, because we skipped the second half. Really, we're not fully parsing all of them. So we're looking at 5,000 records in a millisecond. So that's less than 1 microsecond per JSON object. Now, I find that phenomenal. I find it mind-boggling that it's possible to do meaningful processing of a JSON object in under a microsecond. When I first started using computers in the 1980s, you couldn't execute a single machine language instruction in a microsecond. You know, it took several clock cycles on CPUs that had clock speeds measured in megahertz to do anything at all. And so the idea that you can interrogate the structure of a JSON object and compare one of its values with something in less time than it takes to execute one instruction on a computer in the 1980s blows my mind. I mean, that's Moore's law for you, admittedly. Well, actually, technically not Moore's law. It's the other law. The computer's getting faster and faster, which is not the same thing. But I digress. Anyway, it's very, very, very fast. It's certainly a lot faster than our first attempt. It's an order of magnitude faster. And the memory efficiency is pretty good. However, obviously, all of you are going, why isn't he talking about this one? This one's obviously even better. So maybe this is the one you want, because that is way faster. 50 bytes, look at that. That's almost nothing at all. 50 bytes to process 10,000 rows of JSON. This has got to be the one, right? Let's take a look at this. How much do you want this method? Here it is. Here's a bit more of it. Do you still want it? How about now? Still a fan? Nearly there. And rest. Okay. That was kind of complicated. This is using the streaming API in system.text.json. So we are using a UTF-8 JSON reader, which is this thing here. It's really, really fast. And this is what underpins everything else, by the way. Anything you do with system text JSON to read JSON ultimately relies on this thing at some level. They're all just wrapping it to various extents. So this is the basis of everything. And a bit like the earlier example, we just repeatedly call read, saying, please move to the next item, and we check that it starts with an array. But this has got a lot more complicated because we're not then falling back to serialization once we get to the individual objects. We're doing the whole thing streaming wise. And the big problem with that is you have no idea what order the data will show up in. It's going to be valid JSON, but the properties won't necessarily be in any particular order because JSON doesn't require ordering. Basically, you're not allowed to say, oh, you've got to put your properties in a certain order, otherwise I won't talk to you. That's not really permissible in the JSON world. So we have to be ready for things to happen in any order. And it gets a bit weird and complicated because we've got nested objects. We have to remember, were we in the middle of the nested name type, or are we still in the outer object, or are we actually up in the array waiting for the first object to appear? So we have to keep track of how deep we are in the JSON right now. What have we already seen so far for this iteration? Did we already work out that this is not the one we're looking for, but we haven't got far enough through the JSON to be able to skip to the next object yet because we're still embedded several layers deep? It all gets really complicated. You basically end up having to build a little miniature state machine just to keep track of everything that's going on. And the huge problem with this is it's not at all obvious what the code is doing. Yeah, there's no obvious relationship between the structure of this code and the actual goal. Yeah, so somewhere buried in here, is it here? No, it's not here. Somewhere, I can't even find it now. There it is. That's the actual line that matters. It's that thing there. But to get to that line was, sorry, no, it's not even that. I've got it wrong twice now. There it is. Sorry, R for 5,000. That's what we're looking for. So this is the actual logic, and everything else is just complexity mandated by the fact that this is a streaming API and we are in no control over the order in which we see things. So for this reason, people often decide that actually the performance boost you get from this thing just isn't worth it. It might be. That's a business decision. You know, it depends on how much your performance is worth it to you. Is it worth the extra development overhead it takes to create that in the first place and the extra maintenance overhead involved in having an almost completely unreadable bit of code that's going to be a nightmare to maintain? Are those costs justified by the performance improvements? Now, if you are processing trillions of records of JSON, those performance improvements could well translate directly into lower cloud computing costs, at which point the answer may be yes, this pays for itself 100 times over. Of course, we're going to do it this way. If that's not what you're doing, it might be that the much easier development path of doing it this way means that this is the preferred one, because this JSON element thing gets you most of the way there. It's more complicated than the serialization approach up here, but it's not much more complicated. So maybe this is the way. Maybe, foreshadowing of what's coming later in the talk, maybe there's a better alternative. However, for the time being, that's enough of this demo. I'm going to go back to my slides and talk in a bit more detail about how it is that the JSON element is able to achieve this remarkable performance. So just remember what we've seen. It was able to process 10,000 rows of JSON, apparently not having to allocate any data on a per object basis, which is like 222 bytes up front, and that was it. No more allocations. How can that work? Well, there is a basic principle in operation here, which is that JSON element never makes copies of data. We don't copy data, we just point to some data that was already there. So the basic observation that JSON element is making is this. You've already got all the data that constitutes your JSON document right there. It's that big blob of UTF-8 data. It's all there. We don't need to store it somewhere else because it's all there in the source document. So we don't need to copy the property names out into .NET string. We don't need to copy the property values out into other objects. They're all right there. So when you ask the JSON document for the root element, what does it give you? It gives you a JSON element that says, I represent this range of text in the JSON. all of it in this case, because it's the root element. I represent everything from that opening brace to the closing brace, or in the example for my benchmarks, everything from the opening square bracket to the closing square bracket. So this says I'm all this data here, and it knows that it's a JSON object. If you ask this to give you the name property, it will return you another JSON element that represents just that section of the JSON that is the property. So in this case, I've called get property. This does return the name value pair. So this gives me the both pieces, name quote name quote, that's the property name, and everything after the colon, that's the property value. And then if we ask this thing for its value, we get another JSON element, which is just the bit after the colon. This is an object. If we ask this for the given name property, it's going to give us just that slice. And if we ask that for just its property, it's going to give us just that piece there. Every single one of these things is pointing to the same lump of data. It's all pointing to the same UTF-8 array. It's just pointing to different subsets of it. It's just saying, I'm just this piece here. I'm character, 47 to 95, or whatever it might be. They're all just referring to the one and only copy of the underlying data. And they're all struct types. They're all value types, which means it is possible to use them in a way that they never have to live on the heap. It's not true that structs always live on the stack. That's a popular misconception, but it's possible to use them in a way that doesn't cause any heap allocations. So that is what enables these to go so fast. They don't ever make copies of the data. Okay, so let's now talk about the other performance-oriented feature of the systemtext.json offers that you don't get in Newtonsoft JSON. And this is to do with the reflection. So by default, the reflection mechanisms in both Newtonsoft JSON and systemtext.json, they both do the same thing. They both use reflection to discover what properties your .NET types have. So when I said, please deserialize this JSON array into an array of person serializable objects, it would have gone, okay, what does a person serializable look like? Oh, it's an object with two properties, name and date of birth. What does name look like? Oh, that's another .NET type. That's an object called person name serializable. It's got three more properties and so on. It uses reflection to discover the structure of my .NET object, and that's what drives the behavior of the reflection engine. This is very convenient. We can just write a .NET type whose structure reflects the structure we expect in our JSON, and it just works. That's great. However, there are some problems with this. Reflection has a bad reputation for speed, which is partially deserved. It's actually not as slow as a lot of people think. I mean, it's definitely slow. It's definitely a lot slower to read and write through reflection than it is to just use normal property access, because normal property accesses can, run in nanoseconds, whereas serialization probably tens, maybe hundreds of nanoseconds, maybe even as much as a microsecond. They're not that slow. Yeah, it's not like it's going to take the blink of an eye to do it. Nothing as slow as that. But it's definitely slower. But actually, that's not the real problem often with reflection. It can be, but often it's not. Often the real killer with reflection is how much it costs the first time you use it. It doesn't always matter, because clever reflection-based things can use reflection to work out what's going on and may actually do runtime code generation to avoid the recurring overheads. They're just using reflection to work out what to do and then use code gen to actually do it. That can amortize the costs, but the startup costs for that can be horrible, because it's having to discover everything about the structure of your data types at runtime and then generate code and then get that compiled. And this can all take quite a long time. If you're processing 1 trillion records, you probably don't care about that, because the first time cost is sort of dwarfed by the overall cost of the total job. If, however, you're writing a desktop application or a phone application, the first time costs really matter, because that's when you make your first impression with users. If the first time the user clicks on a button, it takes 2 seconds before it responds, that's the thing they're going to remember. They're not going to remember that the next 10 times they clicked on that button that it was nice and fast. They're going to remember that the first time it was horribly slow, particularly if that's true every single morning that they launch the application. And it's not just desktop applications or phone applications. This can also be a problem in the cloud, because a lot of people run stuff up in cloud platforms in a way where you don't pay when you're not using things. So things like AWS Lambda or Azure Functions, there are billing models where they say, if you're not handling requests, we're not going to charge you any money, which is great. But obviously, they're not going to have hardware on standby for your benefit if you're not paying. So the downside of this is if you have one of these models and your app is idle for 4 hours, it's not going to be running. And so when the next request comes in, they're going to have to quickly find a VM to host you on, or a container or whatever, fire it up, start the .NET runtime, load your application, hit your application's entry point, and get your app to the point where it's able to respond to a request, invoke the request handler, and get a response. All that has to happen, and that can be quite slow because the first time things happen are often much, much slower than everything else. And reflection is particularly bad for that. Reflection is horrible on first use characteristics. So if that's the kind of deployment model you've got, then not using reflection has its benefits. So first use performance, so cold start performance, it's a big deal. There's also a memory overhead, typically a few megabytes, not huge, but not nothing. Also, if you're using ahead of time compilation, if you're doing like native AOT compilation, you're likely going to be trimming your binaries to only include the code that you're actually using. And anything that uses reflection makes that a lot harder to get right. So avoiding reflection entirely has some benefits for those deployment models as well. And also there's a separate related feature which can generate high performance output serialization, which is sort of orthogonal to all of this. But anyway, let's take a look at how this works. So the way they're able to avoid using reflection is through the use of C# source generators. Now, this is a feature of the .NET build chain that enables libraries to kind of inject code at compile time. So libraries, there could be NuGet packages, or they might be libraries built into the .NET SDK, usually a bit of both. They're things that get involved in the build process, and they're able to generate code at build time that gets compiled into your application and can then execute at runtime. So if you're using source generators, the build process looks like this. The C# compiler is started. It loads all the files it's been given, all the files your project says to load. And it tries to process them all, looks for syntax errors, then starts to do semantic analysis to work out what it is you mean by string. Oh, it's system.string, and basically resolving all the symbols. But once it's looked at everything, it doesn't necessarily worry if it doesn't have a complete picture, because it says, okay, I've done as much as I can, but are there any generators registered in the build? Are there any source generators that would like to have a go? And there's actually a couple built in to the .NET SDK, one of which is for JSON serialization purposes. And what these things do is they get access to all of the analysis the C# compiler has done so far. So everything the compiler has done to try and understand the source code is available to these things. They can look at the code and go, I might add some more. I might add some extra source files into the mix. And whatever comes out of your source generator, the compiler will then incorporate those into the build processes. Oh, there's some more files. Great, let's keep going. And only once it's looked at all of these does it consider compilation to be complete. So this gives source generators the ability to fill in gaps that were there after stage one. So let's look at how this works with JSON. If you want to use the system text JSON features for avoiding reflection, but you still want to use serialization, here's what you do. You write a type that derives from JSON serializer context, and then for each type that you wish to serialize or deserialize, you apply an attribute to that class of type JSON serializable. And this can generate two kinds of code. It can generate property descriptors, which basically contain all of the information that it would otherwise have got from reflection. And it can also optionally generate a high-performance serializer. So let's take a look at this rather than describing it. It's easier to see in practice. So I have up here a class called test serialization context. I'm just going to quickly uncomment something in the code here because I have that compiled out by default. Let me go back here now. So as I just said, you need to derive from JSON serializer context. That's defined by the system text JSON libraries. And then for each type that you want to use in serialization and you don't want the reflection overheads, you add one of these attributes. So I've said I need to be able to deserialize and or serialize person seriables. I also want that to work for arrays of person serializable. And I've also had to include this person name serializable, which remember is my nested object. So my name property is actually one of these person name serializable. So I've had to include that in the list as well. So what has this done? If I come over to my benchmark and look for a particular piece of code, right, here we are. So here's a benchmark. Wasn't running earlier because it was hash if def out. And it is using JSON serializer. This one's actually serializing things. It's writing stuff out rather than reading them in. So this isn't directly comparable with the earlier benchmarks, which is one reason I wasn't showing them earlier. And it's saying I would like to write data into this memory stream. And the data I'd like to serialize is this .people. This is the same 10,000 elements that we were also reading in earlier. So my benchmark base class just sets up both the UTF-8 data and also the equivalent .NET representation. So this is going to go from the .NET rep out to UTF-8 data. But notice, we're passing in context.person serializable array. So what's that? Well, context is my test serialization context class. And we're using the person serializable array property. Well, I don't see a person serializable array property in there. It looks pretty empty to me. However, I've annotated it with partial. That tells the compiler this might not be everything. It says there might be other source files around that are going to contribute more stuff to this class. And that is what enables the source generator to add members to this class. So for every JSON serializable attribute I apply, it's going to, in a different source file, add members to this. So if I go back to the benchmark that uses this and say, well, show me this person serializable array property, I'm going to hit F12 to go to the definition. This thing here opens. So this tab, you may or may not be able to read that. It says this file is also generated by the generator system.text.json.source generation.json source generator and cannot be edited. So it's telling me this is generated code actually being generated as part of the build process. And so this is extending my test serialization context class. It's adding in extra members, including this person serializable array thing that my benchmark was using. So I'm not going to go into huge amounts of detail on this, but if we dig into this a little bit, we will find, where is it? I'm probably in the wrong file here. Yeah, hold on a second. There's more than one generated file. I don't want person serializable. I actually want, sorry, I want person serializable, not person serializable array, because person serializable is going to be more interesting. Let's go and look at that one. Right, so this one is for not the array type, but the actual type itself. And this here is what I was interested in. So this is basically everything you could have discovered from reflection, saying this is a property, it's public, it's not virtual, it's declared by this type here, it doesn't have a type converter, here are its getter and setter, and so on. This is all the stuff that the property info type in reflection would have told you. But this is a dead simple object. This has got very little in it. It's going to take almost no time at all for this thing to be constructed compared to the milliseconds it will take for the reflection engine to get itself up and running after you start the process. So this gives all the information that it would otherwise have got from reflection in a tiny fraction of the time. And that is the key benefit that this offers. It enables us to get all the information really, really quickly. Now, it's actually quite hard to benchmark this because it mainly affects first-time usage, because once reflection is up and running, it's actually relatively fast. So I'm not actually going to show you a benchmark for this. It's kind of better to demonstrate it by deploying stuff up into the cloud and timing your cold start request times, but that takes about 4 hours to measure properly. So I can't really do that right now, but it does make a difference. It does tend to make multiple milliseconds of difference. Exactly how much depends on how complicated your object models are, but it's definitely a significant improvement for cold start time. Okay, so the other thing can I find it in here? Ah, yes. The other, this one here. The other feature I mentioned is the ability to write data out, a very fast generated serializer. So the other thing you get with this code generator is a method for each serializable type that uses UTF-8 JSON writer, which is the write mode streaming API, to enable you to write the data out. And this just basically generates the simplest, fastest possible code that writes data out. So this is also going to be way, way, way faster than trying to use reflection. Streaming is much easier when you're writing than when you're reading, because you get to control the order here. So that's the other thing this will do. Okay, so I'm going to quickly undo the change I just made there, because I don't want to break this from compiling, and then I'm going to go back to the slides. Okay, so the basic heart of this is that all that code gen creates or makes available instances of a thing called JSON type info of T, where T is your chosen serializable type, person name info, person serializable, whatever it might be. And this basically, it only has one public member. It's almost empty from an API perspective. The one public member points to that high-speed serializer. It's a delegate that points to the serializer. Everything else is internal, but it gives the JSON system.text.json serializer all of the information it needs so that it doesn't have to go talk to reflection at runtime. Okay, so that's pretty much it for what's built in to system.text.json. But I want to show you another step we can take. We can do better, because what I've shown you so far is either you can deserialize things in the most straightforward way possible, but you often end up with a lot of overheads because you end up creating more objects than you might actually need, and you might operate in a way that's quite inefficient for the garbage collector, or you can start to go a little bit out of your way to get slightly improved performance, or a long way out of your way to get very fast performance. But what if there were a way that we could give a programming model that looked very similar to serialization, but without the problems? Just to remind you what the problems are, no matter which library you're using, there's a fundamental issue with trying to represent JSON data as .NET objects. In fact, there's two fundamental problems, one of which is the .NET type system isn't really a very good match for JSON. You look at what people actually do with JSON, particularly if they're TypeScript programmers, they'll often say, okay, this thing might be one of these, or it might be one of those. It can be two different things, and we'll decide at runtime which it is. That's not really a thing the .NET type system is particularly good at dealing with. It doesn't do some types yet. So that can be an issue. But even if you constrain yourself to JSON that's easy to represent in .NET, we've still got this big problem of allocations. If you've got a hierarchy of data like this example I've been using throughout, you've got a bunch of objects to allocate just to represent one record. And strings are a problem in particular, because the moment you force system.text.json to give you a .NET string, you're throwing away the advantage that you would have got from its ability to work with UTF-8 data naturally, because you're saying, I want this as a .NET string, so it's going to have to turn it into UTF-8. It's going to have to UTF-16. It's going to have to make a copy. So this is fundamentally unavoidable with this model of serialization. Maybe we're thinking about serialization all wrong, though. Could we do something else? Do we have to make our JSON data into an ordinary looking .NET types? Could we do something else? Could we maybe generate .NET types that are harder to write, but it doesn't matter because a code generator is going to write them for us, which do a bit more work and work a bit more like the JSON element API? Maybe rather than making copies of data and turning it into .NET stuff, what if they were just a facade around the underlying UTF-8 data? So what we could do is basically have a thing that looks like JSON elements, only it's sort of strongly typed. It knows about the structure of the data that we actually expect. What would that look like? Well, to whet your appetite, here's an idea of how that might perform. So these are the same benchmarks I've been running throughout. the benchmarks get slower and slower as I run more of them, which is why I'm not running this one live. You'll notice the numbers are now more like I expect, 35 milliseconds for the just first JSON one. But look down the bottom. The last three are benchmarks that are going to use the new technique I'm talking about. And notice these are all around the sort of about 4 milliseconds to process the records. And if you look in the memory allocation side, they all have this ultra low allocation characteristic. And yet they have a programming model that's very similar to serialization. That sounds intriguing. Let's actually see what that would look like. So I'm going to go into my code. I'm going to comment out that thing and take a look. So here is how it could look. So we start off with JSON document, as we did with all the other JSON element-based examples. So you've got to first of all load stuff into a JSON document, and that then lets you do this very hyper-efficient read-only JSON element-based API over the top of that. So we can get the root elements. That comes back as a JSON element. So one of these very efficient things. But then I've wrapped it in this type here. So I've got a static class called gen from, sorry, a namespace called gen from JSON schema dot person array from JSON. It's going to give me this thing here, which is also a struct. This is kind of like a JSON element, but it knows more about what's going to be in there. So this offers an enumerate array, just like JSON element does. But if I mouse over the lambda argument here, notice that the argument to the lambda is not just any old JSON element. It's actually passing me a person. So this array enumerator knows that this is not any old array. This is a person array, and each of the elements in it is a person. And these are still all structs, and these are still basically wrappers around JSON elements. So these are all very low allocations. So I'm able to enumerate the entire array and use link to objects over this to find the thing I want. Now, here's the really interesting thing about this. This uses the same basic structure as the very first benchmark I showed you. This not very clever one up here that reads the entire object, the entire JSON in as one big array, and then uses link to objects over it. If I come back to this latest example, it's basically doing the same thing, saying load the JSON, get the whole thing in as one big person array, and then use link to objects over that to get the results. But look at the results in the benchmark. And I promise you these are real. If I had time to run them, you'd see the same results. That's that third up from the bottom. Find whole array, link schema, gen, deserialize. It's almost 10 times faster than the first one. It doesn't have those garbage collection problems that the other ones did. And we can do the kind of per element stuff, but actually there's much less benefit to doing that now. It turns out that with these wrappers, we can do the stupid thing and magically it goes faster. How on earth is that working? Well, let's talk about that. So the way this works is that these generated types I'm showing you, and I'll show you the website that offers the tool to build these in a moment. These generated types look on the face of it like normal .NET objects. Let me just quickly go back and show you the benchmark again, because I kind of went over that quite quickly. These benchmarks are able to do thing.name.givenName, like it was an ordinary deserialized object. They're able to do this, but we don't see those memory allocation, those bad memory allocation characteristics. This whole thing ran with very low total memory allocation. If I just back up, 350 bytes, most of which was Link's fault. So this is working because these things are just facades over the data, and exactly the same with the JSON element is. They're not really deserializing anything. They're just sort of things saying, I'm these range of characters from here to here. I'm this range of characters from here to here. It's exactly the same sort of picture you saw earlier, but we've just stuck an extra layer on top of the JSON elements. These things are just wrappers for JSON elements that annotate them with properties that give you a way of accessing those underlying things. And I'll quickly, I'm getting close to the end, but I'll quickly show you one example of that. So if I go looking at this name property, It's on this generated code, so it's a little bit of a mess. But this thing says, okay, well, actually, you can run in one of two modes. These are actually writable things. You can either build a person by parsing some JSON, or you can actually build one up from scratch. The first thing it does, it says, am I made out of JSON, or am I actually made out of values? And it has two completely different code paths. If it says I'm made out of JSON, I'm actually just a wrapper for a JSON element. It first of all says, well, is this the right kind of storage? Is this actually an object under here, or have you got the wrong sort of thing entirely? But if it is the right sort of thing, then it calls that same method our earlier benchmark did, try get property. It's saying, okay, it's calling JSON element.try get property for the name it's expecting. So that is actually basically the property name. It's represented as a span, but it's basically the property name. And if that works, then that will get a JSON element out, and it will wrap that in another generated type, person name. So these things are all basically just wrappers around JSON elements. It's kind of complicated because it's generated code, but fundamentally, it's just this picture here. It's a generated layer sitting on top of the thing that you already saw earlier. The generation, by the way, is driven by JSON schema. That's how we know what to generate. So this only works for schematized data. But by the way, it supports validation. So if you do a JSON schema, not only can we generate the wrappers for it, it'll also generate the code to validate that your JSON data is actually conforming to the schema. So you can be confident that it looks exactly like it should do. So there we are. I just showed you that. So in conclusion, systemtext.json can do serialization just like Newtonsoft JSON.NET, but it's just faster out the box. If you do like for like code, it will be faster, mainly because it doesn't have to do any UTF-8 to UTF-16 conversion, but also generally within the code base, they've paid a lot more attention to avoiding unnecessary allocations. But if you're prepared to use the new JSON element API, I say new, it's been here since .NET 5, the newish JSON element API directly, then this gives you an API that gives you very, very low allocation parsing and extremely high performance. You can go faster still. UTF-JSON Reader and UTF-8 JSON Writer give you ultra high performance, very low level access to the structure of the JSON. But that's the way to get the fastest performance. Can potentially go twice as fast again, but it's really hard work. There's built-in code generation for the avoiding the use of reflection during serialization. And it's also possible to use a tactic of code generation to boost performance further without throwing away the benefits of serialization-like behavior. I'm just going to quickly show you the website that's on. So Corvus.net is an open source library maintained by my employer's engine. This is all free to use. You'll see the license when I go to the thing. So Corvus JSON schema is under the Apache 2 license, which is pretty permissive. And the instructions here will tell you how to use the tool that generates all those types that I showed you. So if you would like to use this, it's available. It's up there on GitHub. Please have fun. But in any case, everything else I applied is built into .NET itself. So that is how we do high performance JSON processing in .NET. Thank you for listening.
Oh, there we go. Oh, that was fantastic, Ian. Thank you for that. We're pressing all the wrong buttons backstage here.
Yeah, I know.
I've been speaking into a dead microphone for the last 45 minutes. but
yeah, no. Ian, stop. No. We've all been listening here, and it's been fantastic. It's quite astonishing how much of an impact all of these techniques can have, and it's nice to see computers be really fast.
Yeah,
you hear so much about computers being so slow again these days, but it's nice to be able to get it really fast. So nice one. Yeah, love it.
Yeah, and there's actually talk. Sorry. There's also
go ahead.
There's an environmental impact to all of this, right? The amount of CPU time you consume doing stuff has a direct impact on carbon. Every CPU cycle saved, that's a bit less impact on the environment. So and that's the thing at Engine we spend quite a lot of effort on. We've actually developed other high performance processing libraries in a similar vein. So we produce a library called AIS.NET that parses the radio messages that are sent by ships to report GPS data. And this was for a customer who was processing enormous volumes of that. And we were able to get a server farm from about 10 servers down to 1 by using more efficient methods. And that, that's pure power saving there. It makes a big difference, these techniques.
Yeah, that's pretty cool. And it's always nice with reflection, where you kind of, this stuff up front because your assemblies aren't going to change for the lifetime of the application for the deployment, but it's being generated every single time. So it makes sense to kind of get that information up front. Khalid, I think you had a question to go with.
Yeah, it's kind of interesting. I think Ian maybe alluded to the story behind it, but when you were going through the UTF-8 and UTF-16 encoding examples, I was like, well, duh, yeah, that makes total sense. But then I thought to myself, like, what was the story behind that, and like that discovery for you? Like, yes, this makes a lot of sense, but when you're dealing with .NET APIs, that stuff isn't so evident when you're using just C#, method calls and stuff like that.
So you're asking how did I kind of make the connection that these sort of differences exist? Okay, yes. So I mean, the short answer is I'm really old. Yeah. So I'm turning 50 in a couple of weeks. So as I mentioned, I first started using computers back at school in the 1980s, and so back then you kind of had to know what all the bits and bytes were doing. You only had, a 64 kilobyte address space, and you could know most of what most of the bytes in memory were for in your head back then. And if you didn't, you wouldn't be able to fit anything of value inside a machine that small. And so I kind of come from a background of thinking about trying to cram a pint into a quart pot, so to speak. And then my first job was actually writing kernel mode device drivers. So that's another thing where you really had to think about what is actually happening at the hardware level, because there, if you want to get high performance, you need to think about things like how many times is the data being copied? Is it, can we get this incoming data to go exactly where it needs to be? Because that's actually quite challenging. You think of a server sitting there on the network, and suddenly some electrical signals start wiggling up and down on the network port. How does it know which of the 400 processes running on your machine is supposed to receive that data? And if it can't work it out fast enough, it's going to have to put the data somewhere else while it works out where it's going, and then copy it into the place it needed to be. Whereas if you get it right, you can devise things in such a way that you don't make additional copies. And that directly connects to what I've been talking about here, because the single biggest thing about performance for this sort of processing is not making additional copies of your data. That's the number one thing. If you learn nothing else, don't make copies. And I'm going to plug my book here because it's also relevant to the talk. So I write Programming C# for O'Reilly. The final chapter in that book is dedicated to these sorts of programming techniques. We have a whole chapter on memory efficiency measures in C# where we talk about span and the memory of the pipeline reader and all that sort of stuff. And this is all part of that world in essence. And I show an example of high performance JSON parsing in that. And it's don't make copies. That's the single most important message of that whole chapter, is don't make unnecessary copies of your data, because that, above anything else, is what will kill you. Because from a device driver point of view, it's like, well, the bus that connects your memory to your CPU can only do so many cycles per second, and if you make it do more things than necessary, you're going to max out the capacity. It's as simple as that. But it's because I'm used to thinking, at that level of hardware, because I've had to debug problems by putting probes onto the motherboard and trying, measure things on the oscilloscope. You have to think in those terms. And so
somebody on the chat has just described you as coming, well, me too, because I'm of the same age, is coming from the Clive Sinclair generation.
Oh yes, absolutely, yes. I had a Spectrum when I was younger.
I have no clue what that means.
Oh, for goodness sake, you millennial.
Timex, they were branded as in the US. Timex was the rebranding of Sinclair, but yeah, they were not as popular in the US. He's not old enough.
I'll just say okay, boomers. That's all I can say.
My boss has corrected me. It was 45 servers down to 1. I said about 30. It was more. They had 45 servers and reduced it to 1. That was the.
That's very impressive. So that shows what a big impact this sort of thing can have, which is
Absolutely.
Even better than the benchmark.net figures, really.
Yeah. I mean, that was applying a load of multiple techniques, but yes, it's all part of a package.
Mm-hmm. Yeah. An obvious question is, are these code samples available on GitHub? So yeah, are they available for the audience to get access to?
So all of the custom code gen stuff I showed at the end is up there, and that was the link I put there, and someone has reshared that link in. Oh, Matt has reshared that link in the comments. So the demos are currently not available. The reason for that was that I was doing this talk at a bunch of conferences and didn't want to put it available for people who hadn't. I would have ended up making it available to people who hadn't paid, who were going to go to a conference later. So yeah, I probably could do that now though. They're on a repo which is not currently public, but yeah, I can set that public now, I think.
Yeah, that'd be cool. We've been asked as well. About,
I guess people can follow you. Go ahead.
So I think we've got a delay, Khalid. Why don't you go? Go ahead.
Well, I was just going to ask, folks should just follow Ian Griffith on his social media channels. Go to Engine. Maybe you'll end up writing a blog post there about this talk. So
yeah, Engine is
go
my
there.
Engine
So,
blog is
go
the
ahead,
best
Matt.
place. Yeah, the Engine blog's the best place. I am IDG 10 in most places. That's IDG 10 is me on GitHub. It's me on Twitter. I'm not. I've been a lot less active lately on Twitter because reasons. But yeah, I'm still there. So sorry, Matt.
Yeah, no problem. I was just going to ask a different question. So we've been asked, I'm not quite sure of the concept here, but can we add our own JSON property info arrays into the partial class that's getting generated? So if you wanted to override or sort of have custom handling for what the code generator produces, is that possible?
Right. So if I understand the question, the idea is that. Sorry, someone said Twitter ? X, I should have said. But anyway, back to your question. The thing about that code gen is that it's creating a type called JSON type info of T, which is almost entirely opaque. So its innards are not accessible to you, and so it's a sort of in-only API, and it's not really meant for public deconstruction. So you certainly can't get any of the information back out of it yourself. So all of the generated code just pushes information in to what looks like a black hole. And to the best of my knowledge, you can't really change that. The only thing you could do would be to disable it entirely, copy what the code gen had done, and then write your own version of it. So you could do that, because obviously the code gen can't do anything you couldn't write by hand. But there's no mechanism in the tooling, as far as I know, for getting it to do most of the work, but for you to change a bit of it. I don't think they support that.
Yeah. I mean, it all depends on what the original asker was intending to do with that additional property. I think we've got one last question before we wrap up then, and it's again with the code generator there. You showed that it's kind of caching some reflection data to prevent that sort of first warm-up cost. And then also a serializer, wasn't it? Does it do anything at all for deserializing, or is that not appropriate?
Oh, no, it works in both directions, because serialization and deserialization both need the same information. Fundamentally, they need to know what properties are there. And so they both use the same thing if you're using the JSON type info of T stuff. However, if we're talking about the streaming stuff, so there was the code that basically does a very fast write out to the UTF-8 JSON writer, UTF-8 JSON writer, I think it's called. There is no reader in that one. That's asymmetrical. So that one, and the reason it's asymmetrical is, well, do you remember the code I showed you for the fastest one that was 8 pages of code? It's hard to write that stuff, but the more subtle aspect of it is that it's not at all clear what the output format should be. So that particular thing knew exactly what it was looking for and is returning a single thing once it's found it. But that's a very specific goal. And they could write a code gen that did that. But what if you wanted something else? What if you wanted the top 3 things? What if you wanted to group stuff? You'd need a different code gen every time. And no one has yet proposed within Microsoft or on Microsoft's repos how that might look in a way that looks plausible and sufficiently general for them to do it. I think they would like to do it. They said they would like to, but they said they don't have a design they consider good enough yet. That's why they haven't done
No,
it.
that's fair enough. That's good. Okay, well then, I think we're done. Thank you very much for your session. It's very interesting. Lots of cool tips and useful things to know there. I'm sure a lot of people put that into practice and benefit a lot from it. So thank you very much. I'm going to drop you off the stream and we'll introduce our next host, which is going to be, who's it going to be? It's Martin again. Hello, Martin. No, you're muted.
I thought his name was Jason. I thought his name was Jason.
Yeah.
Not Jason. We had an entire talk about Jason. Let's not talk about Jason now.
Fantastic. So a whole bunch more of very good sessions since you were last on. I hope you've been sat there glued to your screen and enjoying them.
Absolutely. Cool. Let's do this.
Oh man, we didn't get a chance to thank Matt. He just kind of bounced. So thank you, Matt. Bye.
Yeah, thank you, Matt. We can still see you backstage smiling, so people know that Matt is smiling. This is a fantastic moment.
Yep. So go ahead, Martin. Sorry. Go ahead.
Yeah, I was going to say, I think we still have a raffle that we can do. We promised there would be raffles during this live stream, so let's see if someone wants to win a .ultimate license.
Oh, wow.
Khalid, you wanna ask the question to people?
Oh, yeah, sure. I'll ask it. Ian, on our previous talk, talked a lot about JSON.NET. So this is really no, chat. Stop putting in dates. That's not the question. The question is, this will test your speed in terms of your keyboard navigating. So get ready. How many downloads does JSON.NET currently have on NuGet.org? Okay, I have a number. Let's go. Let's see if people get this. It is not purple. Purple is not a number, chat. Giraffe. Oh, geez, what is happening? All right, let's go. No.
99 billion. It's close, but it's not that demands.
All right. 3.8 billion is the correct answer. So, Inua Pedro? Yeah. All right, chat, you can stop.
Congratulations. This is good. I think we can stop all of the colors I have mentioned, and it's around 3.8 billions.
Yeah.
Awesome.
I am worried that people think colors are numbers, but I've heard that there's actually a condition where people can see numbers as colors and stuff like that. So maybe that's what's happening.
I think that might be useful. It could also be that we're streaming for over 9 hours by now. And I'm actually curious, is there anyone in chat who has been watching the entire thing from the start today? Just let us hear there. I'm really curious.
I mean, I know one person who has, like you, obviously, Martin, right?
Yeah, exactly. Just following along all the talks. Loads. Yes. Thank you. Awesome. Matthias as well, Chris Baker as well. This is fantastic.
Yep.
So tired. Yeah, I can imagine. We still have 2 talks for you though, and pretty good talks actually.
Yeah. Our next guest, who's, oops, sorry. Go ahead, Martin.
Go for it. Go for it.
Oh, I was gonna say our next guest is really, he's kind of scary smart. He always kind of like, the things that he talks about are very, very impressive. So I'm excited to see his talk coming up. I know he's been here last year, and he's a big F# proponent. So, I'm really excited to see his talk this time. So I don't know if now's a good time to welcome him in, or should we
bring him in? Matthew, are you ready? Yep, thumbs up. So let's bring him in. Matthew, hi, man.
Hello, how are you? Glad to be back.
Yeah, welcome back. And I'm so happy that you actually wanted to come back after being hosted by Khalid last year.
Oh, no, it was fantastic. I had a great time.
Cool. So yeah, we saw JSON performance, and I think your talk topic is probably another performance topic, and I'm really, really curious to see everything in action. So without further ado, let's bring in your screen as well, and maybe give you the stage. So the fastest .NET dictionary with F#. looking forward. Good luck.
Excellent. Thank you. Well, as we said, my name is Matthew Cruz, and I am incredibly excited to talk to you today about writing a dictionary with F# that is the fastest dictionary in .NET. Now, one of the things I want you to take away from this talk is the thought process and tools that we use for optimizing data structures. This is just one particular example, but this could be applied against all types of data structures. Now, another name for this talk could have been an engineering experiment that got out of hand because it ended up going much farther than I ever intended it to do. Now, for a little bit of context, who am I? Well, I am a software engineer, and I work for Simulation Dynamics. Simulation Dynamics is a consultancy based out of the United States that works with predominantly Fortune 500 companies to build simulations to optimize supply chains, warehouses, and manufacturing facilities. And we are a .NET shop with quite a few F# developers, actually. In addition to that, I also run the Fast F# YouTube channel, where I provide introductory material to learning F#, but then also provide deep dives on how to optimize the performance F# so it can run as fast as possible. And I also do some consulting for other companies as well as they need F# performance improvements. Well, the story begins with me taking some time just kind of pondering. And I'm like, I wonder what the performance is of the different key value collections in .NET. So things like dictionary, read-only dictionary, the F# map. And the reason I was curious about this is because one of the patterns that I often use is I have a static set of data that I want to perform frequent reads on. And so I want those lookups to be as fast as possible. But since the data is static, I put it in a read-only dictionary so I know that my program is not mutating that data later on. So out of curiosity, I decided to create a benchmark for this test. And the benchmark was going to be looking at two different possible key types, integer and string. Now, in reality, I actually tested a lot more than this, but for the purposes of this presentation, I'm going to limit it to integers and keys because I only have an hour. And there's only so many different charts I can show you without overwhelming you. I'm also going to use sizes of 10 keys, 100, 1,000, and 10,000. And again, in reality, I actually tried a bunch more, but these were the sizes that provided the picture I wanted to paint for you. So what is the actual thing that I am measuring? Well, it's going to be the sum of the time to perform 100 random lookups on 100 random instances of these key value collections. And the idea behind this was I didn't want the CPU to be able to memorize access patterns or memorize the data. I wanted it to have to struggle with the randomness of looking something up in a key value collection, like a dictionary. And I decided to start with the default collections available in F#. So the F# map, the .NET dictionary, the read-only dictionary, F# dict, and F# read-only dict, which are convenience functions for creating these key value lookup collections. And when I measure that, this is the picture I get for integer keys. And what we see is that the F# dict is faster for 10 and 100 keys, essentially the same performance for 1,000 keys to the .NET dictionary, and again, similar for 10,000. When I go to string, though, the .NET dictionary is faster for string keys across the board. Now, one of the things you might notice is that the read-only dictionary is not as fast as the plain .NET dictionary. And I actually found this a little bit upsetting. And the reason is because I realized I'm paying a performance penalty for using a read-only dictionary instead of a plain .NET dictionary. And in my mind, that didn't make sense. Why would that be the case? Shouldn't a static set of data be able to give you better performance than a mutable set of data? So I decided to start doing some research on what it takes to write a fast dictionary. And on my journey, I came across this fascinating talk by Malte Shrupke. I hope I am pronouncing that correctly. My apologies if I am not. This is a C++ talk where he showed that it is possible to create a hash table, which is another name for a dictionary, that was dramatically faster than the default dictionary in C++. And I found this very interesting because I had always assumed that the C++ crowd is obsessed with performance. So wouldn't their default dictionary have the maximum possible performance? And what Multi showed in this talk is that that is not the case at all. And in fact, there are huge performance improvements that can be made to the default dictionary in C++. So that got me thinking, what if the dictionary that is built into .NET is not actually fully optimized? What if we could actually implement something that's even faster than the .NET dictionary? So I decided to take on what felt like an overwhelming task at the time. And this is an actual picture of how I felt, me kind of battling Cthulhu. And the challenge I set out for myself was I want to see if I can build a better dictionary than .NET. And what I mean by better is faster for reads. I want to put in a caveat here at the beginning. The .NET dictionary is fantastic. It is a great dictionary, so I'm not going to speak ill of it at all. It protects you against problems that you probably don't even realize that you have. Things like frequent collisions for strings and denial of service attacks. So it is a great dictionary, but I wanted to see if I could create one that was faster. And the idea I had was, let's start with something very simple. And then over time, I will evolve it using profilers and benchmarking. And then hopefully by the end, we could come up with something pretty awesome. So this is hopefully a visualization of what the end product of this is going to be. So to start off, I said to myself, let's start with a completely naive implementation of a dictionary with no regard for performance to have a starting place. And if you go and read the literature on dictionaries, also known as hash tables, you will see that what is often done is that you have this array often called buckets. And this array is kind of the backing data store for your keys and values. And the way you insert a key and a value into the dictionary is that you start with the key and the value. You then compute a hash code based on the key. So you're taking that key, which is some arbitrary type, and then you have some logic for turning that into an integer value. Hash codes in .NET are almost always modeled as integer 32. So when I say hash code, I'm referring to a random int 32 that key transforms into. I then take that hash code, and then I have logic for mapping that hash code to a bucket in this backing array. Now, for simplicity, the way you can deal with the way to deal with collisions is you don't put your key and value in the actual bucket itself. The bucket has a reference to a linked list that sits out on the heap. So that hash code gives you the pointer to the list. You then follow the list and then add your key and value to that linked list. So that means when you want to add another key value pair to this dictionary, you again compute a hash code. That hash code maps to a bucket, and then you follow the linked list and add an element to the end of it. This technique for dealing with collisions in dictionaries is called separate chaining. And it's the naive beginner's approach to doing this. And so what does that look like in our code? Well, we're going to have a type bucket, which holds a key and a value. And then when we create our dictionary, we are going to create a buckets field. And that is an array, which is holding lists of buckets. In this case, the list in F# is a linked list. It's not the list from C#. It's a very different thing. So what is the logic that we then use for mapping that hash key to a bucket? Well, in this case, we're going to use the F# generic hash function, which can take some arbitrary type and compute a hash for it. We then want to mask off the first bit of that int32 to ensure that it is positive for our case. And then we use the mod operator to take that arbitrary int32 and map it to one of the buckets in our backing array. So how do we then search for key values once we've inserted all the ones that we want to store? Well, we would compute the bucket index for that key. We then find the linked list in the array. We're going to use the F# list.find function, which searches for an element that returns true. And our condition is going to be using the simple and default equality logic for types. When I use this approach, the performance is terrible, which is to be expected. This is the naive approach, no regard for performance. So for integer keys, it is terrible across the board. So we only have room to grow from here. For string keys, it's not quite as bad, but we are still far behind. Now, the way we are measuring all this is that we are using the fantastic library benchmark.net, and it is able to report various metrics on how our benchmarks are running. And one of the things that we find is for our benchmarks that we are performing a lot of allocation while doing lookups in a dictionary, which is absolutely outrageous. And this is what it looks like inside your CPU when you have allocations occurring inside your dictionary lookups. It is not a good thing. It is terrible. So how do we deal with this situation? Well, I use .memory, and I start looking at the heap, and I start looking at the allocations, and I'm saying, where are these allocations coming from? What is going on? Well, what is going on is that the code is using the built-in hash inequality to F# that is robust, but it is not fast. So we want to get rid of that, because remember that I mentioned we're using this generic hash function that's built into F#. That hash function can take types of arbitrary shape, but because of that, it's not necessarily fast. So we want to replace it with something else. So what do? We go back to this naive approach, and we need to get rid of this hash function. We are instead going to use the equality comparer default get hash code. This will remove the allocation that is happening when we do the hashing. And then we go to our lookup logic, and we want to get rid of this equality. This is another location where these allocations are coming from. We instead want to use equality comparer.default equals, and this will get rid of the allocations happening when we are doing the lookups. So now when we use this updated version of our dictionary and we benchmark that, we see that integer keys are now performing dramatically better. On this chart, the .NET dictionary is in blue. The dictionary that we are evolving will always be in orange. And the previous version's performance will be the green bars. And so you'll always be able to compare what the performance was like compared to the previous version of our dictionary. So we're going to be constantly evolving this. So now our integer lookups are dramatically faster in this case, and we'll discuss why later. And strings are now faster for 10-element and 100-element dictionaries, but slower for 1,000 and 10,000. Sorry, slower than the .NET dictionary. So I continue doing research, and it turns out that Malti, the person who gave that talk that inspired me, actually has a blog where he has incredibly detailed analysis of the work that he did optimizing a dictionary. And one of the things that he talks about in there is the idea of Fibonacci hashing. And he proposes Fibonacci hashing as a way of mapping hash codes to buckets that is faster than using the mod operator. Let's talk about what that looks like. So right now, when we map a key to a bucket, we are using this mod operator. And this is a very, very common technique. And if you actually go look in the .NET source code, they have a fast mod function. So again, very common to use this because it makes it very easy to map an arbitrary integer to an array of any given size. Now, rather than that, we're going to use the Fibonacci hashing, and this is what Fibonacci hashing looks like. We now have this large number, which comes from, if you want to understand the math of why this works and why it's good, I recommend going and reading that blog post because he does a fantastic analysis. But instead of the mod, we're going to multiply by this very large number, which has very good randomness properties. That's going to cause the integer to overflow and generate a random integer. And then we're going to use a bit shift to map that large integer down to a power of 2. And the restriction that we are now adding to our dictionary is that the size of that buckets array that's holding our data has to be a power of 2 for this technique to work. Now, why would we want to do this? Why is this such a good idea? When you want to do mod in any language, that maps down to the IDiv x86 instruction. And if you go and look at the logic that has to happen in the CPU to do division, it's very difficult. CPUs are terrible at division. And it's beyond the scope of this conversation, but it's not possible to make it fast. So when you're doing a mod, you're actually doing an IDiv x86 instruction, and that has a latency of 13 to 28 CPU cycles. So it takes 13 to 28 cycles before the next operation can commence. Compare that to Fibonacci hashing, which uses the imul instruction and a shift right. Together, those are only 4 CPU instructions. So Fibonacci hashing is anywhere from 3 to 6 times faster for mapping a hash code to a bucket. So this optimization gives us another boost in performance. We now see that Fibonacci hashing is dramatically faster than our zero allocation version for dictionaries with 10 and 100 integer keys, but essentially the same performance for 1,000 and 10,000 element dictionaries. When we go to strings, we do see a slight boost in performance. It's more dramatic for 10 and 100, and it's less so for 1,000 and 10,000. So let's go look at our benchmarks coming from benchmark.net. And one of the reasons that integer lookups are doing so well for our small dictionaries is that the CPU is so smart looking at our data and our access patterns that it is able to almost perfectly predict the branches that needs to be taken. So that is why we're getting this astounding performance from integer lookups already. Now, I got curious and I said, I saw a dramatic improvement for integer, but I didn't see a dramatic improvement for strings. So the question I had was, why are string keys so fast? What is going on in the .NET dictionary that makes them so good? So what I decided to do is to use .trace and profile my own program to say, where is my program spending so much time? And I see that it's spending a significant amount of time on this compute hash 32. And this is the logic that it's using for hashing the string. So I said, okay, well, let's see what .NET is doing in this case. So I dig into the source code of .NET, and I find this code in the .NET dictionary, and there's some really interesting comments in here. One of them is that it is storing the comparer for ref types. So that's an optimization that I could include. I also see that for value types, it's always using the default equality comparer. And this is so that the JIT can inline and devirtualize for value types. So again, a fantastic optimization. I think I'll borrow that. But I also see this really interesting thing. I see that's checking the key type, and it's doing something special for strings. And you see this all over the .NET code base. String is such a predominant thing that you will often find unique optimizations involving string. So I keep going down the rabbit hole and say, okay, where is the actual logic for computing the hash of a string? And I eventually find this. So this is the special logic that the .NET dictionary is using for hashing strings. And it is extremely performant piece of code. And I said, I like that. I think I'll borrow it. And by borrow it, I mean translate it to F# and use it in my own code because it's such a good idea. So this is the F# version of that code where I've just translated it to F#. And so I'm going to use this as my equality comparer for string types. And then when I create my dictionary, I'm going to have a check on the key type, say if it's string or not. And if it is, I'm going to use my string comparer. And when I use this, I get an interesting result. It is slower for 10 and 100 element integer dictionaries and barely faster for 1,000 and 10,000. For strings, it is just as fast for 10 and 100 element dictionaries and faster for 1,000 and 10,000. And it's at this point I get an idea. Now, I remember doing some light metaprogramming in .NET back in the day because I knew that the runtime and the JIT could look at your collections and figure out what pieces of code will never actually be hit and can simplify your code so that it actually runs faster. So I said, okay, up to this point, my getValue function has had the type check inside of it. So this is kind of way buried down deep into the dictionary itself. I said, well, why don't I raise that type check higher up in the dictionary? So now I have two functions, one for getting struct values and one for getting ref values. And then I have this type check at the very top. So it's right next to where the code is for actually indexing into the array, into the dictionary. And what result do I get? No difference. No change at all for integers and barely any difference for string dictionaries. So this is where I have a warning. What I find so fascinating about this is that optimization actually did something pretty significant in .NET 6. This code is all being tested with .NET 8. So the warning is just because an optimization yielded something on previous versions of .NET, that does not necessarily mean it is going to give you a boost in future versions of .NET because it is constantly evolving. So now we need to go back to benchmark.net and figure out what's going on. What can we do to improve the performance of our dictionary? Well, one of the things that I notice is that for the large string dictionaries is that we have a significant number of cache misses. And a cache miss occurs when the CPU needs to work with a piece of data that does not fit within the caches of the CPU, so it has to go all the way out to main memory to read that information. That might not sound bad, but reading from main memory can take over 200 CPU cycles. So your program is sitting dead waiting for this data to come in, and if there are a large number of cache hits, it is extremely expensive for your performance. So I would like to have a different way of laying out my memory, which reduces the cache misses. So one approach to this in the literature is to use the idea of linear probing. Up to this point, the actual keys and values of our dictionary were stored in linked lists. Now what we are going to do is we're actually going to embed the key and value in the buckets array itself. How do we do with collisions, though? So if I have this new key and value that I want to insert, I'm computing the hash code. That hash code maps to a bucket. There's already a key and value in that bucket, so I need to find a spot to put them. So what I do is I search down the array in a linear fashion to find the next available slot, and I will insert it into that next spot. So this approach of embedding the keys and values in the array is called open addressing. So how does this change our code? Well, now bucket is going to have key and value, but we're also going to include hash code because when we're comparing equality of strings, that can be very expensive. So what we're going to do is before we check the equality of string, we're going to say, do the hash codes actually match? If the hash codes match, then we'll check for string equality. But if they don't match, there's no way that the strings are actually equal to each other. So we're embedding all three of those elements into each bucket in our buckets array. How's the performance of this? Well, again, mixed bag. For integer keys of 10 and 100 element dictionaries, it is terrible compared to Fibonacci, which has been our best to date. For 1,000 and 10,000 element dictionaries, it is actually better. When we go to benchmarks, you'll see why this is happening. But notice that there's a huge performance difference here. For strings, though, we get a more interesting result. Linear probing is worse for the 10 element dictionaries, but faster for 100, 1,000, and 10,000. So if we go to benchmark.net, we can see the reason that integers are performing so much worse than they did in Fibonacci is that our branch mispredictions have gone up dramatically. This is very bad. But don't worry, we'll get that performance back by the end. But we can see that the number of cache misses for our string dictionaries has gotten significantly better. And that is why we are getting better performance. Now, let's talk about one of the problems that can occur with this linear probing technique. I have an existing dictionary. It has its buckets array. It has quite a few key value pairs in it already. I get a new key value pair. I compute the hash code, and I map that to a bucket. That bucket already has a key and value in it, so I start searching. Next bucket, still full. Next bucket, still full. 100 entries later, I actually find an empty spot to put this key and value in. And so what does this mean? Using linear probing naively, it is entirely possible that the key can be very far from the bucket it originally mapped to, which means the worst case performance for linear probing can be very, very bad. And this is part of what is kind of causing these these branch mispredictions for those integer keys. And so we would like to have an alternative layout that keeps the data closer to where it originally mapped to. And one of the techniques that's used for this is called Robin Hood hashing. Now you notice in our buckets, we've added a piece of data, and that piece of data is the offset. What the offset represents is how far is that key from the original bucket it mapped to. So in this case, key 1 and key 2 are actually in the bucket they originally mapped to because their offset is 0. Okay, how does Robin Hood hashing deal with collisions? We have key 100. We compute the hash code for it that maps to a bucket that already has a key and value in it. If we were to insert key 100 into this bucket, its offset would be 0 because it's the first bucket it mapped to. Key 1 is already in that bucket and also has an offset of 0. We have a tie. So we don't evict key 1. Key 100 has to go somewhere else. So we go to the next bucket, kind of like linear probing. But this is where it's different from linear probing. Key 100 would have an offset of 1 at this location. Key 2 has an offset of 0. You can think of key 100 as being poorer. It is worse off than key 2 at this location. And so what we do is we evict key 2 and we put key 100 in. And this is the idea of Robin Hood hashing. It comes from the legend of Robin Hood, which was a person who stole from the rich and gave to the poor. And so the idea here is that we are going to steal from keys that are rich and that they are close to their home and give to keys that are far from their home. So we've evicted key 2. We're going to have to reinsert it, and it goes into this next available slot, and its offset is now 1. And so the idea with Robin Hood hashing is we're balancing out just how bad off any key value pair is and trying to keep things relatively close to the original bucket that they map to. And the idea is that we're going to have to iterate through fewer buckets in the worst case scenario. So how does this change our code? Well, now bucket has 4 elements. One of them is the offset, which represents how far that key is from its home. How does this do? Turns out it is worse across the board for integer keys. Interesting. It is also worse for string keys across the board. What is going on? Great question. And again, benchmark.net reveals our branch mispredictions are worse across the board. And the reason for this is that with linear probing, there's a high probability that many of the keys were actually in that first bucket they mapped to. But with Robin Hood hashing, you're often evicting keys because you're trying to prioritize things being close to their home. And so this ends up causing more branch mispredictions. So your worst case scenario may have theoretically gotten better, but your average case has gotten worse because the CPU is having a harder time figuring out what logic it needs to follow. So one of the lessons that we need to take away from here is that performance is this balancing act. We have to consider, are we trying to optimize the average case? Are we trying to optimize the worst case? The correct thing to optimize for will depend on your use case and what the demands of your application are. In my case, I'm trying to optimize the average case. And so this is no go for me. Now, if you're curious, there are many other approaches that fall under the open addressing approach. Things like quadratic probing, double hashing, cuckoo hashing, hopscotch hashing. Turns out this is a pretty good place to get a PhD, apparently. But what I'm going to do now is skip to the ultimate version that Malti gave in his presentation. Malti also wrote up a blog post where he detailed the engineering that went into his ultimate version. He called it a byte linked list. I'm going to call it a byte list because the list in F# is a linked list. And I didn't copy his code exactly. I was basically inspired by his approach, but I had to adapt it considering that F# has a different set of restrictions than C++. So how does a byte list work? Well, when we want to add a value to a byte list version of a dictionary, we again have our key and value. We compute their hash code. We map it to a bucket. That bucket is currently occupied, so we can't insert it in there. We search for the next bucket, still occupied. We go to the next one. It is available, so we will insert it in here. Now, this is where byte list is different than those other approaches. We're going to go back to the original bucket that key 3 mapped to, and we're going to add an entry, and we're going to call it next. And what next represents is the offset to the next key that mapped to this bucket in the first place. And so these next fields are acting like indexes of a linked list that has been embedded in this backing array. So this means when we want to go look up a value from this dictionary, we again start with the key, compute its hash code, we go to the original bucket that it maps to. We check, does key 1 match key 3? It does not. And instead of doing what linear probing or Robin Hood hashing have to do, just iterating through the buckets one by one, it can immediately skip to the next bucket that could possibly match this key. So how does it change our data? Well, now we have our bucket and we have this next field and we're storing it as a byte. And the reason we're storing it as a byte is because it's small and the probability of your offset being greater than 256 is infinitesimally small. Now you obviously have to do some programming to protect against degenerate cases, but it essentially never happens. So what is the performance of the byte list? Dramatically faster. Dramatically faster. This is by far the fastest thing we've seen so far. So this is fantastic. I told you we would get that performance back. So wonderful times. Same thing goes for string. String is now faster than the .NET dictionary across the board. And so this is just a win everywhere. And at this point, I was very excited and I thought I had done well. And I want to emphasize, I'm not doing anything particularly innovative here. I'm just being inspired by developers in other fields who are actually far smarter than me and then translating it to F#. So I'm not taking credit for these ideas. I'm just being inspired and seeing what it looks like in F#. I felt good for a while. And then a new foe appears. And that foe is the frozen dictionary. Now, coming in .NET 8 is the frozen collections, one of which is the frozen dictionary. And the idea is, let's have some collections that are optimized for read access. We will front load the creation of these collections by doing some additional work to ensure that the read performance is as fast as possible. So Frozen Dictionary was created for the exact scenario that started this entire project. And I was like, okay, well, let's see how Frozen Dictionary does against what I have so far. And when I compare it for integer keys, I'm still feeling pretty good. Byte list is still faster in this case. I'm like, oh, and to be clear, Frozen Dictionary is now the blue bars. Byte list is the orange bars. And so it's no longer the .NET Dictionary. This is Frozen Dictionary as the blue bars. When I compare it to string, though, things change slightly. Byte list is faster for 10 and 10,000 element dictionaries, but it is slower for 100 and 1,000. Okay, what are we going to do here? Well, again, we are guided by benchmarks. We're not guessing where the problems are. We're measuring where the problems are. And benchmark.net is saying, hey, you actually still have quite a few cache misses when performing these lookups. And so I thought to myself, what can I do to improve the data locality for these and reduce those cache misses? And this next idea actually came from the game industry. So the game industry is often writing code that has to run as fast as possible. And so one of the things that they will do is they will lay out their data in a different way. Up to this point, the way we have been laying out our data would be referred to as an array of structs. Buckets is an array. Each element in buckets is a struct. That struct is made up of several fields. Very common way of laying out data. An alternative way of laying out data would be a struct of arrays. So those fields in our struct now become arrays themselves. And so you can think of this as actually pivoting your data and reorienting it. Now, why would you do this? And I want to be upfront. This is not always a win. The use of this technique really needs to be guided by your use case and how your program runs. But it is often a good optimization, so it's something to consider. And so what does this make our code look like now? Well, now we have this type data. So this is the data contained by our dictionary. Keys is now a string array. Values is now a value array. Hash codes is an integer array. And nexts is a byte array. So we've basically taken the byte list implementation and done a struct of arrays transform on how that data is laid out. For integers, it's worse. It's worse across the board. So what this tells you is that, oh, okay, maybe I don't want to take this approach. Maybe this is actually worse off. I thought this would help things. For the case of integer keys, it does not. For string keys, though, it gives us a significant improvement, almost universally. I mean, the improvements for 1,000 and 10,000 element dictionaries is smaller, but it's still there. So one of the things that we should take away from this is that, hey, if you're wanting to write a really optimized data structure, you may have to have alternative layouts based on the types going into that data structure. So this is actually something that .NET already does with its dictionaries. So I don't consider this a thing cheating at all, but it's something to consider when you're trying to push performance as hard as possible. Now, there still remains a problem. My version is not as fast as Frozen Dictionary for 100 element dictionaries. And I get a little depressed, I'm not going to lie, because I knew that the JetBrains .NET days was coming a ways out. And when I started this project, I'm like, oh, this would be a great talk for them. But then when I came across this, like, I can't make this claim about being the fastest anymore. So what is even the point? So, and I struggle with this, and I try so many different things, and I make zero headway. And I'm like, what on earth is Frozen Dictionary doing that is making it so obscenely good? And so I went deep into the frozen dictionary and what the heck is going on. And it turns out the reason frozen dictionary is scorchingly fast for this scenario comes down to the idea of perfect hash functions. What is a perfect hash function? A perfect hash function is a function that can take a set of keys and map those keys to a set of buckets with 0 collisions. It is guaranteed to not have any collisions at all. And when you can guarantee that, you don't need logic for dealing with collisions anymore. You don't need search logic to start iterating through an array and find where the problem is. Sorry, find where the key is in some alternative location. And what is happening with frozen dictionary is that when you bring in a set of keys to create the dictionary, the first thing it does is it examines all those strings. And it will emit the most optimal hash code logic possible for those strings. And it will do crazy things like use the length of the string as a hash code, use a single character of the string as a hash code, use the minimal subset of the string for the hash code. It's a very impressive piece of engineering, I'm not going to lie. But it is essentially creating perfect hashing functions every time for dictionaries of 100 elements. Now, it's not guaranteed in their code, but it is essentially what is happening at the end of the day. Now, why is creating a perfect hash function a difficult problem? Well, it comes down to the idea of the birthday problem. What is the birthday problem? The birthday problem is a very interesting product of probabilities. And it's the idea of how many people do you need to get into a room before 2 people actually share the same birthday. And what is a very surprising result is it only takes 23 people to get together for the probability of 2 people to share a birthday to be 50%. It's bizarre, but it's true. And so this idea of birthdays colliding and having a very high probability of collision also comes up with keys mapping to hash codes, mapping to buckets. And that's why it's a really difficult problem. And so I probably thought about this for a month, maybe longer. And I didn't take snapshots of my notebook, right? I just started scribbling out ideas like, is it possible for me to create a perfect hashing function that is also fast? It's not difficult to create a perfect hash function. You can do that. That's not the issue. It's when you need that perfect hashing function to be fast that you run into a whole bunch of problems. And so I mulled over this, and then I had this thought. What if the hash codes for the dictionary are unique? What if we add this restriction to our data? What does it enable for us? Well, let's talk through a possible scenario, and I'm going to start describing an algorithm. I was not able to find it in the literature. If you're someone who's watching this live or is watching a recording and you know what this algorithm is that I'm going to describe, please email me. I would like to know because I would like to give credit. And this technique is not guaranteed to work every time, but I haven't seen it fail yet. I'll put it that way. The probability of it succeeding is very high, and it has to do with the guarantees of randomness when it comes to hash codes. So let's say I have this situation. I have 5 keys with 5 hash codes mapping to 4 different buckets. Key 1 and key 5 are not a problem. They've each mapped to a unique bucket. But I have to deal with the collisions of keys 2, 3, and 4. And now remember, I have guaranteed that the hash codes are unique at this point. So assume that has taken place. And this is one of the other things that's important about this technique. It's not guaranteed to succeed. So you need a fallback version of your dictionary to deal with the scenarios where you do have hash code collisions, where 2 keys are computing the exact same hash code. Highly improbable, but possible. You need to deal with it. But let's assume we've done that validation and we have unique hash codes. And for this example, let's say these are the hash codes for those keys. So key 2 has a hash code of 3889, Key 3, key 4. They're unique. Now let's represent those hash codes as binary. So just zeros and ones. If I want to differentiate between 3 keys, I need at least 2 bits of information. And that's kind of intuitive. If you want to differentiate between 2 keys, you need 1 bit because a bit can be 0 or 1. If you need to differentiate between 3 keys, you need 2 bits so that you could have 0, 0, 1, 0, or 0, 1. So we need at least 2 bits of information from these hash codes to uniquify them from each other. So what I mean by that, like, hey, there are several candidate locations. I'm looking for locations in these hash codes that will uniquify the hash code based on just 2 bits. And these are examples of what I'm talking about. You see that first one where you have 0, 1, 1, 1, and 1, 0. And then there's several other places inside the hash codes where this is also true. I'm going to use these 2 bits as the uniquifier for these keys. And so what I'm going to do is I'm going to take this location. I am then going to shift it to the right by 26 locations. Then I am going to mask off any extraneous bits that I don't need because I only want those last 2 bits at this point. So I use a mask to get rid of them. And now I reinterpret those hash codes as just an offset. So now I know, hey, key 2 has an offset of 1, key 3 has an offset of 3, key 4 has an offset of 2. Now let's talk about how we use this information. Our dictionary now has 2 arrays. One array contains the shifts and the masks. So just what we just walked through. And the second array is the actual buckets containing the keys and the values. So if I want to look up a key using this, if I want to look up a value using a key, using this logic, I'm going to do the following. Let's say I have key 2. It gives me hash code 2. That hash code is still mapping to that second bucket like it did before. And now I know I can use what I'm calling the start index to say all of the keys that map to this bucket, their values start at this location in the buckets array. So this is a way I can store all the different values in one contiguous array is I'm using the start index to say, hey, every key that mapped to here, their values actually start here in the buckets array. Then I use the bit shift and mask that I just described to compute the offset associated with that hash code. And this is a way of being able to deal with collisions because I'm first taking the keys, mapping them to this intermediate array, and then figuring out, okay, what are all the hash codes that mapped here and what bit shift and mask do I need to use to uniquify them? And that is then what I will use to do an offset in the buckets array, which actually contains my keys and values. So how does that look in my data? I have this shift and mask type. I have my bucket still. In this case, I'm just talking about the string dictionary. So the key is just string, but again, you can make this generic. And then I have my data, which has a shifts and mask array and a buckets array. Now, when I use this technique for integer keys, it's worse. It's worse across the board. So this is an example of where like, okay, creating this like special logic for uniquifying things, it's not as fast. And it's because the byte list is just so good when it comes to memory layout and being able to index into it and look up data. So this is not a win when it comes to integer keys. When it comes to string keys, though, it is faster across the board. And now we are actually faster than the frozen dictionary with string keys across all cases. So this is what my face looked like after I got through that. I was pretty ecstatic. So based on this, what are the next steps? Well, first of all, I want to be upfront with you. I started testing these versions of the dictionary against the benchmarks that are in .NET. The versions I have win in most cases, but not all. And for me, if I want to contribute this type of thing to the .NET code base, I want to make sure it's winning across all cases. So I do have some gaps to fill in there. Like I said, it's faster in a majority of cases, but not all. And if that ends up being the case, if I'm able to close that gap, I would look into seeing if I can contribute to .NET. It'll be interesting because everything in .NET is written in C# and everything I wrote is in F#, but we'll see. In the meantime, though, one of the things that I've been working on is collecting all of these high-performance collections that I use into a single library called idos.collections. And the reason I call it IDOS is because IDOS is the name of our discrete rate simulation engine that we have developed at Simulation Dynamics, which is the fastest discrete rate simulation engine in the market. And there's quite a few specialized collections that I use for these high-performance scenarios that make writing this kind of code much easier. And so this version of the read-only dictionary would actually go into that collection. And the reason I want to do that is because I already have someone who's actually like taken my code to use in their code base. I'm like, bro, this is not production ready. And he's like, I know, but I'm stuck on .NET 5 and I need something. I'm like, oh, okay, because Frozen Dictionary isn't coming to older versions of .NET. So at the very least, I can put this out there for people who are stuck on older versions of .NET and won't have access to Frozen Dictionary. So what are the lessons I am wanting you to take away from this talk? One of them is that I want you to benchmark, don't guess where your performance problems are. You should always be measuring. You should never just be assuming whether an optimization is going to be better for you or not. I hope that you've learned that because I showed you several cases where we had an optimization that we thought would yield something and it ultimately didn't. So make sure you're measuring, not just guessing. And you should be letting the profiler and hardware counters guide you as far as what you need to do to improve performance. And you may need to optimize your collection based on the type of data that it's storing. The ultimate version of this uses a byte list version for integer keys and this perfect dict function methodology for string keys. And then for ref types and struct types, I might use something alternatively for a better memory layout. But consider that that's the price you're going to pay when you want to take ultimate performance. You may have to have specialized versions based on your use case. Also, .NET performance is always evolving. And just because an optimization worked on a previous version of .NET does not mean it is going to yield you something on a future version of .NET. And I was actually really delighted with this because it saw that the optimization that I had used previously that involved more work were no longer necessary because the JIT compiler is so good now at figuring out what it is your program is trying to do. And lastly, don't assume that everything out there has already been optimized. The computer science field is still a very young art. And in reality, like how long have we been programming computers? Not even 100 years. And so don't think that things are necessarily settled and something is actually optimal at this point. And part of that comes down to the fact that hardware is still rapidly evolving. We are now seeing this proliferation of different types of hardware. It's not just CPUs. It's not just GPUs. We have things for neural networks and all kinds of sophisticated things. So just because one technique is optimal in one use case does not mean it's optimal for your use case. And so finally, I just want to say thank you. Thank you to Multi. If you ever see this, your talk and blog were incredibly inspiring. Thank you also to the F# community for your patience with all of my crazy questions. And also thank you to JetBrains for hosting me. If you enjoyed this and you want more of it, I actually have a 14 video series on my YouTube channel where I go into much greater detail and go much slower, unpacking the code, the benchmarks, and the profiling. So if you wanted to learn more, I suggest you go check out that channel. So thank you very much for having me today. It's been a real delight to be speaking. And again, if you have questions, feel free to email me and contact me and ask you questions. And if you have a performance problem with F#, I'd love to talk to you, see if I can help. Thank you very much.
That's one amazing talk, and I want to say thank you for this. There's also really good comments in the chat, people saying how they like that this was marked intermediate, but actually is an advanced talk. And I do like your call to action at the end where you say, look, talk to me if you have F# performance problems, because I would love to help. I think it would be great, because seeing in this talk that you just bite and keep biting until it's actually resolved is probably the best advertisement that you can make there. So thank you.
Thank you.
Yeah, I mean, it's still, again, like, blows my mind. Like, the first thing I'm thinking when I'm watching you is like, you know, you compact it into 60 minutes, but like, how long is this actual journey? Is it days, weeks, months? You know,
a long time. So I think I started this in February, and then everything through Byte List was pretty fast. I think that was probably about 3 weeks on and off. And again, part of it was that Malti in his talk laid out a really good foundation, right? And so I really suggest people go check out his talk. It is C++, but it's anyone can apply the learnings from there. So he had already laid a really good foundation, and his blog also goes into more detail. So I was very much inspired by that. So I had a general idea of where I wanted to go. So those first few weeks were relatively straightforward. Getting to the destructive arrays, and then that final thing, that one hurt. I don't know if I want to confess how many hours I spent on that. But it was, like I said, I probably spent a month of my downtime just thinking about that problem. And I don't have the notebook available, but just like, sometimes I've just like written out binary representation of something and like indexing, like, how can I do this? And the solution actually ended up being simpler than some of the other ideas that I had. But yeah, this one took some effort. That last one was painful. I'm not gonna lie.
Yeah, I mean, Martin had I guess he had like a thought too when we were kind of chatting with the group. Martin, do you want to ask that particular question?
Yeah, absolutely. I think it's kind of related to this entire question of how long did it take. We saw that for a long time in your talk, and we were actually saying, okay, the suspense is killing us. We saw that things were being made worse for a very, very long time. Like, when do you generally decide to stop or plow through or say, okay, this is good enough and let's stop here?
Sorry, what was the question there at the end? I'm sorry.
Yeah, that was the question at the end. So when do you decide whether you should stop optimizing because it's a road to nowhere or keep plowing through?
Yeah, so in my last year when I talked, one of the things I really emphasized is that you should always have a goal in mind. That you should say like, hey, once I reach this level of performance, I'm going to move on and do other things. I didn't do that this time. And the reason was this was more of a creative challenge for myself than anything else. It wasn't like, oh, I have this real world problem and I need something to go dramatically faster. It was more of, and this is why I said like, hey, this is an engineering idea that kind of got out of hand, because it was one of those things that once that bug got in me, I'm like, oh, like, like, what can I do? What can I do? What can I do? And it was, I have some like pet problems that I like to come back to and just kind of chew on as like, oh, okay, have I learned something that's allowing me to write a more efficient version of this? Do I know a better way to do that? I have a whole nother data structure that I might propose like for next year, which took me years to get the experience to actually understand how to break that problem down and to optimize it. This is one of those. And I've never written a like really proper data structure before. And so, I mean, beyond things like a stack and a queue, like those are trivial. So I was like, oh, this is just going to be a good engineering challenge for myself just to kind of like learn to do this, because I don't have a computer science background. I'm an industrial and a chemical engineer. And I just wrote enough software that they just kind of like pushed me into the software department. So it was basically for my own learning, which is why I kind of gave myself free rein. I wasn't restricted by meeting some business goal.
Yeah. The chat is saying that they're saying you had a personal vendetta against Frozen Dictionary. That's what drove you.
That is not false. That is absolutely not false. It was deeply I was very frustrated with like, how is this thing so flipping good? And it is. And I mean, it is a fantastic piece of engineering. I'm not gonna lie. But when you man, I don't want to say anything. So that approach is definitely an approach you can take where it's like, hey, we're going to optimize for when we can hash on string length or single characters or all these. I'm like, okay. And I could have just taken that logic and tried to re-implement it in F#. Because like, again, I gave credit, like I'm using the .NET's string hashing function like, that they use. We're taking out a pointer and doing it like, so that's the hashing function I'm using for strings. I wanted to see if I could beat Frozen Dictionary not using that brute force approach of like, hey, we're just going to create a super optimized thing for all these different possible scenarios. And so that's where the idea of having that perfect hashing approach came in. And like I said, if someone recognizes that algorithm, please let me know, because I don't want to do the math to figure out the probabilities to write the paper on it. But it's not guaranteed to work. And that's because you could have a case where certain hash codes collide and you just can't get the right bits to differentiate. I have yet to witness that scenario though. So yeah, it seems in practice, it seems to be successful.
Yeah, I mean, throughout this talk, like, do you think the dictionary is the most complex data structure, or is there, I guess, the next white whale in Matthew Cruz' journey?
Yes. It's priority queue.
Yep. Okay. All right.
And the reason for that is because most of what I do is writing high performance simulations.
Mm-hmm.
I do help with other kinds of code, by the way. I don't just do that, but it's like what my day job is. When I consult, it's for other types of optimization.
Mm-hmm.
But the priority queue in .NET, they decided that if two elements added to priority queue had the exact same priority, they would not guarantee FIFO ordering.
Mm.
So if you add two things, they have the exact same priority, but so you add A, then you add B at the same priority, you could get BA or you could get BA. And in the scenarios that I work in where I need those guarantees, like I actually need this to be in order, the .NET priority queue doesn't work. And so I have to go and implement one that actually does provide good performance, but also maintains that ordering. So that is my next white whale at the moment. So we'll see.
Yeah, is that a tease for next year's talk?
Maybe we'll see. We'll see.
I actually was gonna try and nerd snipe you there, because during your talk you dove into x86 codes and looking at instruction sets and how things are stored and processed by the CPU. So I actually was wondering, at some point during your entire journey with this dictionary, did you think of hardware intrinsics and looking into that part of the .NET worlds?
Yes. And the reason I sound exasperated is because so there are some limitations with .NET and F# when it comes to memory layout, because what I really wanted to do for one of my scenarios is say like, hey, because you're doing this, like the hash code equality, right? Just like, well, I have SIMD, I have these additional registers. I could potentially match against several hash codes simultaneously. But to do that efficiently, you need all those values in memory contiguously so that you can do a really quick load. And I really want that as a struct. I really want to embed that in a struct so that it's actually in the backing buckets array. It's not a reference to another array somewhere randomly on the heap. Like that cache hit is just going to be disaster. So like, okay, I want to embed an array in a struct, like a fixed length array in a struct in an array. And that's not easy to do. Now, in theory, you can do it, but you are doing some really janky stuff that, like, at the end of the day, you might get worse performance because, like, the compiler's having to do so much work to guarantee that you're not blowing something up. So that's the real limitation I was dealing with, is because you didn't necessarily have the control over memory layout that you need to be able to really take advantage in those scenarios. And that's where something like C has the advantage, where you can do crazy stuff like that. And so I'm actually talking at the F# Data Science Conference happening in Berlin on Thursday. And it's all, one of the things I talk about a lot is just memory layout. And I'm not going to emphasize the shortcomings of .NET, but this is one of those things where that fine of control really limits you at being able to use the SIMD intrinsics the way you would like to in some of those scenarios. So I did think about it, and it caused me a lot of frustration. And this is where the thank you to the F# community comes in, because they had a lot of patience with telling me, no, Matthew, you can't do that. I'm like, why?
Yeah, I mean, it's funny you're talking about like CPU operations and those intrinsics and stuff like that. Maybe this is a reverse nerd snipe on Martin, but it'd be cool if you could just kind of see it like inlay hinted, like, oh, maybe there could be a different optimization here based on your CPU architecture or something like that. So I don't know. I don't think that's coming anytime soon, but I can imagine for folks like you optimizing like data structures, that seeing those intrinsics and seeing what CPU calls are happening would be really, really helpful, right? When you're looking at high level code too, right? So
well, this is why I use sharplab.io quite a bit as a way to see, like, hey, what is this decompiling down to at the end of the day? And benchmark.net can actually do that as well. You can add something on there to say, like, hey, please emit for me all the x86 that you generated for this benchmark, so you can get an idea of what is going on.
Well, this is like one last question, and then we'll let you go. But you've talked a lot about like x86 architecture and stuff like that. Have you looked at any of the different architectures? Like ARM is kind of the biggest one coming up. Have you tried to run any of the benchmarks on different chipsets?
That's a great question. So I do not have an Apple machine right now, but I have friends who do, and they have run it, and the results are very similar. Now, the memory bandwidth on the CPU in that iMac Mini is just outrageous. You get the same shape of results. And the reason for that is that at the end of the day, CPUs are all actually relatively similar. And what I mean by that is fundamentally it's a state machine, and it's mostly made up of loads, stores, adds, subtracts, compares. And so they're not as different as you might think. So the answer is yes. I have looked at them. At the end of the day, most of what we are running on is x86 64 CPU, so Intel, AMDs. And it was really interesting to see the result differences between running this on a Zen 2 versus my current machine. But again, it's the same essential shape of the results.
Okay. Yeah, cool. Thank you for that. It's really interesting. So Martin, I'll throw back to you, and then we could say bye to
no more questions from my side. So Matthew, again, thank you for a fantastic talk. I think we enjoyed it, the audience enjoyed it. So thank you for joining us, and actually hope to see you again next year if we do this.
We'll see.
Yeah, me too.
Thank you very much.
Thank
cool.
you.
All right. See ya. Bye.
Bye.
Hey, chat. That's not very nice. Hello, nerds. Yes, we're nerding out.
Hello,
it's
nerds.
Fine.
It is nice. It's cool, right? We are all nerds and just hang out together, learning about new stuff and everything. Khalid, do you think we should do one more raffle for today?
Yeah, let's do it. Do you have a question? Go ahead, Mark.
I have a question. It's not super technical. It is really about the .NET Day event. A lot of people earlier mentioned in the chat that they have been joining all of the events. So now I am very, very curious if any one of those people would know how many times we've run this event, including today.
Okay, the number is between 1 and 3,000, I think. So
yeah, correct. No, between 1 and purple. Between 1 and purple. Oh wow! First answer is correct, Kevin. Congratulations. Yeah, that was a really short raffle and very easy. It's 5 times, so this is the 5th time. Kind of an anniversary, right? Although I think if we celebrate this thing, we should do it at 10.
10. All right, Martin, you're really like predicting out very far. But what version of .NET are we gonna be on when .NET Days is at the 10th anniversary?
Is that going to be .NET 15 or something like that?
Yeah, imagine we're going to go to Roman numerals by then. So I'm not sure.
Although maybe by then we will have .NET spelled as .NET and not with the actual dots in the name.
Oh geez, I can only imagine.
That's a different discussion.
All
All right. Let's bring in our final speaker of the day, Daniel, who has a fantastic talk on xUnit. It's been a while since I've really dug into xUnit, so I'm not up to speed with all of the latest stuff there. So Daniel, if you're ready, let's bring you in. There you are.
Cool.
Perfect. Thumbs up and everything.
Cool.
You're welcome.
Yeah. Thank you. Glad to be closing out the day here. Thanks, JetBrains, for putting this on. It's awesome. I'm Daniel Ward. Yeah. I'm Daniel Ward. Like he said, I'm going to be doing a talk on xUnit. xUnit expanded better testing with xUnit. All the slides and the repo we're going to go through are at my website, daninthecan.com. So if you want to check out things afterwards, check them out there.
Sounds good. Let's give you the full stage, remove ourselves from screen, and then you're good to go.
Sure. All right. Awesome. So really quick about me, I've been in software about 10 years. I'm currently a software consultant at a company called Lean Techniques based out of Iowa. I've been there about a little over 3 years. I am the organizer of the very new San Antonio.NET user group, affectionately known as SAD Nugs. We will be having our first meeting sometime in October, so that's exciting. Like I said, you can find me on my blog, daninthecan.com, where I'm primarily posting about .NET topics. I'm on Twitter or X, Daniel Ward Dev, LinkedIn, also Daniel Ward Dev, but with dashes. Just an outline of what we're going to be going over so you can know what to expect. First, I'll cover why, my reasoning behind why I wanted to do this talk, what I hope people will get out of it. The libraries we're going to be going through, how xUnit does parallelism, how it executes your test. And then the coding demo, which will be the bulk of the presentation here. We'll go over some testing philosophy, naming, how to structure your tests, databases, a bunch of stuff, kind of hard to categorize everything. So let's jump into why. Everything is kind of, in this presentation, is kind of going to be based off this quote here, if you've heard it. Always code as if the guy who ends up maintaining your code will be a violent psychopath who knows where you live. So we really want this idea of, it's for future you also, although hopefully you're not a violent psychopath, that if whoever comes in and looks at these tests next, they will be able to easily see what's going on and make changes if they need to. So easily readable, easily maintainable. And it's definitely not hard to find opinions online about testing, right? Philosophy, cool new libraries or tips people found. But I kind of see it as you get a bunch of puzzle pieces, and until you've done it yourself through this learned experience of doing it yourself, and especially working on a team with other devs, you kind of have all these puzzle pieces, but not the complete puzzle put together. And even worse, especially if you're new, you have these unknown unknowns, right? So you might not even know that you're missing out on something because you don't know the terms to search for with it. And these are things that working on a team can bring you. I don't think this talk is a substitute for learned experience, but I'm kind of hoping to, especially if you're new to testing, give you a high-level overview. Here's like a screenshot of the complete puzzle, a primer with how I like to test. And if you're not new to testing, I'm going to have some more intermediate advanced stuff in here. So my goal is no matter what level you're joining, if if anyone watching, no matter the level, can pick up 1 or 2 things, that's my goal. I'll be really happy. The libraries we're going to be going through in the coding showcase are xUnit, bonus points if you guessed that one. In Substitute will be our mocking library. We'll use auto fixture for creating fake data for our tests. We're going to use a library called Richard Zalay, I think is how you say his name. Sorry, Richard. Mock HTTP for mocking HTTP clients. Fluent assertions to replace the normal out-of-the-box assertion library. It just reads a little more like English, and it gives you more meaningful error messages when something goes wrong. And I've put here in a bullet point this be equivalent to method, because I think if this is literally the only method this package shipped with, it would still be worth it. It has a very comprehensive object graph comparison. I've put a link here. Obviously, we're not going to go over this entire page. I just wanted to show you the scroll bar to show you how comprehensive this method is and how it checks equality. It's super awesome. For the most part, it's just plug and go. So, and finally, we go in over test containers and Respawn for integration testing involving databases. So one last thing before we get into the coding showcase. How does xUnit actually run your tests? So this is sometimes a need to know. Most of the time, it's more of a nice to know. So xUnit has this concept of test collections. And by default, every class is its own collection. And classes will run in parallel next to each other, but the tests inside of a collection will run sequentially. And you can have these concepts of shared state if you only want to do setup and tear down once for a bunch of things. If you're doing something expensive like a database, you have 2 options. There has something called class fixture, which does setup and tear down once for the entire class instead of for each test. And then it has something called collections, like I just said, that will do the setup and tear down once for the entire collection. The way you define a collection is just with attributes. You can do it arbitrarily, whatever classes you want. And then each class that has that same collection name xUnit will shove into the same collection for you. And these are, if anyone wants to go look at the slides afterwards, these are just 2 resources, xUnit owned docs on how that works. They're pretty easy reads, I thought. And it's pretty good info. And now let's just go into the coding demo, which is going to be pretty much the meat and potatoes of this. And the idea I did for this is kind of this fictional bookstore. And we're making an app for it. Probably have some kind of front-end website. And I'm leveraging, if you know what the Gutenberg project is, it's just this big online database of books, and it's all free. You can just go and download stuff. And there's an API that queries that. So I'm leveraging that. And we have this book controller here. It's got a method getBook. We're not even going to be testing this. This is just to give you, put you in the mindset of our problem space, really. And I've got him running here. Here's our Swagger page. Let's just give it an ID of 1, and let's get that book. It goes to the Gutenberg project. That happens to be good old Declaration of Independence. And you can see it gives us some other info, authors, subjects, etc. We don't actually need this project running for the tests, so let's close that down. And what we care about, what we want to look at is this book client that the controller is using. So let's go to look at this method here. And he's really not doing that much either, to be honest. He's querying an API. And then if we get an exception, the only thing we want to do is if it's a 404, we don't want to bubble up that 404. We want to return null instead. So that's a business decision we've made. So let's go look at the test for this guy. Books, book client tests. Here we go. So before we even get into the content of the test, there are a few things we can glean from this, right? The first one is just my method name. You see, when getting a book, returns successful response, then returns the book. And this is how I've been naming my tests lately, is literally just an English phrase and then replace spaces with underscores. I've also seen what I think comes from the Art of Unit Testing book, which is like unit under test, underscore conditions. So successful response, and then expected behavior, which would be returns book, something like that. I try to follow this given, when, then pattern, which you can see here. I just didn't really have a precondition for the given, but in my experience, this makes the test a lot more clear what they're supposed to be doing, at least. You can also take advantage of the display name attribute, and you can literally put in whatever characters you want in here. Spaces, special characters, whatever. I've started drifting away from display name because you still have to give your method some name, and then you have to keep these in parity with each other, so it makes sense. Bottom line, choose what your team wants to do as long as it's consistent. Have that conversation, whatever makes sense to people. We want to avoid the psychopath reading your code, right? The next thing is how I structure the test. So when I was first starting to unit test, what kind of made everything click for me is this concept of arrange, act, assert. And that's just how you write the test. So arrange would be, setting up any mocks you need, setting up any data like this, creating your system under test. And the next step, act, is often a one-liner. It's just running the system under test. In our case, that's executing the get book method. And then the last step is assert, which is just saying, I'm making sure that thing I expected to happen actually happened. And here in my assert, I just have an example next to it of what the out-of-a-box assert looks like. So I just like the way this reads better. Obviously, it's not a requirement to use fluent assertions for testing. I think it helps with finding out what's going wrong with your test too with its error messages. So one last thing before we actually get into what this test is actually doing is how I've named my variables here. So I am making a random book, and I'm calling that expected book, right? And then I'm making my system under test with the HTTP client, and then I'm actually running it, and I call that actual book. And down here, it reads really nicely. It's like expected should be actual. And sometimes you'll see these just called expected and actual. But what I used to do, and what I see a lot still, is I would just call this book. And I would call this maybe, result or something. And this test is simple enough that I can reason my way through it pretty easily still. But that isn't necessarily always the case. And if I see this up here at the very start of the test, and I see that word expected, I know that that's basically like, oh, the entire test is going to depend on this variable, basically. It's hinging on this. And this kind of helps put my mind in the right space. And then when I see this with the word actual, with the method run next to it, so, oh, this is the real system under test. This is what I got from it. And then when I see my assertion, it's very clear what's going on. So this is something that just seems really minor because it's not even a coding thing, really. It's just the English words you use for your variables. But in my experience, it makes a big difference in the readability and maintainability for it. Okay, finally, let's actually look at what this test is doing. So we're just creating, our random book, expected book, creating our mock HTTP handler so we can have a mock HTTP client, creating our system under test, getting the actual book that the system under test returned, and then making sure what happened is what we expected to happen. So I want to talk about HTTP client mocking now, because I'm going to go over a few different ways to do this. This is maybe the most common one I see, is to create your own custom fate class. So here I've made my mock HTTP message handler. It is an HTTP message handler. And there's really not much going on here, right? I give it a status code and the response content. And whenever Sunday sync fires off, it just spits those out. No logic, really, but it lets me have a runnable test. And that works. Possible downsides to that is I need to create my system under test in every single test, right? Because I'll probably need different values for the message handler per test. So that's kind of annoying. It's more boilerplate code. It's also less extensible. If I ever want to do different things, I'm probably going to have to create different HTTP handler mocks. And if I just want to add logic inside of it, it's sort of brittle, right? So it works, but maybe we can do better. So to look at that, let's go to the next method here, which is also for get book. just verifying that when we get a 404, we do get a null response. So these are extension methods I've made, and I'm just going to spoiler you. I don't recommend you do it this way. So here are the extension methods I've made. If you've ever tried to mock set up send async, you have probably discovered that it's protected and you can't do that. Well, you actually can do that if you use reflection like this. It's very ugly. The advantage here is that now we do actually get to check, that it was called with the right method, and that we actually get to check that the URI was correct. And then I have this other extension method that, it'll spit out any response content we want per test. So that is at least an improvement, because we can create our book client in our constructor now at least. And we can even say with this third extension method, hey, you should have actually received this method. And that utilizes the received calls method from xUnit. In substitute. Again, this is not my recommended approach. It is a little cleaner maybe in your tests compared to a custom class, but you have to copy paste this into every project. To be honest, these methods are pretty ugly, right? It's going to be hard to extend these two. It's probably going to be hard just to sort of understand them. So let's go down to our third test here to see the way I do recommend. And this one is for a different method that we'll look at in a second. But this is using that Richard Zalay, his mock HTTP library. And it's really simple. It has this mock HTTP message handler class. Just new up one of those. I'm doing that here in the constructor, and then creating my book client. And then it's basically got those extension methods I made. It's all that in the library already, and a bunch more. So there's a bunch more options in here for you to do if you need them. So I'm saying I expect this get method with this URL to be called. And when it does, return an OK with this JSON response. And it just works. And the best part is this expect will actually make my test fail if this wasn't hit. There's also a .win if you don't want to do that, but I like that about it. So this is the way I do recommend. It also is agnostic of what mocking library you're using, so you can carry it over to different projects no matter what it's using. It's pretty great. So now let's actually look at this new method. It's running this get books added in month test name, calls endpoint with date range from given month. So into the book client, let's look at get books added in month, and it takes a month, which is an enum I've created, so you can only give it valid values. And then all it does this get date range extension method that I've made, and it sends that into a URL. All that extension method does is basically it calls the days and month from date time, because that's a variable amount depending on the month. And it returns the start date and end date for the month. That's it. And then it'll pass those to an API. Now, for the test, I can tell you here, because I wrote it, that this is a flaky test. So something Writer has for flaky tests, if you've ever run into that, it's extremely frustrating where it passes locally. And then just every once in a while, it fails in your pipeline, and then your pipeline breaks. It's very annoying. If I go to the test name, integration tests, here we go. I say calls endpoint with date range from given month, and I right click on that and I say run selected tests until failure. That is pretty much what it sounds like. It's just going to run that test over and over until you click the stop button or until it fails. So I'm not saying it's a perfect solution, but it is way better than guessing and running it manually every single time until it fails. So we can see here, it finally did fail. And it's saying month must be between 1 and 12 at this line. So, I know what's happening. It expects a value between 1 and 12 for this, but enums in C# start at 0. So I actually have 0 to 11. So if I got unlucky and I passed in January, it would fail. So all I need to do to fix that is this. and then it'll work. But that is a good segue into my next point, which is why, if it's not extremely hard to do, I prefer using random data in tests. I know there are some that probably disagree with that, so let me try to defend myself here. If I had not used a random month for this test and I just chose June, for instance, the test would have never caught this bug. And it doesn't catch it consistently since it uses a random value, but at least it has a chance of catching it. If I had just stuck with a static value, I would have only caught that bug in production. So it kind of gets into your tests sort of become fuzz tests at the same time. But with AutoFixture, it's so easy to do anyway that it's usually not an issue. And especially with things like Booleans where there's only 2 possible values. If I see AutoFixture create a value, I know it doesn't actually matter. Where if I see someone say like, assign something to false, I might think until I go through the test, oh, that actually needs to be false. So if at all possible, I do like using AutoFixture for that. And this is just another example of why I like Fluent assertions. If you were using the out-of-the-box assert library here, it would not be able to do this because this is a list of objects. So it would not be able to compare those 2 things. The Fluent assertions be equivalent to can still handle that, no problem. So awesome. Let's go to our next method here, which is for upload photo, I believe. Yep, upload book photo. So let's look at him. Maybe we decided we want to add functionality to upload photos to our book website. You know, it's pretty popular for like when people are leaving a book review, they can upload a photo of the book or something. So we want to do that too. So we're just passing in the file name of the photo and the photo data. And the only validation we're doing, we're saying if the photo is bigger than 10 kilobytes, we're going to kick you out. So that is questionable usefulness for a photo, but you know, that's the requirements we got, so we got to go with it. And it has to be one of the valid file extensions up here. And if it's not one of those, JPEG, JPEG, and PNG, if it's not one of those, we're going to kick them out again. Otherwise, we just forward it onto this API. So let's look at those tests. I want to showcase here a library called xUnit.combinatorial values, just because I don't think it has, I don't think it's very well known. So what this one test will do is run 9 tests total. So if you remember combinatorial from your maths class, pretty much the same thing. It'll run JPEG with these 3 values, JPEG with an E with these 3 values, and then PNG with these 3 values. So it's going to run every possible combination of them together. And let's just see that in action real quick. And you can see an arrow opened up there. And it'll actually tell you which value it ran with on which run. So if one of them fails, you're not left guessing like, oh, which values was it? And you can drill down into that. We look at the failure test here. I have 2 other tests for it that are pretty much the same thing. These are just the SAD paths. These are using invalid file extensions. This one's using invalid file sizes. The only thing I really want to point out with these is how I'm asserting on the exceptions. So you can see I'm saying it should throw an argument exception with this specific message. So I don't actually care what this message really is. The only reason I'm checking it is because I want to check that a specific exception was thrown. So in this method, I can throw argument exceptions for 2 reasons, right? So if the file extension was bad, I want to make sure I'm not throwing this one, right? I'm throwing this one. So this just makes super sure I'm throwing the exception I think I am. And that's also why I'm checking specifically an argument exception instead of an exception, because you could have the case where you have a passing test because you just said exception, but it's failing for a completely different reason than you thought. So it's a bad test. So these 3 tests altogether will run 27 tests total, right? Which would normally be completely overkill to do all that, but this library just makes that so easy that it's worth the trouble, you know? I will caveat this and say, if you find yourself needing to use combinatorial data to test your code, that is possibly a code smell. Maybe take a step back, say, is there a way I can refactor this so I don't need to use this anymore? I do think it has a use case, but just make super sure that you're using it right. And I believe that's it for book client. We only have 2 more methods for unit tests I want to go through. And so now I want to go over to file line parser. And I think probably most of us have been in a similar situation. We are getting an export every month from another team, and let's say it's all the books we got in our catalog this month. It's a CSV, and we need to parse it. And for some reason, they've decided to put each line in this format here. We don't know why. Maybe they're the violent psychopaths, right? But we need to parse it. So there we go. And we're doing that here. I'm not going to go through each line, but we're parsing the book name, each property out of it, and then we return a record at the end. And this concept of string parsing, massaging can kind of prevent all the same problem of how do we make sure we're covering all the branches and not make our test suite completely awful to read? Because if we wanted to be super sure, I guess we could split out into its own service, parsing the different values. We could have a language parser, a year parser, an author parser. But how many would we have for that? We'd have 1, 2, 3, 4, 5, and then 6 for the parent. 6 services just to parse each line, when each one of those services is probably going to be like 5 lines of logic. It just seems like you get into abstraction hell very quickly with that, right? So what I like doing with things like this, and with regex, by the way, let's go into the file line parser test here. I use theory data. So to look at how this is working, let's look at the test here. You can see it's a theory, and I'm saying member data, name of, and then whatever I name the variable, in this case, happy test cases. And you can put as many types as you want here. They just have to line up with the parameters in the test. So in this one, all I'm saying is parse the line from that theory data, and it should be the expected record also from that theory data. So, for example, this first one here, this is a pretty well formatted line. This is what you expect to see from that file. And this is the line data I would expect to get back. The second one, I threw it a little bit more of a curveball, made sure it will trim the book name, made sure it can handle hyphens and periods and empty values for some of them. I say, okay, well, this is the record I should get back from it. And then in the sad test cases, collapse that. These are all ones that'll throw an exception. So I just need the line. And I kind of put the test case in the line itself. So like book name without a closing bracket, line with too many semicolons, line just missing data, and empty string. These should all fail. So I still get to test a bunch of my branches, but my tests aren't completely unreadable, right? And I'll run these 2 here, just to show you what they look like in the test runner. And you can see they do the same thing as that combinatorial data. It shows you which values it ran with, so you know if one of them failed, what you need to do. You'll also maybe notice all the values in my theory data are static values. If you want to have non-static values, they have another thing called class data that you need to use. Pretty much what it sounds like, it's a class instead of a member in your tests. So on to our last method here, which is lottery service. So let's say we wanted to implement this cool feature on our website where there's a raffle every month. Speaking of raffles, right? Where everyone who has purchased books on our site each month is entered. And the more books you've purchased, the better chance you have at winning. So all we do is we get their books purchased and throw that into an API, and it gives us back a lottery number. And if it's this winning lottery number, which happens to be 1, 2, 3, 4, 5, 6, 7, 8, 9, then we return true. So that's it. And let's say we only want to count books that are copyrighted, because if a book isn't copyright, that means it was free. We want to encourage purchases, so we're only going to count copyright books. So let's go into our test for that. When lottery number is the winning number, then it returns true. They won. So how I'm doing this is I'm creating several copyrighted books. I'm creating one book that isn't copyright, and then I'm slamming them all into the same list. And then I'm saying when process purchased books is called with any IEnumerable book, it returns the winning lottery number, and it just makes sure that it's true. So let's run that real quick. And we can see it worked, it passed, but it actually shouldn't have. Our code was wrong, and our test still passed. If you noticed, we only want to include copyright books, right? So what we really want to do is this, right? Ignore the books that are not copyright. But we didn't have that in there before, and our test still passed. So it's a bad test. So why did that happen? And the reason that happened is because of this arg.any here. We're saying when this is called with any enumerable of book, we're going to return the winning lottery number. Really, since we're passing in this all books, which has a non-copyright book, what we really want to make sure is that this was called with copyrighted books to make sure our logic is working correctly. And the reason I think people shy away from this is because, admittedly, doing an arg.is of a list of objects is completely awful. It's ugly, takes forever to do, it's long, it's not fun. So it sure would be nice if we had some method that had a massive object graph comparison with a really small scroll bar that we could leverage. And oh wait, we do. We have the one from Fluent Assertion. So maybe we can make use of that. So let's go back into my in-substitute extensions here. I'm going to show you what I've made here. I named my class arg_is. The arg class is static, so you can't extend it, unfortunately. So I was a little cute with my name here because arg_is still reads very closely to arg.is, right? Okay. So we're going to be using this equivalent to method in here. And you can see this is actually using an arg.is inside of it. And in the Lambda, we're calling this matching assertion here. And you don't have to understand this right away because this involves some Fluent Assertions knowledge. So go back and look at the repo later if you need to. But this takes just any action. We'll create a new assertion scope inside of it, run that action, then return basically just if there are any Fluent Assertion errors. So we're going to say in here, it runs that matching assertion method. And then there, we're going to run the should be equivalent to. So again, this is kind of a lot to swallow all at once, but let's see what that looks like in practice. Actually, let's comment this out so we have a comparison. So this will become arg is equivalent to copyrighted books. And now let's try that. And that passes. But to really do a good test, we should like throw all books in here. And now it should fail, right? Because it's not being called with all books. We're filtering out the non-copyrighted books. So let's see if this fails just to make sure our method is working right. And it does fail. So awesome, it works. So if you ever have really hard arg_is checks that you need to do, this is a very helpful little trick. And obviously you can make, this is extensible, right? You can run other Fluent Assertion checks in here if you want to. So this second test in here is not really anything new. It's just testing the sad case. So let's close him out. That's it for the unit tests. The last thing I want to go over in here is the integration tests using a database. So let's look at our database, which is super simple for this project, pretty contrived. All it has is book likes and book reviews. So book likes, all it is, you know, a user can go in and like a book, click the like button. So all we save is the user that did it and the book they liked. And book review is almost the same thing, but we have the content of the review as well. So those are our only tables. What I really want to showcase here is two libraries, test containers and respawn. So I'm not going to go over how to set up a web application factory for integration tests because there's a bunch of resources for that online and that would take too long. But what I see probably is the most common thing to do, and what I used to do for a long time, is you either use the AF Core in-memory provider or the SQLite provider, which I think Microsoft themselves even recommends you don't use the in-memory provider except for like overly simple situations. So probably the SQLite provider. But with any kind of sizable project, what will probably happen eventually is you'll either get false positives or false negatives. So let's say you're using SQLite in your tests and you're using Postgres in your real production database. You might get all your tests passing, but then there's a little difference between SQLite and Postgres, and something that the same production code doesn't work on your Postgres database. Or you can go the other way, that something in your test fails, but it's actually fine on Postgres. And if you've ever encountered these are extremely frustrating to figure out what's going on and to debug it. So the optimal thing to do would be is if we could set up like the real engine in our tests, an actual Postgres, in this case, database, and then run our tests against that. So the classic problems with that, right, are that takes forever to do, number one. Number two, if you're using the real dev database, you have to make sure to clean your data up and all that stuff. And if you fail to clean your data up, then your tests on the next run might fail, and it just gets ugly. So this library called test containers, it supports a bunch of engines at this point. I'm using the Postgres one. You can see I'm making something called a Postgres SQL container using a builder. I just give it some things like the database name, username, and password. Here I'm telling it Postgres has a built-in method called PG_IsReady, which is pretty convenient. It's basically exactly what we want. It won't return true until the database is actually ready to be used. So I tell it to wait on that. And I tell it to build. And down here in my initialize async, I tell it to start. And I'll have Docker up and running. This will actually create a Docker container on my computer. So you need Docker to run it. And the same thing for your pipeline. And it will create a Postgres database in that container, and my tests will run against it. So let me go to my book-like tests here. I'll run them and open up Docker Desktop just so you can see. Give it a few seconds. So this reute container is like the manager container for all the other containers it creates. Here's my actual Postgres one. The tests are done running, so it deleted it. And pretty soon he'll delete himself. It just takes a little longer. Now, close these down. Got my integration tests. What you may have thought when I was explaining that is, how do you handle the state bleed between tests? Right, as an example with my book-like tests. This guy runs the like book method, which all he does, I don't know if I ever showcased this. He checks to see if that book like exists already. And if it does, he doesn't do anything because you can't like a book twice, right? And if it doesn't, he inserts it into the database. So in our test, if it doesn't exist already and we like the book, then it should be in there, right? So this test will insert a book, but that will mess up this test because he tries to add a book already, because here we're trying to test the logic that it won't add an already existing one. So that's an example of some state bleed between tests. So how can we make sure that doesn't happen? And the answer to that is another library called Respawn, which is by Jimmy Bogard, who's the guy who made AutoMapper and Mediator, if you've used those. And it's also pretty simple. Up here, I have a respawner object. In my initialize async, I say create async. The way respawner works is you kind of create checkpoints, and then you can just go back to those checkpoints in your database. So what I'm doing is I'm just when the database is empty, and I'm resetting back to that at the end of every test. So that sounds slow, but I'll run the whole suite in a moment and show you that it's not. So, and then at the end of every test, I am using this reset database method to call respawner reset async. And that's it. That's pretty much it. So here's a good example, actually, of collections in xUnit. So because this database test collection is an iCollection test fixture, I'm naming my collection here. My book-like test also uses that name. So do my book review tests. So this setup only happens once for my entire suite. I'm only making that PostgreSQL container once. So let's just run the entire suite, which will run the book review tests as well at the same time, and see how long it takes to both create the container with the PostgreSQL database and reset the database after every single test, right? And I've got other stuff going on my computer. I'm sharing my screen and all that. So it took 733 milliseconds total to do all that, which is pretty darn good in my opinion. Most of that is overhead, right? It seems when I was running this before, it seemed like maybe 500 to 700 milliseconds overhead to start that container up. Respawn itself is pretty quick. So this is just, you get more confidence with your tests when you're using databases. You're using the real engine. I realize with test containers specifically, this might be a little bit of drinking from the fire hose, but like I said, the repo is out there. So hopefully you can glean some things from that. And I believe that's it for the coding showcase. Me back here. Got to go through all my slides again now because I closed it down. Okay, so recap, went through how xUnit executes your test, right? How it does different orders. We went through a few different libraries and why you'd want to use them. Some of the patterns and like testing tips, I guess, philosophies I've picked up that I found helpful. I don't want to make this come across as like, this is the way you have to do it. It's more like I've tried a few different ways and here's the way I've landed on now because I think it is cleaner. We went through combinatorial data, theory data and class data, the be equivalent to from Fluent assertions and how you can leverage that for in substitute. And then finally, integration testing with test containers and Respawn. So that's it. Thank you. And thank you, JetBrains, for having me. There's my social information again. I think we do questions now. JetBrains people, correct me if I'm wrong.
Yeah, we can definitely do some questions.
Yeah. But, you might be over, so sorry.
No, we're not. We got plenty of time. Again, you have the benefit of being the last.
Right.
So
yeah.
We could stay here all night. I mean, Martin's gotten in his pajamas. We're ready to go.
Colin told me before this started they were saving the best for last. That's why I'm here. So.
Yeah, it's funny. Martin and I, at least 3 times during your talk, said, today I learned. So
awesome.
We learned about display name. We learned about that combinatorial values attribute, which is super cool.
Yeah.
And assertion scope. So those are 3 things that Martin and I learned about today, which is really cool.
And also in practice, I think the use of actual and expected in the variable names in tests is something that I will be adopting from now on. I typically use something like result and things like that, but actual sounds way better because it's exactly the same as what you would get in the assert methods.
I take royalties on that, so just saying it, just a warning.
The check is in the mail, Daniel.
Yeah.
It's in the mail.
Cool.
I have a question for you. You jump between integration tests and like mocking. Like, in your opinion, when do you decide to use one over the other?
So I do both. I try to cover the testing pyramid, right? I still might use mocks in my integration test. An integration test to me doesn't necessarily mean I'm using the actual dependencies. It just means I'm integrating multiple units together for the same test. So I might use mocks. I might not. It depends on what gives me confidence and how awful it is to write it, honestly, and read it. So
okay. Yeah, I guess that makes a lot of sense. I mean, I think the like follow-up question to that, I'm guilty of doing this. I think every developer who touches a mocking framework is guilty of doing this. But like, how do you make sure that your unit tests actually test something of value? Because at some point you could mock away everything and be left with a test that's like not doing much for you. So how do you keep yourself from like going mock crazy?
Yeah. Typically, I try to mock those. The only real code I want running is my system under test. I don't want anything else causing the test to fail. So if I have to go mock crazy for that, that probably means my actual production code is kind of messy. Something in there, a lot of dependencies or something. I shouldn't have to go mock crazy for a test, right? That might be pointing to a design issue. So
yeah, that's this is a great answer. Martin, do you have any questions?
Yeah, we covered a little bit about testing with data. So for example, the combinatorial values, the use of custom data that you inject into tests and so on. Do you see any mistakes that folks typically do when they are writing their test suites?
I've seen a lot. I've seen people mock the unit under test before. Don't do that, obviously. I have seen pretty much everything I could think of. I tried to put in the presentation, to be honest. Like variable names, honestly, is a big one. If I look at this, and be like, what the hell is this doing? A big reason is the variable names. Especially if you use like abbreviations and stuff. I very much favor long names that describe what it's doing over abbreviations that is a mystery. Yeah.
So I have another question for you, Daniel. You mentioned 10 years in .NET. You said you've seen things. You also mentioned you work with potentially a lot of psychopaths that are out to get you. So I'm worried for your safety. I want to put that out there. If you need help, just give us a call. We'll come help you out. But
well, I've been a consultant the past few years, right? So you have to be a psychopath to do that anyway. So it's not so bad.
Yeah. But I guess the question I have for you with those 10 years of experience, have you found .NET has gotten easier or harder to say unit test or integration test? And what are some kind of notable areas of .NET that you feel have maybe gotten better or worse?
So I will say I was definitely not doing testing for all those 10 years. So I can't talk for all of it. But one specific thing that comes to mind is records. So records use value equality for checking. So you can use like argis for them and it'll actually work. So you don't have to do any tricks with that. That's definitely something. I don't know if this was always around, at least it was just not the knowledge I had how to use HTTP client correctly and like inject it or maybe use a factory. That's gotten a lot easier, at least since I started doing it the correct way with typed clients. And I find that lends itself to testing very easily. Yeah.
Yeah, I mean, maybe Martin can kind of chime in on this because he manages a website. When you're writing unit tests, another big thing from a long time ago was HTTP context, which kind of has a similar profile to HTTP client. And I've seen a lot of people and personally tried to mock that out. And yeah, that has a lot of properties. Like, Martin, do you have any experiences trying to do that?
I have traumas from trying to do that. I don't have experiences.
Yeah, the scars run deep with trying to mock HTTP context.
Yeah, we just got a new question in the chat, and I actually think that's a really interesting one. When do you start conducting or when do you start writing tests while you are developing? Do you do that while you are still implementing the codes of the system under test, or do you wait for it to stabilize a little bit and maybe even wait until the development of certain parts is completed before you start writing unit tests for them?
It's a really good question.
Yeah, that's an awesome question. This is one of the things we try to. We don't push it on people, but we at least try to make them aware that it exists as TDD and the red-green refactor. So like that's the goal, right? Sometimes you're not going in greenfield, but if you have that advantage, I start writing the test before the code is written, right? So you start with the test should fail, then you go write part of the real code that makes it pass. Then you run your test and keep adding logic that way until your requirements are complete. And this gives you the advantage of you can keep the tests around for regression purposes, right? But also, the other big main reason you do that is for design purposes. TDD is some kind, it's called test-driven design. So you're more, I find in my experience, you're more likely to end up with code that doesn't lead you into mocking hell when you do that. Because really all the test is doing is forcing you to consume your own library, right? And if that's hard to do, maybe you need to refactor anyway. If you don't have the advantage of going in on a greenfield project and there's a bunch of code with no tests already, that's harder. You try to do like some black box testing then, which would be where you go in and write a test. You say like, I don't know what this method does, but I know when I give it this input, I should get this output. And if that ever breaks, you at least have some form of regression testing. And you can just keep improving that as you go. So.
Yeah. I mean, a good follow-up question to what our chat has asked is like, obviously when we're writing a test suite, when we start out, we kind of don't know how our systems are going to evolve over time. And the business context and the solution context changes. How do you and your team decide like these tests are valuable, these tests have kind of like outlived their usefulness and maybe are brittle or a burden for our team to maintain? Like, how do those conversations happen within your team?
Yeah, that's a good question. Typically, the tests that are usually brittle in my experience are the integration ones. Unit tests should be pretty like you get the same output for the same input. Unit tests, unless we delete the real method in the production code, we typically never delete a unit test. You can at least keep it around for regression purposes, right? If you introduce new changes and those tests break, maybe you did something wrong. And if you hadn't kept those tests around, you wouldn't have known. We also keep the tests around for documentation, right? So like the tests have real English names of what they should be doing. So that tells us like, was this code actually put in here on purpose? Like I can't actually tell what this is supposed to be doing. And it's sort of like a massive README for the project, right? Is all these test names. Lets us know that it was intentional and it's supposed to be doing this thing. And maybe it's not, maybe it's breaking, but that lets us know. Sometimes you do get brittle tests, especially with integration tests. And you have to weigh your confidence, I think. If taking that test out breaks your confidence in pushing to production, then maybe you need to refactor the test or refactor the code instead of removing it. If removing the test doesn't change your confidence in production, in releasing to production, then maybe it's a test you don't need, right?
Yeah, that's a really, really good point. So yeah, I mean, I guess that's the whole point of your talk, right? Like tests are about the value that they give you and your team and the confidence of like shipping quality code to your business and to your end users. So yeah, that's a great answer. So on that note, Daniel, this was a really great talk. Martin and I definitely learned a couple things, right, Martin?
Absolutely.
Yeah, absolutely. Yep. So on that note, we want to thank you. Thank you for closing out JetBrains.NET Days with us. And hopefully
thanks for having me.
Yeah. Hopefully you submit for next year and hopefully see you again. So
thank you. And to everyone, please add me on the socials if you got something out of this. I think it'd be awesome to meet people from here. So yeah, thank you.
Awesome. Thank you, Daniel. Have a good day.
All right, Martin.
All right. that was the last session. So what do we now, right? What do we do now, right? I think we still have a couple of licenses that we can raffle out. So for those people who are still in the chat, let's maybe play a game of winning one of 2 .ultimate licenses. You want to kick off with the first raffle question?
All right. Get ready, folks. You might have to Google it. You might have to look at some JetBrains products. Just giving you a little heads up here. But this one should be pretty easy. It's going to be about speed. So what is the next stable /release version number of JetBrains Rider. So go ahead. Let's see. Let's see if people know this. No.
Another release number. Yeah.
Oh, there we go. So Mr. Prometheus with numbers in their name definitely got the first one. So please email us. We'll put the email in the chat, and you get a license, I guess. So Martin,
fantastic.
I did one. What question do you have? So get ready. This should be a pretty straightforward one if you were paying attention, but Martin, go ahead and ask it.
Yeah, this is definitely going to be an easy one. If you have been watching Daniel's talk before, what was the lottery number that Daniel has been using in his talk in one of the unit tests?
Let's see. I'm curious if people are paying attention. Ooh, there we go.
That was really fast.
Yeah, Jason Miller, you are the winner. Man, a lot. You know, I'm really happy. Chat is like the folks watching are really paying attention, or they're just copying what the other person. Either way,
whatever it is awesome to see so much activity in there. So thank you people in the chat for making our day as well, asking lots of questions, looking into giving comments on the talks, enlightening us about things that we didn't know or that the speaker might want to look into. So thank you for that.
Yeah. Yep. So maybe as we close out, Martin, first, let's thank all of our guests this year. Like just awesome talks. Every single one of them, I learned something new. So that was great. I want to thank you, Martin, for being a guest host with me. I want to thank all the other advocates, Matthias, Rachel, Matt, and I guess I can thank myself. No, that's kind of weird.
You can thank yourself. Let's do this.
Okay. All right. Thank you, Khalid. You did a great job this year.
or I can thank you. Thank you, Khalid, for hosting this one as well.
Oh yeah, that's a good idea. And I want to thank the JetBrains team that helped us put this together. They did a great job. And most importantly, Martin, I think you and I should really thank the community that kind of tuned in and makes JetBrains a really kind of special community of people that come together and share this kind of stuff. So it's been pretty awesome.
Exactly. So all that's left to say, I think, is I hope we get to do this again next year. And I hope to see everyone who has been here the past 5 times will be there for the 6th as well.
10 times, Martin. 10 times. Bye, everybody.
Take care, folks. Bye.
Wow.